Good morning, everyone. We are slowly trickling in physically, but of course, virtually everyone's always very punctual. So just so that we keep to the proper schedule and respect those who are awake and ready for another day of exciting talks online, we're going to get started. So I'm Michael Barngrover. I'm the Managing Director of XR for Europe. I'm very happy to make the introductions on the second day, the very first couple hours of the second day's talks. So our first speaker is Oliver Canepe, who is the director of the Virtual Medicine Center. He's based in Geneva. He'll be talking about his medical research that he's overseeing and is personally involved in, and talk about the Virtual Medicine Center itself and its impact as it's embedded very closely with patients and physicians. So Oliver, please take it away.
Thank you for the introduction, and thank you to those of you that made it out here this morning. Also, thank you to Art and the organizers for the invitation. I'm very happy to be here. Like Michael said, my name is Oliver Canepe. I work at the Geneva University Hospitals, and 2 years ago we set up the Virtual Medicine Center. I also work as a scientific coordinator with MindMaze today, but there's no conflict of interest. I'm not trying to sell anything. It's more on an R&D basis. So let's see if I can... I think the clicker is not working yet. I assume it's just the green. There we go. Okay, cool. So I wanted to start out. It was actually great that we had the presentation yesterday morning about this idea of body perception and embodiment, because my research background is really this sort of using understanding how the brain uses multi-sensory information to build a representation of our body. And then specifically, I'm interested in the sense of agency, so how we control our movement. And I'm showing this because usually when we use VR, or the advantage of using VR is that we can have these very controlled conditions where we can add some delays or mismatches. And we do this in a very controlled way. But this was a project that we did with the ZHDK in Zurich, the art school. And this was a bit to taking this to the extreme. So we had this immersive installation. My kids are there. And basically, this allowed you to receive feedback from your body. And instead of having a small delay, we could add up to 4 seconds delay. So at some point, really, you lose this touch or this link to your own movement. And we can play around sort of to see what it feels like when you sort of lose your sense of agency. And we also played a bit with sort of body distortion. So when you touch this, your hand will actually be larger than it usually is. So what I wanted to talk to you about today is a bit about this research actually on the sense of agency, and then how this translates to clinical populations, and ultimately how working over and over on this project with the hospital led us to create the Virtual Medicine Center. And so I'll talk a bit about this there. So I'll go from research to translation to a bit implementation. So I'll start out with the definition of the sense of agency. So Patrick Haggard said that the sense of agency is the feeling of making something happen. It's the experience of controlling one's own motor acts and through them, the course of external events. And I think that everyone that's working with VR is sort of very aware of this anyway, so this is the first time you put on the headset, you can actually interact in this virtual world. What I like about this definition is there's the aspect that is phenomenally thin. So generally, it's not like we pat ourselves on the shoulder every time we do something. It's a very sort of innate sense you just feel in control. And also he's saying it's something that we do, often we have movements that are automatic. But even though it's automatic and phenomenally thin, we still feel in control. But of course, this is all good and well as it works naturally. But there are some situations, I don't know, is anyone familiar with the movie Dr. Strangelove? So Peter Sellers' character here suffers from the anarchic hand syndrome. So he doesn't have a sense of agency over his own hand, and it keeps on attacking him throughout the movie, which is very entertaining here. But what you see for the sense of agency is actually it's linked to quite a few serious clinical disorders and conditions, and also to conditions that affect the motor system. So it's very interesting also to see how we can study agency ultimately to help the patients. One thing that I also wanted to say, where VR is interesting, is that quite often the sense of agency was investigated with little actions. So you press a button and there's a sound, you press a button and something visually happens, which is easy to let's say, set up an experiment, you have really cool studies, but a lot of the actions that we actually do are more sort of goal-directed movements. So I'm pointing towards, I'm reaching towards an object. And then what I'm particularly interested in is more continuous movement, like walking and breathing, so the cyclical movements that are semi-automatic. So we have control over them, but of course a lot of it is automatically generated. So talk a bit about those two. The sense of agency is also interesting, the link to sensory motor control, because there are computational approaches. I don't want to spend too much time on this slide. I think most people here are familiar with this idea of the forward model and the comparator framework. So the idea for our movement is that as we move, we have a prediction of our movement, then we receive the feedback, and then we can correct our movements, and this can also be applied, this model can be applied for the sense of agency. So we have an intention to act, then we receive feedback about what we're doing, and this is why we feel in control over movement. And the first person to sort of systematically change how, or investigate this sense of agency and what the limits are was Marc Jeannereau. And he had this really cool setup where basically participants' hand was hidden from view, and they were asked to draw a straight line from point A to point B. And then what they could do is actually, as you're moving, you can add a delay, a shift in your movement, and people would automatically compensate for the shift in order to reach the target. So the interesting thing was that normal subjects, so it's a healthy student population, appeared to be poorly, if at all, aware of the details of their movement. And unable to correctly monitor consciously the signals generated by their own movements. So people would automatically correct for this mismatch in the feedback, but they're not even aware of their correction or this mismatch. And during my PhD, I was working with Olaf Blanke, and then one of the questions was always, it's one thing, you know, if you're moving your hand and it's slightly in a different position of where you think it is. It's another thing if you're walking and your whole body is sort of somewhere else, and there's this mismatch where you're not just moving your hand with respect to your central frame, but you're sort of being displaced in space. And then what we used for the setup was this motion capture arena, so people were wearing this marker suit, and then we had a screen that was sort of, I think, 3 by 3 meters, or 3 by 3 meters, which had a life-sized avatar that will walk with you in real time. And then we had the same task, so we showed you a target. You could walk into that target, and as you're walking, we can actually deviate your feedback, so people have to correct for this. And then what we find is that we have, on the x-axis, you see the perturbation. So this is really a shift of up to 30 degrees. And in the dark bars, you have the movement correction. So what you see is that if we shift the movement 30 degrees to the right, people actually compensate for this. And also, if we don't have a mismatch in there, so they're very accurate at reaching the target. And the light gray bars show you the sense of agency. So again, if there's a control condition, there's no mismatch, people really feel, okay, this is my movement. And then as we increase the perturbation, we basically see that at 30 degrees, it really people know, okay, this is not linked to my movement anymore. And the interesting thing is always what happens at this 10, 15 degree, because there is a mismatch, we're correcting for it, but we're not actually aware of the mismatch or this correction, so 50% of the time. I thought I'd throw this headset in there too. Is anyone familiar with this fake space headset? So we used this in, when was this, 2008 maybe? So this cost about 10 to 15,000 euros, I think, at the time. It didn't have any tracking itself, so we actually created our own tracking, tried to calculate the center of rotation, because we thought we could do the same studies in VR, and then basically it just made everyone seasick, and yeah. But essentially we've been playing with the VR sort of since that time. So the other thing, like I said before, we have the button press that we can use for the sense of agency, and we started looking at these goal-directed movements. And then I always feel there's a bit of a bias, so if I press a button, I know there's going to be an outcome. Now, if I reach for a target, if I reach the target in the end, it feels, I'm going to say yes as well to my movement, because that was what I wanted to do. So what's interesting for these continuous movements is there's actually no goal. So here we had people walking on the treadmill, and then we show them feedback of their avatar, so they get feedback of their own movement, and we see again, does this feedback correspond to what you're doing? And then what we do is we add a temporal delay. What's interesting with locomotion is that it's a cyclical movement. So if you add the delay, if you make the delay big enough, you actually start resynchronizing to your previous movement cycle. And we did this initially for an auditory paradigm. So here people were walking, we put microphones on their heels, and then as you're walking, you basically hear your footstep through the microphone. And then what you can do is systematically add a delay in the feedback. No? So now your foot comes down, but it takes like 150 milliseconds before you hear the sound. And we again asked them, does this feedback correspond to you actually walking? And then what you can see is this cool sinusoid where people feel like, yes, this is my feedback. So on the left is sort of the real-time feedback. This is really my footstep. Then as you add the delay, it feels less and less like their own. But here, after a delay of 0.5, so 0.5 means that my right foot is down, but I'm hearing actually the feedback from my left foot. People don't distinguish between left and right, so we have this really cool synchronization to their own walking rhythm. And what we also saw, so this were people walking in the corridor, is that they actually adapt their speed depending on this delay. So there seems to be this automatic synchronization going on, where if there's a small mismatch, you try to sort of compensate for this. And so here we did the same thing visually. Same idea, we add the delay, we increase it. And what we see here is also that we have sort of the beginning of the sinusoid, but this, here at 650 milliseconds, that corresponds to one step, because visually left-right is clearly not what you're doing. So here, you actually have to wait for like a full gait cycle before you have this resynchronization. It feels like your own movement. And what we did see, even though people were walking on the steady speed treadmill, is that there's a small adjustment again of these movements depending on your delay. Yeah, so we have agency for synchronous feedback, and we automatically adapt our movements. So this was sort of work done mostly during my PhD, but we're still interested, or I'm still interested in this paradigm for many reasons. So one is we now went from auditory to visual feedback, and here we developed an actual feedback system. So the idea was that we can record your footsteps using insoles, and we can remap that to your back. So now it is literally a feedback system in that sense. And we can see that when we do this, we get the same effect. So people actually do feel like they're causing this feedback and it's linked to their movement. And the one reason that we're looking at this too is that there's research with Parkinson's populations that have non-motor symptoms that have a presence and passage hallucinations. So people, it feels like someone is walking behind them, coming up to them. So here we can use this approach to see if we can create the sensation in healthy individuals. Another area where we applied this, and we started this in 2018, before we knew how acute this would become, like a year and a half later, is that, let's see if this video works. Oh. Can you start that video by any chance? No? Oh, well, so imagine wearing your headset, you're looking down at your avatar. So what we did was we put a respiration belt on participants, and then we can actually animate their torso, their breathing with them. And the idea is then also for agents, for breathing, we have this sense of agency, and we see this modulation. So it's really, we have the sense of agency for real-time feedback or feedback that's delayed by a bit. And we always see this slight synchronization, which I think is interesting. And I'm curious, this is sort of an open research question, if this is something to do with syncopation. I don't know if there's any musicians here that know this sort of syncopation and beats. So there's some music that is known to sort of create this almost like motivation to move, and I feel like the synchronization might be tapping into this. And then the final study that was interesting that I wanted to present today is looking at the sense of agency, because now, we've spoken about all these different types of movement, different type of feedback. So there's this question, is this sense of agency actually really something that is linked to your effector, to your body part, or is it something like a general mechanism? So what we did here is to design a study that we could do with the hand and the full body. So, but it's a similar paradigm, so you can move the joystick to one of the two target areas, and we can introduce these mismatches. And then on the right here, we have we built a human joystick. So this is actually like a therapy tool, but it allows you to lean and come back to the center. So we did the same task, so asking people sort of if the movement corresponded to their own, if the feedback corresponded to their own movement. And what you can see here is sort of on the left, we have the movements from the hand. And we have the same movements also when we walk over ground from the original paradigms. And now we have the same thing for the full body. So you're quite good at leaning towards the target, and you can correct for these movements. And if we look at the agency thresholds, so at what point does this sort of feel like your own movement, and at what point does it no longer feel like your own movement? There's a strong correlation in participants that they have between their agency thresholds for the hand and the body, so which sort of suggests that there's a general mechanism that's responsible for all of this. Well, we did find that if you challenge the movement, I don't have enough time to go into the details here, this seems to change a bit, where you have to really focus on the details. But I think it's from my side, it's very interesting to see that, okay, there seems to be a general mechanism there. And this is also, again, like more of an open research question, because I'm really interested if this sense of agency relies on abstract motor representation. So I don't know if people here are familiar with this term of motor equivalence. So if you look at handwriting, for example, you can write with your, so I write with my left hand, but if you write with your right hand or your foot or your mouth, your handwriting actually looks the same. It's sort of tapping into the same motor representation. So in a way, this could be a first level of abstraction from the motor system. So that just sums up the first part. I think one thing that's very interesting, if you're an engineer working with VR, this means we can have some delays and we can have spatial mismatches in VR that our brain automatically corrects for. So if you're sort of working on a system that has delays, it's not so bad, because generally we like this feeling of being in control. So how does this translate to patients? How does this translate to clinical work? I just picked 2 studies now. The first one is just something because I was very happy we could do this, because once we started working on locomotion, we all said like, oh, at some point we should do this with sleepwalkers, because they're actually really good at walking. It's very automated. So we work with the clinic and the hospital in Geneva, and they sent some diagnosed sleepwalkers. So these were sort of late teens. So I think, I forgot the percentage now, but a lot of people actually sleepwalk as a child. So, but then after a while, this sort of stops. Whereas if you have diagnosed sleepwalkers, it's really something a bit disruptive to their life, because they will, get up in the middle of the night and sometimes leave the house and then do all sorts of things. So we're interested in seeing like, okay, how do sleepwalkers do this? Because if you do not recognize sleepwalkers, let's say, by their normal behavior, because there's nothing, no way to study it. So in order to be diagnosed with sleepwalking, you have to have these long, you have to go into a sleep lab, you have to stay there, and then you have to hope that there's actually like a sleepwalking episode there. So it's very hard to study. So we also ran the same paradigm. So it's like on the top left here, I'm not sure if that's clear, is with these spatial deviations. And if we just did the standard paradigm, there was really no difference between the controls and the sleepwalkers, which is kind of what we expected. But then what we did is we asked participants while they're walking to do a cognitive task. And this was counting backwards in steps of 7. So it's actually quite difficult. And what happens usually, which you can see in the control participants here in red, is that, so we have the walking speed here. They all walk at the almost similar walking speed in the single task condition. And now if you start counting backwards, what happens is it starts to interfere with this automated movement, and people become slower and slower. So if you work with clinical populations, they quite often they stop walking. And the first thing that we saw with the sleepwalkers is that it didn't affect their walking speed at all. So they're doing this task, and then they're just sort of kept walking as before. So that was really interesting. And then the second thing that we saw is that, again, if you look at the single task condition, there's really no difference between the 2 populations. But here, what happens with most healthy participant or healthy controls is that if there's a doubt about our sense of agency, so if there's a cognitive load usually that increases doubt, we usually say yes because we want to be in control. So actually the threshold in that sense is higher because we're worse at discriminating. And here we saw exactly the opposite for sleepwalkers. So, and that's, I mean, this is also something that is a bit sort of up for debate. Why this is lower? Does that mean they're better at recognizing this mismatch, or is it more that they do not feel connected to this movement anymore? But yeah, generally it's very sort of interesting population to be working with. And this is the first time we could show these differences in awake behavior. And yeah, so now to move something more, even more clinical, like I said, we had all these studies with the hospital. We had some studies with the pneumology department. And during the second wave of COVID, so this is the winter of 2020-21, there were the reports of, one was happy hypoxia patients. I don't know if people remember this. So people who their oxygen level was very low, but they never became aware of their situation. And what we had also, we had patients that were hospitalized and they were treated and they were cleared to go home. And they, even though oxygen, everything was normal, they said they still had this persistent breathlessness. So even though they were sort of officially healthy. So then we saw, okay, how can we now use VR to see if we can help them? One, to study this. Is this really something perceptual, that they're not aware of this? Or, yeah, sort of, and then can we help them to see, sort of, to normalize this? There's some work also by Olaf Blanke and Dan Adler, who's the pneumologist in HUG at the time, looking at breathing or agency for breathing movements using sort of illumination of an avatar. So what we did here is that we actually worked together with EPFL and then MindMaze, which is a spin-off from EPFL, to see, can we develop an intervention in VR that we can bring to the hospital in sort of an intense period for everyone. But so what we did, we used this old system now. I don't know if you remember these headsets where you basically had a mobile phone and you could stick it into the headset. We used a respiration belt. And then what we did is basically, as you breathe in, we didn't track this on the avatar, but we just changed the luminance again of the avatar. So as you're breathing in, the avatar becomes brighter. And as you breathe out, it becomes a bit darker. And this is sort of very intuitive, you know, that this is sort of your breathing feedback that you're receiving. And so what we found, and we can do a strict control, so we can give people the same visual feedback, but is no longer synced to their breathing, to see, okay, is this just an effect of, okay, they're in VR and they feel better, or is it really something, this breathing feedback that's helping? And yeah, I actually don't have another slide on this, but this is what we found in the end. So we gave this to participants for 5 minutes, and really in this synchronous condition, they felt like their breathlessness was improving. The case, and this patient was also interesting, was because he was actually in isolation for quite a long time. He also mentioned, so we put the avatar slightly off to the side so they could see a full body, but it's almost like it could be them, it could be somebody else. And then he really said that it was like the first time there was somebody else in the room with him, breathing with him, so it had also this sort of social component was very important at that moment. And so I think we already at that point talking to the hospital about creating the virtual medicine center, and I think this study was really the moment where then we got sort of more people on board because hospitals like universities move very slowly when you try to change the structure. So yes, so I have like two or three corporate slides from the hospital just because they look very nice. So I don't know how many people are familiar with the University Hospitals of Geneva. So it's one of the 5 teaching hospitals in Switzerland. So we have Geneva, Lausanne, Bern, Basel, and Zurich. And Geneva is like one of the biggest and oldest there is in Switzerland. What's also interesting is it's university hospitals, plural. So we actually have 9 hospitals and I think almost 40 sites in total. So it's also now working at the hospital is very interesting because it's no longer like one small research lab that you're working with, but you're working with more than 10,000 colleagues. So 2 years ago, we finally were able to open this at the Virtual Medicine Center. And here, coming from this research background, the idea was really, how can we help the hospital sort of promote this research, use virtual reality, augmented reality, and sort of flip the script. So now instead of the university trying to do research with the hospital, we can actually reach out to the universities, and we have the University of Geneva and EPFL right there that are involved. But then also just working with clinicians to see what is something that you would like to do in VR, and maybe we can set that up, or maybe someone is already offering a product there, no? And we're based on the 8th floor here in the Swiss Foundation for Innovation and Training in Surgery. So we started also looking at a bit this medical education in VR. But our three main pillars that we're working on is patient care. So again, how do we use VR directly with the patient? What can we do now? Clinical research is this COVID study is really more basic research. And then we have medical training. So how can we use VR for simulations, things also for de-risking some procedures, because VR is just like a safe place to fail, no? It's a bit like the flight simulators that we want to do with the surgeons now. So that was the idea in a way. And then since joining the hospital, the thing that became very clear is there's a lot of more fundamental work about implementation, about access to resources that is going on. So actually a lot of our day-to-day business is also just working on this implementation. And I have one specific example here. So I don't know if people are familiar with HypnoVR and Healthy Mind. So there are two startups, I think they're both French-based, that have a similar product. So it's really a medical device. And what they do is basically have sort of visual worlds that you can escape into. And then there's sort of a guided meditation or hypnosis track too. And people can use this, doing small procedures, or if you're on dialysis, so you're in the hospital for a long time, you can wear this and you sort of have this easy way to escape. And then what happens is that, so we have industry partners contacting us, but quite often it's nurses that actually say, I saw somebody at the hospital using this, or a friend of mine works in another hospital and they're using this. Or we have patients coming in, okay, I saw that you can use VR distraction. So we're talking to them, and then as I go to the purchasing department, say, so apparently people are using these tools, but it's not in the catalog. So where do I find out more? And then I talk to the head of the service, no? And it's always, they're very motivated against a university hospital. So I end up coming back out with research ideas and ethic proposals that are all very cool, but it became quite apparent that we actually have to centralize all of these efforts, no? And then once you do this, you end up talking to the IT service, because you want to see, at the moment, every HypnoVR has a specific headset that they use, and then Healthy Mind has their own headset. Quite often it's the same hardware, but because it's a medical device, it's a bit like thinking about Office. Instead of having all of your Office programs running on one computer, you have a separate computer for each Office program, so it's a bit of a pain. But of course for IT, it's difficult to integrate these, and then immediately you're also looking at having sensitive patient data. So we're talking to the data management, which means very quickly we're talking to the legal department. And I mean, it's a good way to sort of meet with everyone at the hospital. And so what we're doing now, and in one case, for example, we set up a collaboration agreement, and this then sort of gives us a legal starting point to do things like building a dashboard, so we actually know which service is using this, which patient is doing this. And there's a big internal communication there that we have to do. We work with the Innovation Center. We had some workshops where we say, okay, we can actually, so in some ways, protect our clinicians, so that if there's an industry partner, we can sort of help them organize, and we can meet them not as individual physicians, but as the hospital. And then, of course, the Innovation Center is always good for publications, and then we bring this out to the public, events as this one. But then the key thing is really for us is this idea that anyone in the hospital that sees VR, XR, AR, knows, okay, then they can come and talk to us about this. Yeah, I think that this is just a final note on the common challenges of this implementation. Is really that the technical integration is really difficult, because we have the public network and then the protected network with the patient data. So this is a huge effort to see, should we add any VR devices there? There's a mechanism for this. So I don't know if we have any industry partners here at the moment, it's actually worth the effort, because if you do it with us, you do it for 5 other big hospitals in Switzerland at the same time. And we're also working a lot with sort of existing structures in the hospital. So there's a big pain network. that has been there for decades, because any patient at the hospital, whatever their main reason for being there, they probably also have pain. So we're trying to see like how can we create the documentation so that everyone uses VR in the right way. And one thing that we're working on, which is another, I like to go into some of these things a bit naively because this is like a bigger effort, but the idea is like every patient that uses VR, we should be able to see that in the patient dossier and really track also what that means. Like, does it lower their medication? Does it lower the stay in the hospital? So this is all sort of long-term, behind-the-scenes sort of work that we're doing. So I'm not sure how I'm doing for time, but I think it should be good. So that's sort of, that's a bit the implementation part. This is working with medical devices that we're bringing into the hospital. But we're also still, like, I come from a research background, so I'm still very much interested in doing research, and some of it can still be quite applied. But this is a project that started with Bruno at EPFL. And has anyone used VR in an MRI? Anyone in the audience before? For like, so in cognitive neuroscience, there are 2 companies, I'll show them in a second, that make headsets that can go into the MRI scanner. And so the idea was, wait, if we're using this for research, we should be able to just use that with patients that have high anxiety or claustrophobia, no? Because I think 5% of the population really have claustrophobia, so they will usually have or would have a panic attack if they had to go into one of these scanners. So what happens is they have to be medicated, which then means it takes a long time. It's and not ideal to sort of put people under. But also, like in the general population, it's up to 40% of people that just get anxious. So that means they move more. The imaging quality, suffers a bit. So we said, let's run initially a study where we give people this VR as a distraction. But at the same time, so I think we're all familiar with creating one study, publishing this, and then we're all happy and we move on to the next project. So the real challenge is now to see like how do we actually change the clinical routine to keep using VR. So those are the 2 headsets that exist. I think they both, or each one costs about 80,000 euros or so, because there's just 2 companies making them in very small numbers. But what we did, so on the top, what you see is actually reconstruction of the scanner room. So we do something that's like a soft immersion. So people put on the headset, they lie down on the bed, and then when they look up, they actually see the same room that they're in. And I can show you a quick video here where on the right we have, so this is just a volunteer wearing the headset, and it's mounted to the head coil of the MRI. And then we have like red tennis balls on there so we can track the position of the scanner. And you can already see the patient at this moment is seeing, I hope this video works, is seeing the ceiling. There we go. And now as the patient enters the scanner, we actually play with the perspective as we slowly shift down. They can see their virtual body. And then, I mean, here it's a bit exaggerated, but the idea is that we can actually minimally track what you're doing, so it does feel like your own body. So, and the idea is here, we don't want to put them, into space. We don't want to put them somewhere into a game, because the idea is they're still in the MRI. They're not allowed to move. And in this way, they sort of are aware of the context. The French colleagues speaking. They're still aware of the context, but now actually the scanner is open, and you can watch a movie. And it's even sort of, if you try it yourself and you know what's going on, it just feels very liberating to not have the scanner bore in front of your face. And so we ran the first study, just sort of questionnaire based. I'm not going to go into the details here, but what you can see is like with VR, which is like the light blue, people feel safer, they're more relaxed, they're more confident, and similarly, they're less tense, not as frightened, and not as concerned. It was an interesting study to run, so we actually worked with claustrophobic volunteers, so not with patients, but people that came in from the outside. And what you see is like actually a lot of them will drop out if they can't use medication or they can't use VR because it's really that strong. We had one patient who couldn't go into the room with the scanner because already that was too sort of limiting, which is interesting now for the statistical analysis because people are just missing in the non-VR condition. Okay, and then so what we're working on now is, can we buy more of these headsets for the diagnostic department and really integrate this into the clinical routine? So this is the number from 2 years ago. So you saw, even though this was still sort of at the end of the initial pandemic, I don't know if we have left, but we had 24,000 scans per year. So if you think about 5% of those people having to be medicated and up to 40% of people moving because they're anxious, the idea is like this could potentially very quickly self-fund the money that you're spending for these headsets. Okay, final project I will talk about is education. So I mentioned we're situated in the Swiss Surgical Training Center, and working with all the clinicians, the medical students. And one of the things that we're really interested in is the OSCE. Do we have any MDs in the room or people working in the hospital that know what an OSCE is? Okay. So basically, an OSCE is an objective, structured clinical exam. And it's the most, let's say, complex exam that medical students do before they start working with patients. And the way it works is that you actually get to make a case file. You hire an actor. The actor learns sort of his case history, and then goes and plays the patient. And so in these OSCE exams, the student will then have a brief description, will enter a room that looks a bit like a normal doctor's office, and talk to the patient, do the history taking, try to do a diagnosis. But the point is that it's hugely complex. For the final exam, there's about 12 stations next to each other, so it's really 12 rooms, 12 actors, 12 doctors doing the assessment, and then all the medical students. And the final year version of this is organized locally or centrally by the IML, and this costs, I think, 5.2 million francs for a single sort of 60-year exam. And of course, during COVID, this also collapsed because you couldn't have face-to-face meetings, and also this is not something that you can do via Zoom or any other method, no, because the idea is really that you go and you interact with the patient. So this is a very nice collaboration with the Inselspital in Bern, the IML, which is funded by InnoSwiss, and we also work with Orama VR, which is a Greek-Swiss startup, and they have built an SDK that sits on top of Unity, and that basically allows you to more efficiently create medical simulations. So, and then together with this innovation fund, we basically help them improve the platform and sort of test out the limits of it. So this is another way to look at this OSCE is sort of going from on the knowledge triangle. So initially you have multiple choice questions, case presentations, so there's more essays, and this is really the first time where you can have clinical skills that you can assess. Okay, now I have one more video which hopefully works. So, and it's going to be, there's a lot going on in the video, so I'm just going to prepare this. So there's actually 3 screens. On the right side, you see Matthias, who's our VR engineer, doing sort of a speed run through this simulation. So this is not sort of the normal pace that you would do this. In the middle, we have automated assessment sheet. So usually the physician does all of this by hand. So now we are using VR and AI to do some of the grading. And on the left screen, we show you the sort of user interface for the moderator or the examiner. And then one thing you will notice right away is that we're more interested in the framework and the technology rather than being very precise, let's say, with the animation and having sort of super realistic avatars. The idea is really, can we do this? You can see as the student, it's actually in German, yeah, steriles Vorgehen. So the student disinfected their hand. What's cool is in VR that you can't do with a patient, actually if you look into the ear, you can show a healthy ear or you can show an ear that has been affected in some way. Same for the nose. So here the patient that was used for this exam actually had burns. So we can really show you in VR directly what the burns look like. We can also, if you listen to the breathing, we can show you whether or not the lungs have been affected. Yeah, we can switch these things. So it's not hyper-realistic, but in a way the current way when you're working with an actor is also not realistic, because if you try to do a medical exam, basically you will receive a sheet, and the sheet will say, this is what you now just found out about the patient. You can also see that the light actually goes through the skull, which is kind of funny. You don't notice initially when you're doing it because you're so focused on the eye. But yeah, so we're this work in progress. And like I said, so this is a bit the technical framework behind it. So at the moment we have it connected to ChatGPT, but it's just for parsing a bit the text and saying, like, did the student ask about the history? Did they do this? And we're also looking at other open weighted models that we can run locally. We're using Azure because it speaks Swiss German. So it actually translates, the transcript is in the High German, but you can also use it for voice generation. Yeah, Matthias and I did the mocap ourselves, so we're sort of very much still involved at every level. And usually I always say, like, I would like to give a demo, but at the moment those cloud services are linked to my own credit card, so it costs me every time I give a demo, so we'll have to make a local version first. And yeah, so we ran a first study on this summer, so this is a 2-year project. We're like 1 year into it now, and the idea was to have the study next year. But what's great about working with the IML is that, so they set up this exam for the final exams for all of Switzerland, but they have sort of intermediate exams just for the clinic in Bern. And so we spoke to them, and they actually gave us the exam ahead of time. So we had to sign an NDA, so because we know what the students were going to be tested in. But this allowed us to create really a virtual twin of the actual exam. And then we of course, cannot use it yet for grading the students. So the idea was that they all first took their normal exam, but then we can work with the same students to say, okay, now do it again in VR, and we can do a comparison. But yeah, it's not randomized, so of course it's not ideal. It's really an initial feasibility. And yeah, without going into too much detail, I think generally students were really appreciating this. I think that it was still a bit early for them to say it was strange if this is an exam. It's like, it's super useful for training because you can't usually, bring in an actor and just train with them yourself. But yeah, so some parts they really liked. I think this second part here, like the question on realism, is just, it's clearly not very realistic at the moment. It's also something that we just said it's not worth it on the research side to invest time and resources in. But yeah, so this is an ongoing study or ongoing project. So if you're interested, you have any ideas, please come talk to us. So we're a small group. We're still, everything we do is sort of project-based. So if we have a project that's interesting at the hospital, or for us technically, it's we will write more proposals and then bring in more people. So I left X a while ago because it was but so you can reach me on Blue Sky or LinkedIn, or you can find us online. Of course, all of this work is done by lots of very cool collaborators and people to work with. Like, so we have like EPFL involved, HUG, in the Spital, and yeah, our small team at the VMC. And with that, I will say thank you for your attention.
Yeah, thank you very much, Oliver. All right, we're going to transition to our next speaker, which is Keisuke Suzuki from the Hokkaido University. He'll be talking about his research into sense of presence. I'd like to remind the audience, both, well, I guess really just you physically, that questions will be during the coffee break, so you don't need to expect an opportunity to ask questions to the speakers as they're concluding their talks. If you're listening online, which I know many of you are, you should be here if you wanted to ask questions during the coffee break. So it'll be just a moment as we make the transition. All right.
Okay. Okay, thank you very much. And first, I want to say thank you for the organizer for inviting me, and I just flew from Japan a few days ago, so I'm still a little bit dizzy, so I'm sorry if I'm zoned out during my talk. So today I'm going to talk about basically reality and presence, and I'm a cognitive scientist, so yeah, some approach from like cognitive neuroscience, cognitive science, and also some computational approach on presence. So my background, I actually did my bachelor in physics and then moved to more like computational science, and specifically on like here, like artificial life, and then moved to somewhere for some reason like virtual reality and consciousness science. So last 10 years I was in the UK, in Brighton. I was working with the professor Anil Seth in Sussex. He's now big guy on consciousness science. And so most of my, the content of my talk is actually the work I have done in UK. And now I'm came back to, sorry, I put Sakura Center. I was there for 10 years. Now I'm back in Japan, and yeah, continue the research on virtual reality and consciousness, embodied cognition. So my area is artificial life originally, but also embodied cognitive science, and recently I'm more into like computational phenomenology. I will a little bit talk about this later. And then, yeah, topic I'm interested in is also really diverse, and yeah, as you see, like I did a lot of study on like, yeah, embodied self in virtual reality. But yeah, in my recent work is more on like hallucination delusion. So it's also related with like you know, the clinical, how to say, symptom. But yeah, it's going to a little bit get off from the embodied aspect of the consciousness to more like a visual aspect. Okay, so what is reality? I mean, I can maybe skip this part, but you know, it used to be like all the sciences on like a real, actual, you know, biological, natural stuff, but we now have all the AI, robot, and also virtual reality. It's kind of all used to be fake, but it's getting more realistic, and you know, nowadays, like especially like a language, large language model is kind of almost, you know, reaching the level of the human. But I think it's all coming to, you know, together. It's a fake, artificial, or like virtual is coming really closer to the real stuff. So then the question is, what is the reality? Especially like a more like to us, you know, it's not reality in the sense of ontological physics-based reality, but how do we perceive the real in our mind? That's my question. So the idea is going to this experience of presence. So I feel always confused between the concept of the presence and reality, but in this talk, I just keep using the word presence. So the presence, I think in like a casual definition is just feeling of your being here and now, like just feeling everything just happening right now. I think it is a bit more formal definition is, I actually like this one because it can be applied to physical reality, but also virtual reality. But this nice review paper by Felton and Jackson, 2021, said presence can be referred to the extent to which something, whatever, environment, person or object, whatever, appear to exist in the same physical world. And it doesn't need to be physical, but you know, in virtual reality, the observer and things, you know, seems to be in the same the world. And of course, in a real physical world, you feel you're here and with your body and environment. Anil Seth, my supervisor, he said, presence is somehow like a structural property of the consciousness, because it's not, you know, it's not about actual content of the, you know, you see an apple, but presence feeling is not associated with apple itself. It's somewhere in between your consciousness and external world. So it's more like a, you know, somehow, how to say, it's more like attribution to your consciousness itself. And of course, virtual reality, extended reality, we you know, try to simulate this presence in virtual reality. And sometimes, you know, yeah, like the talk yesterday, this place illusion, you know, people try to make illusion as if you're in a real world, even you're in a virtual environment. And sometimes I also like this definition. Sometimes they call the presence is like the virtual reality creating the illusion of non-mediation. So, you know, like when we immerse in a virtual reality, we need to wear the headset and, you know, stuff like that. And of course, when we are in a physical world, we don't really need any equipment, like any media to engage with the world. So I think the ultimate goal of the virtual reality to create direct experience, without any mediation between your sensory organ to the environment. Anyway, that's a bit too long to make an introduction, and then I'll maybe make it really quick, this one, but presence is also, big issue in like a clinical and what is called, psychiatry. And for example, depersonalization is maybe typical example, like people feeling like attenuated sense of presence without, it doesn't really, it's completely separate from a virtual reality, but just people naturally feel this physical world doesn't feel like real. There's many causes, but it actually happens to the normal healthy people, but if it's continue really long, it's called a disorder. And people sometimes discriminate between like a depersonalization, which is actually more like your body, but also sometimes they say, things looks less realistic. And I think this is just a flip side of one coin, but sometimes people separate these two. I also, hallucination delusion is, it's not directly related to the presence, but these are also disorder of, I would say, reality monitoring. The patient cannot distinguish between what is real and what is not. So I'm going to this at the last part of my talk. So the sense of presence and or experience reality is actually a bit more complex than just one definition. So actually, one paper dated back 2014 by Anises again. There are multiple layers of reality. So one is, I think there is like a name is a bit arbitrary, but he called subjective veridicality in like a base level. So this is more like things. Actually, this is not the first level, but the first thing is this one is actually really close to the sense of presence. So things looks like existing in the real world. And there's another kind of different, dimension of reality is more like whether your experience is like a perceptual, like compared to like imagination, for example. So this is slightly different from presence, but this is also, related with a kind of reality as well. And I think third level is doxastic veridicality, which is, I think, more similar to what is called like a plausibility illusion. So it's more like a belief. Do you actually believe this is real? Interestingly, these three levels are, corresponding to these different type of clinical psychiatric condition, like depersonalization, hallucination, and delusion. And so as I said, like this second level is actually, how people can actually distinguish between real percept of the external world or just imagination. Okay, and today I can actually talk about this third part, maybe in somewhere else, but today I'm just focusing on this first part, first two. Okay, so my first part of my first part of my talk is this subjective veridicality with sensory motor contingency. So you can see some object. This is just augmented reality, and there's a 3D object on this AR marker, and it's really, I just playing with this object for a while, and I just really feel like this object actually exists. So one of the big factor of this presence is this sensory motor coupling. You act something and you can get the correct feedback from the environment. And this slide is a little bit philosophical, but there's some argument by, of course there's so many theories about, how we can actually make a presence, but one theory is from this Origan and Noe, they are a philosopher on active perception, and especially Alban Noe talking about this sense of presence, or maybe, I think he called perceptual presence in his book, in Action in Perception in 2004. And his idea is, like there are some distinction in our perceptual experience. This is, the left one is, of course, a picture of a pipe, and the right one is actual 3D, real pipe. Of course, it's still not real one because it's on a slide, but imagine you can, this is a real one. But, there's something different between the 2D image of the object and the real object. And I think their explanation of this is we feel some 3D object as real because we know how to manipulate, As I said, like in a real object, when you turn this way, you can see the back. And, of course, this is only happen in a real object. I don't know, maybe, of course, a picture as a whole is an object, so you can actually move around, but I'm talking about the actual painting, the pipe in the 3D image. And also Anil says talking about this with a bit more computational, like using this predictive coding explanation. But yeah, it's kind of, he said we have like a generative model in your brain involving like action and action consequences. So, but yeah, he didn't really show anything. He just wrote about this really conceptual level. So we did some experiment based on his theory. So again, this is I already showed the 3D object in augmented reality. It looks real, and we can, of course, easy to manipulate this sensory motor coupling in a virtual object. For example, this one just inverted coupling. And you can see it's because of this shading and lighting, you still feel this is a little bit like a 3D, but while you're actually playing with, you just, you cannot get this sense of the reality of the object anymore. But the one problem, like how to measure presence, I think this has been a big problem all the time, and of course, early days, and still people use this subjective rating, the questionnaire-based approach, and easy to measure, but of course, it's biased by prior knowledge, and especially using virtual reality, people have a different degree of usage of the virtual reality, so that affect the subjective rating. And some people use this behavioral measure, like a Bection, or how much your weight balance or body motion is affected by a visual stimuli. And yeah, some people also use like a physiological measure, like skin conductance response in threatening threatening environment. And people say, there is a behavioral and neurophysiological measure of presence is a little bit more like prone to, bias prone, but still there's affected by the expectation. But also, sometimes I always wonder, is this actually the measuring the presence? They are studying emotion maybe in a physiology measure, and behavior measure maybe they just measure this immersiveness of the technology itself. So I want to create something, the new measure of the presence. So the one approach is using some idea is coming from a vision science or conscious. I don't know. I don't need to use consciousness, but a vision science. So some paper early 2000 they use continuous stress suppression paradigm. I think some of you know. We just show the it's here. Dynamic Mondrian-like pattern on one dominant eye, and then you show some target image on another eye, and it takes it's a kind of different type of this binocular library paradigm, but this one actually quite powerful. So it takes sometimes more than 10 seconds until you actually see the object, because the mask is quite high contrast and dynamic. And there's kind of some interesting study by Roy Sermon using this paradigm on bodily perception. So for example, he studied body congruency, incongruence. So sometimes there, I think which way? So they show the image of the hand, but sometimes their visual hand is congruent or incongruent from your real physical hand. And they show some how to say, cue actually on the hand, and they found, for example, when the visual hand and real hand is congruent, the stimulus come into your consciousness quicker than the other condition. And a different version, it also create a huge chair, rotating chair. And this time he tested this not just proprioception, but like a vestibular. So the chair itself is rotating counterclockwise and clockwise, and you can see this red arrow, again, left or right. And then, again, like when your bodily movement is congruent with the arrow, this arrow actually breaks through your consciousness quicker than the other condition. So we actually use the same kind of paradigm, but in virtual reality. So this continuous thrust suppression in virtual reality. So you can see that this is actually mask. We only present this one on the one eye, and the other eye you can actually see the object. And the idea is we actually manipulate the sensory motor coupling of object. So, and we also designed the novel type of object. It's not like a cup or like a clock. It's just a new object. And people actually move the object through this like a motion tracking device. And the task itself is just a shape identification task. So you need to press button once you see the object, and you need to say which object you actually see. And normally, to me, sometimes it takes actually 10 seconds. Even the object, the visual stimulus is moving. Normally it's the huge salience. So it must break through this mask quicker. But this paradigm, I think the mask itself is also the kind of new continuous moving one. But anyway, so we found the difference between the live condition. Oh, I didn't explain. The one condition you actually control the object with a tight coupling. The other condition, the movement of the object is inverted or like a completely static. So all the condition people keep moving the object with this device, but only the visual stimulus of the object is different in these three conditions. And we found only the significant difference in this breakthrough time between like a live condition and a replay condition. And we just discussed maybe this difference between like a live coupling, the object with live coupling is quicker to perceive compared to the replay condition is maybe, because of this live coupling, people see their object is more realistic, and maybe that's why the object perceived quicker. And interestingly, there's another group of people from Israel. It's parallelly doing the quite similar experiment. They actually created the augmented reality version of this continuous thrust suppression experiment. So they actually cut one side of the glasses, so people see this Mondrian pattern on one eye, but in the other eye you can actually see the real object on the table. So it's quite similar, but they actually use a real object. Interestingly, they found the quicker first reaction time, so they can actually see the object quicker for the 3D object versus 2D image of it. So it's kind of interesting because this is a monocular vision. So there's no depth skew, like there's no stereoscopy, but apparently the 3D and 2D image is somehow processed differently in our visual system. And interestingly, they like a follow-up experiment show why this is happening in the, it's kind of interesting. They actually cut off the object into like a pieces and connect each other. So you can see this is the clock with like a scramble. And then like this 3D, 2D, the difference in 3D, 2D disappeared. And they claim this is because, the object, like the left side of object, we know how to interact. We know like our sensory motor coupling because we interact with it over light. Whereas the right object is scrambled, it's so unfamiliar. So we don't have this kind of object food, sensible object food. And they claim this is a reason, the effect disappeared with the scramble way. So we kind of discuss, we approach this sensory motor coupling, sensory motor mastery, and visual perception, visual awareness in two different ways. We actually manipulate this sensory motor coupling on ongoing way, during the task. We change the sensory motor coupling, whereas they did use already the everyday's object, so they already learn how to manipulate the object. So in a two different way, we actually manipulate sensory motor mastery, and we show this sensory motor mastery or learned contingency affect this conscious awareness. And maybe this is mediated by this perceptual presence, how it looks real. So that's our kind of conclusion, but of course we need some more explanation. And now we are working on slightly different kind of perspective. What time is it? Okay, already 20 minutes. So the previous paradigm, we use this binocular library paradigm, which is kind of great, but sometimes I always feel like, how to interpret this data? What does it mean, like things come into your consciousness quicker than others? So I don't know, maybe this one also has the same problem, but like some, there's the phenomena called spatial neglect, or I think there's other name. Anyway, some patient who had a brain damage, sometimes they ignore all the left side of the space and left side of the body. And when they are asked to draw a picture, they cannot draw the left side because all their conscious experience is only the right side of their space. But interestingly, I didn't know that until recently, but even like a healthy people, you have similar effect, and this is called the pseudo-spatial neglect. So when you're asked to bisect a line, it's actually the opposite direction, It's slightly biased toward the left. So some people say maybe this is because, our brain, spatial perception in our brain is really right hemisphere bias, Our right hemisphere actually cover whole body, but the left side of our body only charge of the right side of the body. But anyway, and this effect, this pseudo-neglect effect only happened with a one-dimensional line, and effect disappeared with a 3D stick. So one of my collaborators tried this effect using somewhere in between, it's you see like a rod or stick but it's actually not actual one, it's just a picture of the rod, or the one is actually shaded line. So it's somewhere in between, like just a line, 2D line to, it's a line, it's 2D, maybe 1D, 1D line to the 3D. And then still, only the real object, rod, have no effect of this pseudo-neglect. And all these lines have this effect. So now we are working on this, the task in virtual reality, because we can actually manipulate a lot more than just shaded rod to the line. So for example, it's still ongoing work, but in virtual reality we can show this like a 3D rod versus, we cannot draw a one-dimensional line in a virtual reality, so it's like a 2D ribbon on a table. But we can also control sensory motor coupling. So whether this effect is associated with more like a 3Dness or volumey, perception, or more like, again, like a sensory motor coupling, whether you actually, possibility of you can actually grab the object affected this task or not. So that's what are we doing now. So the summary so far, we did some experiment using this virtual reality, augmented reality, to try to understand how sensory motor coupling affect visual awareness. And of course, this don't directly address the sense of presence, but it could be related with presence from the sensory motor coupling. And we want to use this as a kind of implicit measure of presence, because a lot of the measure of presence still, this is actually the work by my old colleague in Sussex. A lot of, some people actually are more some people are more hypnotically suggestive. They can actually generate their experience without even intended. So especially like a presence is easy to, some people are, actually there's a huge individual difference how much you feel the presence even in the same environment. So I think implicit measure of the presence is really important, and I want to develop something more like behavioral implicit measure of presence. Okay, so I don't really have much time, but I will just go through quickly the second part. So the different, another one is, so I was talking about is more like whether the object actually in the real world or not. But there's another dimension of the reality, which is, as I said, like what the difference between imagination or the mental imagery versus real percept. And recently, there's some neuroimaging studies showing like imagination, especially voluntary imagery and real percepts, sharing the same neural mechanism. And maybe, you know, like how to distinguish between the real percept and the imagination is related with this kind of, you know, reality monitoring. And interestingly, in machine learning, it's already a bit old, but the generative adversarial network actually using the similar kind of function, you know, like they just create the data, and the other network try to distinguish between real data from the generated one. So I think the brain has a similar kind of function, and it's actually the Samuel Gauchman, he's a big guy in computational neuroscience, also said, yeah, maybe brain has this adversarial network inside. But anyway, this is a, you know, one explanation of hallucination is, yeah, maybe people have no ability to distinguish between what you actually imagine and what you actually perceive. So in that sense, I'm really interested in hallucination, especially visual hallucination. Yeah, we have a lot of different kind of visual experience, but one extreme is this hallucination. You know, it's not like a dream because you're awake, but some people in clinical condition, also some people taking psychedelics sees a lot of things. It doesn't really doesn't really exist. So we just use a little bit strange way to tackle this problem with using deep neural network. And now people all use a transformer diffusion models, but this was actually back to 2015, 16, when we started. So this time the image recognition task is done by this deep convolutional neural network, and it was actually reaching the human level performance for image classification task. And it's really interesting because I think that current, you know, the diffusion model is difficult to interpret in brain-wise because there's no hierarchy, it's just a denoising each layer. But this convolutional neural network is inspired by the visual cortices of the human or biological brain. So there is actually a hierarchical, you know, early layer of the neural network is actually resemble to the human or monkey brain in terms of representation. So we actually made this demo implementing the virtual reality. We call it hallucination machine. So it's a deep neural network synthesized visual hallucination, or maybe more like psychedelic visual hallucination. And you can see like each you know, people walking by and all faces turn into dog. And I can explain why there's so many dogs maybe later, but yeah, it's just really dog-oriented hallucination. And what is there? So interesting part of this, the model is because this is a hierarchical, whether you clamping the lower layer of the network to the middle to higher layer network, it creates a different type of hallucination, you know, and actual clinical patients see this really, you know, geometric hallucination sometimes, but sometimes they see complex actual human or dog. So this model actually can differentiate to create different type of hallucination. And we actually did some, you know, study using this setup because so far it's just a demo. So we actually use a questionnaire used by Imperial College London. They actually administrate a psilocybin to the participant, and they, yeah, the subjective rating after their experience. So we did the same questionnaire, and kind of interesting. We found that so the right figure is just comparison between our video, our hallucination machine, and actual rating after taking some psilocybin. They actually administrate in the blood directly, but we found like a kind of similar, you know, rating between real and like simulated psychedelic experience. So this is like a really schematic figure, but I was thinking it's a kind of a the idea is getting from the, you know, predictive coding or free energy things, but, you know, our perception, normal perception is really, you know, vivid and detailed, maybe because we're using the whole network, hierarchical network of our visual systems. But maybe complex visual hallucination, we just create something without, you know, using the bottom-up signal. Just a top-down signal is enough to create some real object. Whereas maybe normal mental imagery, I think I don't have the some people actually hyper fantasia. People actually have a really vivid perception, experience even imagery. But normal people have really broad image when you imagine something. So it's just maybe because we only use a higher, top level of the hierarchy. And whereas maybe psychedelic experience, when you take a psychedelic drug, maybe visual experience is just stay in a lower layer of the visual network. Maybe that's why we see a lot of geometric pattern and spiral and stuff like that. So I think I'm running out of time, so I will skip this part. Yeah, we're working on a different type of hallucination as well. We do some actual interviews, semi-structured interviews with the patient who have visual hallucination regularly. Also, people who had psychedelic before to assess how our model actually, reflect people's actual hallucination experience. And now we actually, so the older hallucination machine I showed looks like, the actual virtual reality, but it's all offline. It's because it's 7 years ago, this deep dream algorithm taking so much time to just process. But now, like a couple of years ago, we actually created a real-time version. So now all process in real time. So this is the view from the camera on your head. So you can actually see your hand and explore. Of course, it's still, we need RTX 4090 to process this one. So we cannot actually make it mobile yet. But we can actually explore like 3 meter square. And you can see, start seeing some dog face and drifting towards somewhere. So this is kind of, new approach, and we start testing something. So this is some technical detail. We need some multi-threading and some efficient data transfer between like, video card, GPU memory and stuff. And this is my last slide. So I think this is kind of renewed our approach to mind. These are the long tradition of phenomenology from like Husserl and Merleau-Ponty, people studying this subject experience as it is, not using like a psychological metric. And there's so many approach to like a bridge between like a science and this phenomenology. But I think this is the way to using computational modeling to do phenomenology in terms of just other way. So sorry, I'm just running over the time. Okay, I'll just skip. This is just a summary. And so, if you have any question or any collaboration, just tell me. Thank you very much. Sorry for running out.
All right, thank you very much, Keisuke. All right, we are preparing to transition to our next speaker, which is Maxine Room. She's head of people at United. We'll be talking about education at Web 4.0. So we're going to get her set up. We have the clicker. Yeah, perfect. Okay, and do you have your microphone already, or?
I have nothing.
Okay, yeah, you need to be set up.
Do you want a hand mic or is that one? Do you need your hands free?
Yeah, I need my hands.
Okay, so you have to put this one. Can you put your hairs, please?
Oh, no, not easily.
This is behind the scenes. We pull the curtain back, so you see the magic behind the production.
So much hair.
And this is an opportunity if anyone's a little thirsty. We have a coffee break coming up, but this is an opportunity to grab some water.
Take a break. Take a minute. Oh, yeah. I didn't think about that. No?
So now we have to put this in here. Should I grab the bed?
All right, I think we're set to go. Maxine, the floor is yours.
Okay, good morning, everyone. I'm Maxine Room, all the way from Spain via various places. Delighted to be here in Germany again. Ich kann ein bisschen Deutsch, aber es ist nicht so gut jetzt. Ich muss in English. Okay, so a little bit about me. And a little bit about the organization that I'm representing and working with, United. And then I want to talk about education, which is my passion. So I'm delighted to be here in an educational establishment. So I was a teacher a long time ago in the UK, and I progressed to being a principal CEO of colleges across the UK. And in recognition of that, the Queen, the late Queen, gave me a Commander of the British Empire for leadership and management. And my other passion, which is diversity, equity, inclusion. And my other passion, which is technology. So for the time that I have been working in education, I've been really keen to see the ways in which technology and innovative technologies can support education, learning, teaching, all those aspects. And I've done it from the ground up. So I'm not just talking as a theorist, I'm talking quite practically about the way in which technology can support the education systems. And recently I've been talking and writing about the fact that we cannot keep teaching in buildings. We do need buildings. It's important that we have places where people can meet in person, but the system is very expensive. And last week I did a webinar about reducing the costs of higher education. And it costs £9,250 per year for an English or UK student, more or less, and it costs the universities much more than that to deliver. So I've been looking at what could be a hybrid, what could make the difference? How could innovation in education using technology be different? So 2.5 years ago, I started to work with United. We're a small but beautifully formed startup. And if you do have a computer with you, you can walk with me in my nature hub. Those of you who are online are actually in the webinar space that we developed for the summit, and hopefully there are a few people joining that now. So I think we're going to flip so you can see my world. And hopefully you can see me in a minute. Are we all there? No, it's not sure. Ah, there we are. There I am. Okay. So this is just one of the worlds that United has developed. And you can see my avatar. It happens to be a Ready Player Me avatar, but we have all kinds of avatars. And I've been interested to see how these worlds can be used for education. We're working with a number of organizations, including a university, a digital university in Germany, to deliver through the vertical and digital worlds a whole range of degree courses, which is really exciting. And we have a number of opportunities in these worlds. I mean, this happens to be mine. You can hear the birds singing. It's quite meditative in some ways, but you can have all kinds of things in there, and I can actually be on the screen. Can you see me there on the screen? Yeah. So we have a number of features, and I'm just going to flick through some of those. Laser, there's the opportunity to add assets, and we build these for clients in the way that they want to have them. So if you use our arena space for as a campus for a university or for teaching and learning, you can have a number of different assets that you can build. We have spaces where you can sit down. We have zones where you can have a private assessment with your tutor. And what's interesting coming to any of these events for me, and I do a lot of them around the world, is that I always learn something myself. So I'm interested in everybody that's spoken yesterday and today about how we can use AR, VR, and get those experiences immersive. That whole thing around presence is really interesting to me. How we can use augmented reality to teach and learn in these spaces. So you can see there are screens, there are, I have our CEO Florian in the space with me. And if you go into the VR Summit webinar, you'll be able to see me if you have to leave today, or you can see other speakers. So there are a range of emotions that you can use. So I can wave, jump, clap, or do all kinds of things within the space. And we have one of our engineers over here who's helping technical engineers, who's also in the space there as well. So that just gives you a flavour of some of the things that we've been doing at United over the last 2.5 years, investing 2.8 million in developing. We have a really diverse team across the world. We have a female developer in Pakistan. We have a female project manager in Serbia. We're 70% women. And that's another interesting dimension to this Web4 world now, where often when I go to events, it's predominantly male and young male at that. And that has a dimension around what it means when the people who are developing have a particular perception of the world, a particular identity. You know, as a black woman, I work across a whole range of different pieces of work and have done, but I'm unusual in this space. I'm unusual when I go to conferences and conventions. Can we go to the presentation now, and I'll come out of the space. But if you want to go into that space yourself, it's a public space, and there are some other public spaces that you can explore. And if we go to the next slide, that's the link that you can get into. And that's our arena. It happens to have a sort of 360 panorama of Mallorca, because we have people working in Mallorca as well. And it's really very culturally diverse. And some of the work that I've been doing over the last couple of years is to think about what is it that we need to do in order to make Web4 immersive enough for our learners and in education. And I use ideas, and I talk about inclusivity. How do we make it inclusive? Because sometimes it can be seen to be exclusive in terms of these immersive technologies and these innovative technologies. How can we make it more diverse? How do we make it accessible? And diverse in terms of listening yesterday about avatars that you can develop to make look like you, rather than what the developer wants you to look like. I know when I first had an avatar, I looked like Lara Croft, and that was not me, as you can see. But we're getting better at actually making really diverse and inclusive avatars. I also think there's something in education around economics. How can we make the accessibility to this technology economic? And that's something that universities in the UK are having to look at, and it's what I've been writing about, because it's important that we ensure that we do not exclude by price. Today I heard on the news that the UK is thinking of increasing the students, the amount students pay via a loan or whatever, to over 10,000 to make it economic for universities. Universities have lost out in terms of their international students because students can't necessarily travel. It's very expensive. There's a currency dimension. So how can students across the world be more included to do the courses they want to do where they want to do them? There's something for me about accessibility, and we're talking to a range of clients at the moment about SEND, students with who have diverse needs, who may be disabled in some way. How can we make these spaces suit them? And then there's the whole thing around sustainability, security, and safety in these spaces. So all of those dimensions is something that United are trying to work with, and we're looking to partner and collaborate with others in order to do that. And I want to have those conversations later today and tomorrow if possible. So if you want to explore our worlds, there's a QR code, and if you want to explore me, then you've got my LinkedIn, and you can find me very easily on LinkedIn, and I'm really happy to engage. We're looking at a number of verticals at the moment. Education is one of the big ones, but there's also opportunities to build communities around those things people are interested in. So we're talking to investors, we're talking to real estate, we're talking to banks. We're actually working with Sparkasse in Germany, and they have a digital twin of their offices and their banks that people can use. And that's really useful for people who can't get to the bank and want to use those services. So there's a number of different ways in which we are working with organizations. So, revolutionizing learning. So there's been a lot of talk over these couple of days around the AI-driven interfaces. And we know, ChatGPT, I think, was being mentioned this morning. And there's lots of other ways in which AI can be used to create intelligent, adaptive learning environments. And that's something I'm really interested in. I was a curriculum developer in a past life, and I'm looking now at how curriculum can be delivered differently within an immersive space. Getting real-time feedback for learners and content updates based on student progress, and making learning much more bespoke and individualized, I think is really important. One size does not fit all. I know as a teacher, that often you can teach to the middle, or in lectures at universities, you're teaching to the masses and you're expecting students to pick up what they need. How can you, in these spaces, use an individualized, bespoke approach and monitor students' progress? And decentralization. So we've had Web 2, Web 3. Web 4 is a much more integrated approach to and a decentralized model with AI-driven decision-making, enabling a more efficient peer-to-peer educational content sharing system, not just for the students, but for the professors as well. And we've been working with professors to say, you do it this way now, how might you do it differently and possibly better in a space, in a virtual digital space? Enhanced accessibility, leveraging AI and decentralization with Web 4 ensures that learning resources are accessible 24/7. And in some lectures, the students walk out, or even on a Zoom or a Teams call, everybody goes. With this approach, 24/7, you can hang out in your learning community, you can work with others. We have, as I say, private spaces where you can go from a lecture into a space with a group, work on a project. You can make that space incredibly private by not allowing anybody in, and we have that facility. So it's important that we leverage AI for good, and there's a lot of discussion about that at the moment, about how we make AI work in learning, in education. I know that some of my colleagues in the UK have been concerned about how AI can be used not in a positive way, but I think if we set the protocols, if we discuss what it is we want students to be able to access and how we want that done, and we tackle the issues around plagiarism, etc., that's a really important aspect. And so this is a global opportunity for universities to grow and other education establishments to grow in remote regions where you haven't seen education reaching previously, and reducing education inequalities. And as I say, one of my passions is diversity, equity, inclusion. I work with an organisation also, the Black Leadership Group in the UK, and we deliver mentoring and coaching. And we're just about to launch a micro-credential in our space around mentoring to support staff who want to progress in their careers in a way that they haven't been able to do previously. So, some solutions. Blending the digital and the physical. You know, I love meeting people. I like being in the room with people, but it's not always possible. And Education 4, Web 4, integrates digital tools like AI, Web 4, and the Internet of Things with traditional classroom environments for a seamless hybrid learning experience. So with UDS, we're working on them having a space where they can collect students together and then students can go off into spaces. And you don't have to have walls. It's quite interesting. You can make things as closed as you want to without having walls. But we seem to like walls. You know, it makes us feel really good if we're in an environment that we recognize. And there's been some talk about that just now. But it's really important to make that learning environment really integrated for students in a way that perhaps our use of Zooms, Teams, etc. doesn't. And that hybrid learning experience can be really positive. And personalised learning. Students with ADHD, students who have autism, we're working with an organisation called Nobotics, who are really keen to develop a platform which really gives those students an experience that they're not getting in schools, colleges and universities at the moment, and to support them through their learning in the way that they want to learn, and optimising both pace and content for learners, and recognising their individual needs. And education is not just limited to, you do your qualification and to formal settings, but extends through life. I'm still learning. I'm hopefully going to learn Spanish. I live in Spain. I'm hopefully going to learn Spanish. And I can do that within a virtual environment. And it enables that continuous skills development. It's also really great for organisations. We're just looking at a proposal for Sparkasse at the moment around how they might use their existing intranet in a digital virtual space to engage much more their staff. And there's a lot of work that's going on, research into neuroscience, how we learn, cognition, and how the hippocampus makes us engage much more. And this is not my area of expertise, so I'd be keen to talk to people who've got that expertise. But understanding this makes a much more engaging and meaningful experience of learning and retention. And I'm all about how we develop the skills for the future, not skills for the past. And sometimes what we see is that we're still teaching in a way that, the expert is here and they're talking out there, and we have to catch what we can from that and make it work for us individually. And I've also been interested not just in specific qualifications or degrees, etc., but what goes on around the learning experience. So in terms of student support, in terms of counselling, in terms of using something like an AI tutor bot, which is available 24/7. How many students work specifically between 9 and 5 these days? You know, when I have my best ideas sometimes at 1 o'clock in the morning, and I want to go and see how I can actually explore those. And so it's a really interesting way to bring not just the qualification that a student might be studying, but also the support needs that they might have. And support is an expensive resource within education. I know I was a principal of colleges, and I know it's not just about giving students careers advice at the end of their course in order that they can get a job. It's that whole process. And I've been looking at, as I have throughout my career, the whole learner journey, the whole student journey from entry to exit. And talking to university in Lithuania, they were interested to have an alumni space. So what happens when you leave university? You get cut off almost immediately. You get cut off from the university. But having something like an alumni space where you can meet employers, where you could talk to others, where you can maybe build your CV, understand how you might make the next steps into your career is a really important aspect. And those students who've got good jobs, who've gone on to be great employers, etc., wanting to give back. And that gives an opportunity to get that dialogue going in a way that perhaps doesn't happen easily, particularly when people move across the world and are working internationally, and you can bring them back together. But also recently talking to universities about marketing. A university in the US, in New York, was trying to get as many prospective students and families to come into the university at the weekend to talk about the courses that were on offer. And they did get about 1,000 coming through, but they knew that their catchment area was in the millions. And yet they couldn't afford all the resources that they need to make that happen. But within a digital virtual space, that can happen. And it can happen when people are ready. You know, sometimes I used to run open days, and if it was raining, nobody would come. If you've got a digital space, they can come anytime. You can have things running. They can meet the Vice Chancellor. They can meet professors. They can actually experience some of the activities and assessments that they're going to be exposed to. So there's lots of different ways that the spaces can be used. And it can offer solutions. So a lot of the time when we're talking to clients and customers, prospective customers, we're talking about what are the pain points? What are the things that you can't do that this platform could help you to do? And how can we help you to overcome those challenges? So we've heard already about AI and the powers of personalized learning, real-time analytics, and how we can do some adaptive assessment to meet needs. The use of, and it's been fascinating to me, I don't pretend to understand all the things around virtual reality and augmented reality and the developments that are going on with some of the organizations that are here and the products that they have. But I think there's a real opportunity to collaborate and partner and make those things work in an adaptive environment and assess how those things are going to make the difference. So, you know, if, for example, in the UK, 43% of students are dropping off each year out of university, what is it that would make them stay? You know, is it financial? Would it be better for them to experience some of their course in a space like this? Or are there other things that actually aren't engaging them? The actual way of learning, the way of acquiring knowledge, the way in which the systems are set up, those are the things that stop those students actually staying. And for universities, there's a real cost, you know, billions over the life cycle of student life. So it's something that I think universities can think about in terms of making these things work for them. And the blockchain technology ensures secure credentialing and transparent verification of skills. And also our platform is GDPR compliant. We don't hold on to the data. The data becomes the organization that's actually commissioned us. And, you know, we don't want to be a Meta. We don't want to hold on to that data. We want people to own their own data. We want to be a challenge to that if we possibly can. So, what I think this has been about, and I'm catching up timing because I realise we've got behind quite a bit, so I'm not rushing through, but there are these innovative learning platforms. I think the professors across Europe and across the world can contribute to doing things differently. You know, I have a challenge sometimes when I'm talking to various people in education. It's like, don't understand what you're talking. They haven't even got at the starting gate. What we're about is educating people, helping people to understand that, understand what an innovative learning platform can do, how it can add value. Financial assistance, you know, a degree, a digital-based degree can cost about 7,000 euros for a year, whereas, you know, it can be more expensive in terms of, certainly in the UK, if it's an in-person. So having a program which is more cost-effective and actually makes it easier for the students to access. And then these personalized learning support services from beginning to end, and these immersive learning methodologies, which, you know, we're at the forefront of at the moment. We have technologies, we just need to make them work in an integrated, immersive way together. And these will be the solutions. Thank you for your time and attention. There's a lot that I think that a group like this can do together, working together. And at United, we're happy to offer you a demonstration, take you through a world, and you now have the opportunity to build your own world for free. So if you go on the platform, you can design your own world. I had a go at this the other day. I had a lot of plants in my space and not many walls, but I had a nice sofa and I had the opportunity to sit down with others and discuss a whole range of things about education. And you can contact us at info@United World. I can go back and let you see the link for the virtual world if the engineers can do that. And I'll be happy to answer any questions in the coffee break. Thank you very much.
Thank you very much, Maxine. All right, we're transitioning to our fourth speaker before the coffee break. Our next speaker is Abraham Mahidly. So he is a research group leader at the Max Planck Institute, and he actually spoke yesterday. So today he'll be talking about harms in emerging technologies and various topics related to that subject. And that's, I think, for me, quite exciting because it's going to be an interesting follow-up to the panel discussion we had yesterday. So Abraham, I welcome you to the stage. Just 1 second, we're gonna turn it on.
Mic test, 1, 2, oh yeah, folks can hear me? Cool. So, hello everyone, my name is Abraham Mahidly, and today I'll be talking about the physical and mental harms of VR advertising. So first, a little bit about myself. I work at the Max Planck Institute for Security and Privacy right here in Bochum, and I study the harms and ethics of new technologies. So try to looking at, okay, what do new technologies look like 5, 10, 20 years from now? What are the possible ways they could harm people, and what can we do now proactively to address these harms? And I've studied a broad range of technologies, AI, IoT devices, smart speakers, brain-computer interfaces, but I've also studied VR. And more specifically, I've studied VR advertising. So first, quick question. How many people here, while using VR, have encountered advertising? All right, just one. And I guess my next question is self-answering, but anyone here work on developing VR ads? Oh, a few. All right, cool. So for those who might not know, VR advertising, as the name suggests, is advertising that takes place in VR. But in terms of what formats or what does this actually look like, it really can be anything, because it's a new, exciting, and rapidly changing field. At its simplest method, you could imagine that like 360 videos and photos. You could have virtual avatars that try to promote something or sell you something. Standalone virtual worlds, right? Maybe Starbucks has a Starbucks planet that you visit and can do cool things in. Posters in a VR environment, so maybe you're in a social VR and it's a social environment, but there is a poster in the back corner that's selling something. As well as whatever the future will come up with. And to give an example of what one ad could look like, this is an experience by Oreo. It was released a while ago, but it is a 360 video. You can find it on YouTube. It's pretty cute and adorable. And as you can see, it's fantastical. You know, you are floating among Oreo cookies down this Charlie and the Chocolate Factory type thing. You know, very cute. It actually makes me want to have an Oreo. But yeah, so these are the types of possible types of VR advertising that exist. And so while it was cool, the key thing to note about VR ads, like I said, it's a new and emerging field and they're not here yet, right? Most people here hadn't experienced it. And it's not like smartphones or TV, where ads really form the backbone of these industries and form the main monetization model. The types of ads that do exist in VR, they're few, far between, and really they're not as polished or mainstream or as developed as we might imagine in a world 5, 10, 20 years from now. But they are coming, right? VR technology are like mass communication technology, and like smartphones before it, the internet before that, TV before that, newspapers, radio, all these technologies, all these communication mediums, as they become popular, they start to integrate advertising. And with VR, it's not expected to be different. First, because of what's happened in the past. And two, because you have a lot of companies either saying, we want to develop ads for virtual reality, or actually actively doing it, like Oreo or many other companies. And so that's fine and good, but the question is, you might be asking is, well, Abraham, you just admitted there are lots of ads everywhere. How is VR advertising different? In other words, why should we care about this new phenomenon? And there's actually 3 key things that experts have thought about how VR advertising could be different. And not only slightly different, but like qualitatively different than ads that have come before it. So the first is that VR ads are expected to be more immersive, right? Stands to reason. VR is more immersive than a TV screen, so the VR ad is more immersive than the TV ad. So you're not just seeing an ad, you are a part of the ad, and you will be integrated into the world that the advertiser wants to create for you. Relatedly is that VR ads can be more interactive, right? When you watch an ad on your phone, on a TV, you're really just passively watching the ad. Sure, you've got those annoying mobile phone ads where you technically have to play, and like that's technically interaction, but it's like night and day with what you can do in VR. You won't see a car, you'll be driving the car, right? You will be in a world that responds and reacts to your every move, and so that can really change advertising. And the third one is that VR will allow for new ways to view products. You won't just see a t-shirt, you'll be able to grab the t-shirt, turn it around, try it on, and this will allow for unprecedented ways of viewing ads. If you want to go to a new tourist destination, maybe you can preview it in VR first. So all is great and good, VR advertising is going to be amazing. Except, hold on. Advertising in a technology dominated by this guy? I've seen this movie before. And you'd be right. Alongside these expected benefits, there are also a lot of concerns. And there are many of them, but probably the 3 ones that have been raised are, firstly, the privacy risks, right? VR devices can collect everything your smartphone can collect, as well as other types of biometric data, right? Your height, your gaze, how you move, with the integration of brain-computer interfaces, your brainwaves. And the question is, how will this data be used for advertising? Which is not helped by the fact that Meta is one of the biggest players in this space, and let's just say they don't have a stellar reputation in managing people's privacy as it relates to ads. So that's kind of one main issue. Another one is manipulation. So, right, you have these highly immersive, realistic looking worlds. Can VR advertisements, either through privacy and brain collection, be used to like leverage your sensibilities and show you exactly what you want to see? Can virtual avatars pretend to be real humans and try to sell your product, and you're not aware that you're talking to a fictional ad? So all these types of concerns. And then the third one is irritation, right? The whole point of VR is that it is an immersive environment, and is it really immersive if you have ads popping up and potentially ruining the experience you're in? Half-Life Alyx or Beat Saber is not as fun if every 3 seconds you've got a Coke bottle saying, buy me, buy me, buy me. And so these are all important harms, and they're worthy of being addressed. But what I'm going to do is talk about a different harm, one that I think is just as, if not more important than these, but that so far I don't think people have talked about, at least in my field in academia, and it's really like flown underneath people's radar. And that is the physical and mental harms of VR advertising. Right, throughout my work, like studying ads, predicting what ads will be like, talking to VR users, as well as reading what other people have done in this area, I feel this is like an underlying harm or theme that I keep noticing and keep wanting to talk about, but I've noticed other people focus on all these other harms. So my goal for today is to show you all how VR ads can cause physical and mental harms, why we should care about them, and then conclude with maybe things, possible solutions, maybe ways we can go about addressing it. And so that's sort of the outline I'm going to follow today. First, I'll talk about the harms that VR advertising poses, why it's important to consider these harms as its own separate category rather than just, an extension of other VR harms, and what we can do to mitigate or solve these harms. So to start, let's talk about what the physical harms that VR advertising poses. So the first one, as anyone who's used VR can attest to, is like nausea and motion sickness, right? So this could be either through a badly optimized VR ad, or maybe you're in an ordinary VR experience and there's one ad which says, okay, in order to proceed, you have to transition through this portal to a different world. And the transition is so jarring, so drastic, so violent that it disorients you, and you throw it. So that's one. The second one are bright lights causing seizures, so this one's pretty self-explanatory. Maybe you have a VR ad experience that has a lot of lights, or maybe you're in a world and there's like that one poster in the back corner that's like thumping lights, trying to like pay attention to me. The third is crashing into things into your environment, right? So maybe you're in a world and there is a VR ad ferry, and in order to proceed or to get rid of it, you have to catch the ferry, read the message it has for you, and then move it on. So it's flying away just out of your reach, so you try, you jump, and then, oh no, you sort of fall and crash into the table you didn't realize was there. And the fourth is muscle strain and injury. So we talked before about how VR ads can be interactive, and maybe you have an ad that requires you to do some exercise, right? Maybe you have an ad for a tennis racket, and they're like, oh, you have to play a few tennis points to feel how this new superior tennis racket feels, and so you just want to get it over even though you have an arm injury, so you try playing, and boom, you sort of hurt yourself. So these are probably the four main physical harms that can be caused. And then moving on, we've got the mental harms that could be caused, so psychological harms. And the first one has to do with something called shockvertising. And basically what this is that shockvertising is a tactic whereby you deliberately show shocking, graphic, explicit, distressing images in order to disturb the user, scare them, catch their attention, things like that. And to give an example of how this looks like in VR, I'm going to show you a real live ad. It's made by Gatorade. You can find it on the Steam store. And the ad, it's okay. I mean, so you play American football and you drink some Gatorade to get some points, so it's all fine and well. But there was one point that sort of felt a bit odd when we played through it. And that's this one right here. So here you're playing football, and as you can see, sort of the vision is narrowing. And basically what's happening is you are getting dehydrated. You're getting attacked to these people. As you can see, there's red lights. And what this doesn't capture is like there was a loud thumpitation getting louder and louder, and then you finally pass out due to dehydration. So that's kind of what is shown. And as someone who had to go through it, it felt very visceral, a little bit disturbing, a little bit uncomfortable. And you can imagine how there could be VR ads in the future that incorporate much scarier, much more traumatic experiences. You can imagine maybe an ad for a horror film where, you're in a house and suddenly you have someone with a chainsaw chasing you and you have to escape them and they're coming up wearing the chainsaw and then they stab you to death. And then as you're dying, it says like, come watch the next Texas Chain Massacre movie or whatever. Or maybe there's an ad, public service announcement against drunk driving. And to really scare you, they have you in a car, you got your partner, you got your kids in the back, the dog is there, you're driving, you lose control, crash into a tree, everything's burning, your partner's dead, your children are dead, the dogs are dead, the world's on fire, and then as you're dying, it's like, don't drink and drive. So you can imagine sort of situations like that arising. And you might ask, well, what are the importance of this? And well, not only is it terrifying when I say it, but first, research has shown that emotions are felt more strongly and viscerally in VR than in non-VR environments, which makes sense, right? VR is more immersive. And also, we've just begun to scratch the surface about how the brain perceives events in VR as compared to non-VR, right? And how will you process traumatic experiences in a VR environment? And not only that, but you could argue, well, what's stopping ads from you could have a really disturbing ad on TV, and that's true. But the difference is when you see an ad on TV, a bad ad, you can look away. Not the case in VR, right? In VR, you're surrounded by the ad, so no matter where you look, behind, up, down, you're going to see it. And like headsets are usually very bulky, very difficult to take off. So it's not like you can just like shut around. And you could say, okay, well, Abraham, just shut your eyes. And I mean, first, I guess that could work, but the problem is A, we shouldn't expect users to adapt to the technologies, right? Technology should adapt to their users. But B, it won't work because A, you can still shut your eyes, but you can still maybe hear the noises, right? You'd hear the serial killer chasing you, you'd hear the car crashing. But second, because if the privacy risks are to be believed, VR ads could track where you're looking. And they could maybe say, oh, you close your eyes? Well, no, you need to open them to continue the ad. And so, for example, I'm sure you've all seen this Black Mirror clip. So it's this person, they're not in VR exactly, but you can imagine they're playing a game, and then they see a very explicit ad that they don't want to look at. And so they close their eyes, and then suddenly it's like, no, you have to pay attention. And then eventually, you have to open your eyes again in order to continue with it. And one could imagine this happening in VR and being like a lot worse, a lot more disturbing. And the next final harm that I want to talk about today, it's sort of closely related to having traumatic experiences, but it's not necessarily seeing one. It's being forced to carry out a task that you're uncomfortable with, that you're controversial with. So you could imagine an ad made by McDonald's or made by a restaurant where you have to cook a hamburger. And that's fine, right? Nothing wrong with that. But what if you are someone who has fierce opposition to eating meat, or someone who finds it like unethical to do that, and suddenly you're in an environment where, remember, this is interactive, you're not just seeing someone cook meat, you have to perform the act yourself. And that could, cause distress, be very uncomfortable, and depending on the act that's required for you to do, and depending on your own personal beliefs or convictions, maybe it's like disturbing. So this is like a quick overview of sort of the 6 main harms that I've sort of seen throughout my research. So nausea and motion sickness due to badly optimized VR ads or rough and jarring transitions, bright lights inducing seizures, crashing into nearby objects, or muscle strain in case you have VR advertisements that are very interactive and require very strenuous movements, traumatic advertising through graphic and disturbing scenes, and being forced to carry out controversial tasks. So that's kind of an overview of the harms that you could find in VR ads. And when I wrote this, I was like, okay, this is cool, but you might be thinking, hold on a minute. How is this different from the harms you can find in regular VR experiences? Why, Abraham, did you go through all this harm of creating this like physical and mental harms of VR advertising when you could just talk about VR? And to those people, I'd say, you're right. The harms are very similar. I'm a fraud, I should get off the stage and just change my thing. Except, there's like one key difference that makes the harms of VR different, at least in terms of how we address them or how people might perceive them, to the harms of regular VR experiences. And that is that generally speaking, when you enter a regular VR experience, you choose and know what you're getting into. Whereas in VR advertising, that's not the case, right? Think of everything you need to do if I want to download a VR experience. I need to search for it, know that it exists, search it on the store, click on it, go through the store, and download it. Right? If I enter a VR horror game, it's because I went out of my way to get it, and so I know what I'm getting into. But that's not the case with ads, assuming you have the current model in place. Currently, you don't choose what ads you see. You may choose to receive ads, but if I'm watching TV and an ad pops up, I don't know if I'm going to be shown an ad for a sofa, an ad for a car, or an ad for the next Harry Potter film or whatever. And same in VR, right? You won't know if you're going to get an active ad or a passive ad, an ad about kittens or an ad about monsters. You don't know. And this has broad implications because essentially, if I know what I am getting into with VR experiences, I can prepare for them, which is not the case with VR advertising, right? So, for example, I can brace myself for shocking experiences. If I enter a VR horror game, it's because to some level I want to experience the horror. I can brace myself, wait until I'm mentally prepared, and essentially be ready and open and even willing to experience this shocking content. But with a VR ad, that's not the case. I could be doing something completely different. Maybe I don't want to experience horror. Maybe I can't handle horror. Maybe there's like a phobia in the ad that I have. And so for that reason, I can't really prepare myself. And same with sort of interactive ads, interactive experiences. If I'm playing Beat Saber, I know I'm going to jump around. I will clear nearby objects to avoid crashing. Maybe I'll stretch beforehand. And thus, I can mitigate some of these harms. But there could be a situation where maybe I'm just sitting on my sofa watching a movie in VR. Or maybe I'm at my desk working on something, and suddenly there's an ad that pops up that's like, oh, you need to jump up and down, and you need to do these very ridiculous dance moves or whatever to pass it. And I want to get back to my movie, so I'll just get up, do it, and then crash. And so for these reasons, even though the harms on the surface might seem the same, this very simple difference that one chooses what VR experiences to engage with, but not necessarily VR ads, means that we should consider them as their own category. But oh no, Abraham, like surely you're just theorizing, right? Companies wouldn't really want to hurt their users, would they? In theory, maybe you're right? In theory, companies don't want to hurt their users, and so they wouldn't go out of their way to hurt people. But theory and practice are two very different things. And in fact, I can see several ways as to how these bad ads might filter through accidentally. Well, first, it might not be accidental, right? For some companies or some places, like harm and shock may be the intent. Maybe you have bad actors who want to deliberately hurt users. Maybe you have people spreading political messages or propaganda that want to hurt the other side or want to do something like that. Maybe there are some companies or some charities or some nonprofits that want to deliberately cause shock and awe in order to like catch people's attention. So sometimes harm and shock is the intent, right? So that could be one. Another one is maybe lack of oversight or cost cutting, right? Maybe a company does not have the funds or the resources or just wants to save time, and so they don't do their due diligence in making sure that their ad is properly optimized. And also lastly, maybe there's a case where people are simply unaware with the issue, right? Maybe because, especially since VR ads are so new, so innovative, so many exciting possibilities, one person could just simply think that one thing is exciting without realizing what could come down the line, right? I could think, if I'm a horror movie aficionado, I could think, oh my god, it would be really cool, right? If I get to play a part of the victim and I get to fight off Leatherface or whatever serial killer is, without realizing that what I think is cool, other people may find completely horrifying. And so, for these reasons, there is a possibility that bad ads filter through. And to clarify, I'm not saying every single VR ad is going to try to kill, hurt, maim, and torture you, right? I don't think it's going to be all ads, not a majority, not even a sizable minority. I think it's only going to be a very small percentage of ads. But they're still worthy to be considered. Because even a small percentage of VR users, if VR ads are expected to grow, that's going to be like a lot of users affected. And B, because the harms that are felt are going to be so distressing, like it's not going to comfort me if I go through one really disturbing ad to be like, oh, well, you were only 0. whatever% of people. Like, that's still going to be shocking, that's still going to hurt me, and it's still something that needs to be taken into account. So with that, talking about why it's important to address these issues, and you may be thinking, oh my god, Abraham, okay, you've convinced me. There's a VR advertising dystopia, the world's on fire, everything's ruined. And even though I sometimes share that cynicism, I am cynical, but I'm also more stubborn, and I'm also adamant. And I think we can fight back, and I think we can start drafting solutions, ideas about how we could possibly address these issues. So for that, I want to end my presentation on a more positive note and give some ideas about where we could go from here, and what are potential ways we could solve some of the issues that I talked about. So first is the importance of contextual. Yes? No? See, they don't want us talking about the solutions. They're on to us. No, just kidding. So the first is this idea of contextual advertising, which you already see in non-VR environments, right? So it's the idea that, oh, if you are searching for dishwashers, I'll show you ads for dishwashers, kind of matching the content. And in VR, this takes an added dimension, first, of matching content. So if I am in a VR experience that's like family-friendly, only show family-friendly ads, things like that. But also it means aligning the activity required. So I'm in a passive VR experience and there's an in-app ad, I should only get passive experiences. So I don't have rapid changes in what I'm doing and potentially crashing them into my surroundings. And similarly, if I have an active experience, maybe I can have active ads, but mostly try to match it. So that's kind of one way of approaching it. The second is having guidelines for acceptable or unacceptable content, right? Bringing diverse groups of stakeholders, including VR users, companies, advertisers, legislators, nonprofits, advocacy groups, and more, and sort of decide collectively what are allowed things that VR ads can ask of you and what can't. And you already have, I mean, this is nothing new, right? You already, in most jurisdictions, have ads regulating what types of ads can or can't be shown, for example, to children. But the important thing to keep in mind is that VR is qualitatively different than non-VR. And advertising that is maybe okay on a TV screen, the same ad in VR may not be okay because it's more immersive or interactive or whatever. So while we can look to these past guidelines for inspiration or as a starting point, we can't just copy-paste them. We have to take into account the unique circumstances of VR. Third, there should be a way to easily exit ads, right? So allow users to quickly bypass and exit ads if they encounter an ad that they don't want to engage in. And simply, currently, because a lot of experiences, a lot of VR operating systems allow you to just exit to the home menu, that's not enough. Because exiting to the home menu doesn't just quit that ad, it quits the whole experience. And what if it's a really important experience or one you want to engage with, or what if the ad just always going to be there and you just have to like eventually get through it or miss out on an experience. So ads shouldn't be unskippable, and they should be easily, if there's any disturbing content, be able to just like that, move on. Similarly, and maybe a bit more radically, this idea that ads should be not only be opt-in, but should also inform the users of sort of what the ad would entail before actually showing it. So maybe this is a 360 video where you'll be in a park, there'll be a bunch of kittens running around, and then there'll be an airplane flying overhead. Or this would be an interactive ad where you need to play tennis for a few points, and then we'll like give you information about a tennis product. And this way users could take it on themselves and can then know, okay, am I comfortable engaging in this ad? Do I have the capacity to engage with the ad? And hopefully mitigate some of the harms that were discussed before. Another solution is we need more oversight. And by that I mean that current models lack oversight. And with current models, I mean currently a lot of tech, especially large tech platforms, don't manage every single ad that is shown to users. Usually you have middlemen called advertising networks that connect would-be advertisers to the user that they see. And so a lot of times there's like Google, for example, on YouTube does not directly decide who gets what thing. It's like their ad network, or it's a separate service. And the problem is this means there is a lack of oversight and lack of vetting of each individual ad. And given the harms that VR can cause, there needs to be more robust mechanisms for verifying that ads comply with standards and making sure that bad actors can't get through. And the final thing I want to talk about is maybe a little bit boring, but it's kind of raising awareness. Right? Like I said, part of the thing that motivated me to talk about this harm above the others is because I feel this harm hasn't been talked about as much, and because I think that a lot of the ways that these harms could be realized is not through malice or bad intentions, is by people who are developing the ads, like not realizing, oh, this is the way that this could be impacted, this is the way that this could hurt people. And simply, if you know people in industry, if you know people who are working on developing these, if you are a researcher and you're looking for a new research direction, raising awareness, learning more about this would be important. And so with that, I want to conclude my talk. hope that today I've managed to show you that VR ads can pose physical and mental or psychological harms to users, how the unique context of advertising, namely that you don't choose what ads you engage with, means that it's not just VR harms extended, they're like two different entities and require different solutions. And I pointed to possible solutions including the need for contextual advertising, exiting ads safely, having appropriate guidelines, and raising awareness. I love talking about this. If you agree, even if you disagree, I love being challenged on my ideas. So come talk to me coffee break, or you've got my website, my email. That QR code takes you to my website, my Twitter handle. And with that, I will conclude my talk and leave you to your coffee. Thank you.
Thank you very much, Abraham. So yes, just to confirm for everyone, this is now the initiation of our first coffee break of the day. So for those of you who've been politely waiting for your first cup, if you just arrived a bit late, you no longer have to wait. We'll be back in 15 minutes for the next round of talks.
We rise and shine, we are the future, we design. coded, loaded, started, scanning, crafted, lighted, charted, link it, sync it, scale it, frame it, map it, mod it, forge it, name it, render, blend it, shape it, stream it, plug it, play it, move it, dream it, test it, flex it, lift it, scan it, feel it, view it, touch it, span it.
We are the dreamers reaching high, breaking through the limits of the sky.
Build it, code it, load it, start it, scan it, craft it, light it, chart it, link it, sync it, scale it, frame it, map it, mod it, forge it, name it. Render, blender, blend it, shape it, stream it, plug it, play it, move it, dream it, test it, flex it, lift it, scan it, feel it, view it, touch it, span it.
We are the dreamers reaching high, breaking through the limits of the sky.
Build it, frame it, scan it, dive it, code it, launch it, drive it, thrive it, wire it, link it, craft it, phase it, live it, breathe it, set it, raise it, loop it, map it, tweak it, shift it, shape it, break it, lift it, drift it, plug it, play it, see it, be it, dream it, stream it, now let's free it.
We are the dreamers reaching high, breaking through the limits of the sky.
Link it, live it, dream it, fly it, push it, play it, reach and try it. In this world we rise and shine, we are the future we design.
Okay, can I call everybody back from coffee now? Please take your seats for the next presenter. Hello. Hi. Is it possible for people to take their seats? Okay, I'd like to introduce now Leon Krojek, I think that's right, from Regensburg University. He's a master of psychology, I think, and he's going to talk about generative AI and social interaction. So let's give him a round of applause and welcome him to the stage.
Thanks. Thanks for the nice introduction, Maxine. Can you hear me, everybody? Okay, great.
Yeah.
So today I'll be talking about a topic we've heard quite a lot about yesterday and also today. And I will be talking about how we can use generative AI in social interactions in virtual reality and what effect this has on user experience and behavior. And when I talk about generative AI, what I basically mean is that, does the pointer work? Yeah, talking agents. And the nice thing is, once you have your agents talking, you can also sort of manipulate what these agents are saying and how they say things. And this talk is going to be about the influence of the communicative style of a virtual agent on user experience and behavior. But first, let's talk a bit about social interactions. Social interactions are a fundamental part of all of our lives. Like every day when you step out of your house and you see other people, you start to interact. Might be very short interactions, just the exchange of a glance. Might be a bit longer when you're at the bakery, standing in the line, or if you're talking to the cashier. Or might be like deep conversations, for example, here at a conference like this. And they also have a very strong influence about your experience. Because at the end of the day, if you think about what was nice, what made you feel good, what made you feel bad, you often think about these social interactions. So they are very important for our lives. And as a researcher, as a psychologist, I'm of course very interested in studying these effects of something that is so important. But in the lab, it's really hard to study these social interactions. Because you know, as soon as two people are in the same room, things start to get complicated. And of course, while this is quite nice for soap operas and whatsoever, it's not so nice if you want to conduct controlled experiments. And as you might have guessed, because you are here at this VR summit, VR is a technology or a tool which might help us to study these social interactions. And we have also done this. For example, by looking at facial expressions, yeah? Like when you smile at someone and the person smiles back at you. You can nicely manipulate that with virtual agents. But you can also look at actions, for example, yeah? We looked here at a punching action and participants had to defend of these actions, and you can look what makes people faster to respond to an action like that. Or you can also look into a public speaking scenario, yeah? Like give people talks in front of an audience, just like that here, and then you can manipulate the behavior of the audience, yeah? Looking very interested, just like you now, thank you, or looking very bored, yeah, like yawning and stuff like that. And these are certainly interactions, but they are not all verbal interactions. Even in the case of public speaking, only one person is speaking, the other ones are just passively sitting there, reacting non-verbally. But in real life, a lot of our interactions are verbally, and we want, of course, to study these verbal interactions as well. So, what about conversations? Of course, you can implement this in virtual reality. Yeah, you can record sentences, and you can have them play at a specific time point during your experiment, and you can sort of like draft a conversation and then have this back and forth. But the problem, of course, with pre-recorded sentences is they are not very flexible. And it will probably only take a few sentences, if if a few, maybe just the very first sentence, and participants will know that this is not a real exchange, it's not really the conversation partner reacting on them, it's something which has been defined before. So, what can we do about that? And one possible solution, which I will be talking about today, is generative AI. Because large language models have been developed on like a huge, trained on huge data sets, and they are very context sensitive, and this all gives us the possibility to create output which is very finely tuned to the input questions. So the responses you have are actually plausible responses, they are context sensitive, and they make allow for individual exchanges. Yeah, so if the participant decides at some point to start talking about his favorite elephant, I don't know, and the model could react on that. Yeah, and the experimenter might not have thought about that before, that this topic might come up, but the participant decided to do it, and here is a way to react on it. And because this works quite well, it's of course already used in numerous applications, but most of them are text-based. Yeah, you know chatbots, you probably have conversed with them already, and this is also some form of interaction and communication, but you might say it's only part of the picture, yeah, because like a real social face-to-face interaction includes more than that, and it's not just via text, and some things might even get lost if you only look at text communication. So the next step then would be to give these conversational agents, that's a chatbot, give these agents a body. And that's what you can do with embodied conversational agents. And there you can present like a virtual human, or doesn't need to be human, a virtual character in virtual reality, having them like face to face. And now you can start to engage in the conversation. And it's not via text, you can just normally talk and you will receive answers. And here is like, here as well, I used another generative AI to think about how this could work or how this could look. And if in a minute you will see our experimental setup, it looked pretty much the same, but we just didn't use this holographic agent. We used someone who looked a bit more human. So what did we try to answer in our study, which I'm talking about today? Well, the first thing was more about feasibility. How can we do that? Can we combine a large language model with a virtual agent? Can we embody the conversational agent? Just wanted to know, of course, does it work at all? Spoiler alert, it does. So we can now explore a bit more interesting questions, like can we directly change or manipulate the experience of the user by varying characteristics of our language model, of our AI. And we tried that by using different communicative styles, like by describing the personas of the large language model to be, for example, very friendly extrovert or more neutral, so that we would then compare the experience with conversing with these two different personas. And then we were also interested into task effects, because you might imagine, like if you talk to someone, very talkative, very good in small talk, likes to tell you all about this last weekend and so on. It's very nice if you're like in a party situation, doing small talk. This is very, very pleasant. But now imagine that you are very focused, yeah? You would just want important information from this guy, and you definitely have to concentrate on your task. You're not in the mood for some extra information about the weekend. So this is some effects, like where you have different tasks, and the persona of the person you're interacting with might be experienced very differently depending on your task. So let me show you our setup. So on the left side, you see me, wearing the HMD, and I was in a very plain virtual environment, which you can see here on the right side. So there's nothing really more in this room. It was actually a real laboratory room at our university. These are not very colorful, unfortunately. So it was just a plain room, and you were sitting face to face with a male agent like this. And then we, of course, let our participants talk, let them ask questions. I explain that in a minute. And we recorded the speech via microphones, and then we used a speech-to-text model, which resulted in a text, because these large language models, they still require some sort of text. And this text input was then just the prompt we gave to our model. And the model created or generated some sort of output. This was also text, so we did the way back around and had like a text-to-speech conversion, and then we could use this these speech files, animate them, lip-synced, so that you could have now the virtual agent having actually producing the sentence verbally. And one thing which is, I think, very important in this regard is like, how fast does it work? Yeah, what's the latency of it? I think this is still some point which needs to be improved. We had a latency here about 1.3 seconds, which is slower than we have like in a face-to-face human-human interaction, but it was acceptable for our participants. But of course, I hope this will be faster in the future. And another point I want to mention here is that all of these components were installed and running locally, like just in our at our own servers, and so we didn't send the data to OpenAI. And I think actually this is an important point, because like if you're having like user data experiments, you also need to think about GDPR and stuff like what happens with the data and what participants actually know about what's happening with their data, and do they consent to this. And I mean, this is something also very important for running experiments. So that's why we decided to not give any data away, just to have it run at our own servers, which comes with a small drawback that you can't use, or at least we couldn't use, the biggest models, yeah, not the complete newest ones, which require quite a lot of hardware resources, but we used like more accessible models running on smaller computers. But actually, which is nice if you know the Hugging Face framework, you can get models which run quite well, also for example here in German. So this is something very, very, very useful. And like I said, we did some manipulation, and you can see that here on top, we gave the language model an additional information about the persona, about characteristics of our virtual agent. And here you can see some excerpts of these descriptions we fed into the model. So like I said, we had this friendly extrovert version. So they were both called Moritz. We didn't want to have anything different from the name. But the one is described here as a very extroverted character, sociable, likes talking, likes to engage with other persons. While the other one is more neutral. Yeah, he's not unfriendly, definitely not. But he doesn't enjoy it that much. And if he gives answers, he's more he likes to have them very short, and enjoys more being alone. And everything else was kept constant, of course. Yeah. And so we had the same appearance, and so there was nothing else that we did change. And of course, if you if you introduce such a manipulation, and before you start testing participants, you want to know, well, does it have an effect at all, or do we just does it matter at all what we write into these persona prompts? And that's why we did something which is very something which you can easily do in psychology, like do one of these standardized personality tests with our language models. And you might have heard about these, the 5 factors describing personality. So I'm not talking about if this is the perfect model to describe personality, but it's very commonly used, and you have like some dimensions, like here extraversion, openness, neuroticism, and so on. And they are used to describe personality variations. And now if we like give these questions to our language model and just see how the model answers these questions, and we did it actually here like 100 times because the model doesn't care how often we ask them, you see that there are some, interestingly, there are differences, but not in all dimensions, yeah? Like, for example, here with respect to neuroticism or consciousness, we didn't really give information here in the prompt, and they didn't really differ, our 2 personas. But like here, if you look into extraversion, which was, I guess, the trait which we mostly addressed in our prompts, then we found differences here. But of course, you might say, well, it's a questionnaire. How well does it work in humans? Of course, we want to know if there's also something else which we can, like, more like a hard metric or so we can use to describe differences. And that's why we also looked in the quantity of speech. Yeah, like our model, when it was talking, when it was generating sentences, how long were these sentences? How many words did the persons use? And here you can see all of our participants' interactions, but this data is from the model, so what was generated by the model. And you can see also that here, like the friendly extroverted persona was much more talkative than the neutral persona. So there is also like a real effect on the output behavior of the model. And then, of course, so this was just to see if our manipulation works. We ran our study, and one important thing is that our participants, they didn't interact with both personas, yeah, because this would have made the differences very salient, I guess. They only interacted with one persona, and it stayed like that for the whole experiment, yeah, so they didn't switch, like 2 tracks between subject design. And then we had them, like I mentioned in the beginning, we had them perform different conversational tasks. The first task was small talk, yeah, because we had to introduce themselves, or had to the agents, or better, the agents had to introduce them. And this was done by, we had some predefined questions, and they were displayed in VR on the table, and we asked them to ask these questions to their interactive partner. So this was scripted. This is also something you can do with pre-recorded sentences, but it also gave us a bit of experimental control about what topics they will go into. But then we had them give another instruction, which was, once you have asked this question, you're free to follow up on anything your interactive partner says. Yeah, so the question, it would be here, do you have sisters or brothers? And the model would say, well, yeah, I have 2 sisters. And then the agent, the participant was free to ask, are they younger or older? And do you like him? And so on. Yeah, so this was completely free. It would also have been, or it was also possible for participants to just skip to the next question. Yeah, they were free about that part. Took about 8 minutes, and the next part was then a knowledge test, because that's often how we use ChatGPT or so. We like in everyday tasks at work or so, you just need to know something, and you don't want to Google it, so you just asked ChatGPT directly, and then you get an answer, and then the question is to use that answer or not. So this was the approach to do it like that. So we had now questions about like every world knowledge, if you want. So here, for example, what's the highest building in the world or so? And they had to answer the questions themselves, the participants, but they were free to ask the interactive agent for help. Yeah, so if they didn't know by themselves or they weren't sure, they could always ask the agent, like, sorry, can you help me here? I need to answer this question. And we also had like different categories of questions, which were mostly like differentiated on how difficult they were, so we had easy and hard questions. So the last task was now also a bit more social focused, but it was also focused on argumentation. We called it convincing, and the approach was pretty similar. So you had like another question presented on the table, and this was, for example, what do you prefer, cats or dogs? And our participants asked this question the model. And the model was also instructed by us to give one specific answer, because we told the model, you like dogs better. And this was, for example, done because we didn't want the model to think about an answer themselves, because then this might be different between our personas, and then people would just like the person who likes dogs better or so, because they like dogs better themselves, and we wanted to control for that, so this was instructed, and they had a range of these questions. So now the model said, I like dogs better. And the task, actually now the task really began, because now participants had to start to convince the model of the other option. So model said dogs, and now they had to say, participants had to say, yeah, but cats are a lot better because they are so fluffy or whatever, because they are so intelligent, or whatever you could think of. Even if they personally would say that they agree that dogs are better, they should just go for an argumentation. So we did all that, and like in the end, we asked participants to rate their interactive partners on like a social dimension, like sympathy. They had to rate their own emotional experience, like how pleasant they felt, arousal. Also, we looked into how naturalistic they thought the interaction was going. And we also tried to look into behavior. So that's why we also used our like speech quantity metric, which we had looked into with the models before. So we just said, how talkative were our participants? How many sentences were we talking? How many words were we using? And so on. This was something easy to measure, because we had like their speech transcribed to text anyway. Okay, let's look at the first results. And this is like interacting with these models. How does it change how we feel about the agents? Do we like them better or not? And here you can see the data, and in red you see the friendly persona, friendly extroverted persona. In blue you see the neutral persona, and you can see across these 3 tasks they always like the friendly extrovert person better. So it was rated as more sympathetic, and of course this is something we were looking into. This is the expected effect. What's interesting is that this was actually in all of these tasks. So the difference was there in all tasks. That didn't really matter. Might here be as well that because they started with the small talk, then they just kept with their evaluation. That's also possible. When we look a bit more into the task effects, you see that overall they liked the agent in the in the knowledge test task the best. So and this is also you can think about it as like a helper effect, because they got something useful from the agents. They actually helped them. Now they also transfer this into a social evaluation, and they say, well, this guy is really nice. Now let's look a bit into the behavior of the participants. So, like I said, we measured all kinds of stuff, like how many words they produced, but we also looked into how many of these questions which we were giving to them to ask, how many did they reach? How far did they get in this 8 minutes? We had like hundreds of questions. No one reached the end, but still it was like individual differences, how many questions we were actually asking. And here you see that they always, like also in all the 3 tasks, they were faster, if you want so, or reached more questions and topics with a neutral persona. So I wrote here they were rushing through. But you can't really tell from this data alone that they were rushing through. You have to look at what per participant's doing during one single question. And this is what you can find here, because here you find the reverse pattern. You see here the number of words our participants were actually speaking in one conversational task, on average per topic or question. And here you see, like, compared to the table above, it's completely reversed. So while they reached less questions overall within the 8 minutes, this was because they were talking a lot more for every single question or topic. So if you like remember, they were free to follow up. They did it more in the friendly condition, or that they were more effortful in trying to convince their agent if this agent was perceived as friendly extrovert. So, and this actually, in this task, the convincing task, this behavioral effect was most pronounced. Okay, and the last data I want to show you is about the knowledge task. Because, like I said, they had the option to ask the agent for help, but they didn't have to. Yeah, they could have answered all on their own. And so we asked, like, maybe they will ask more the friendly version, yeah, because the threshold might be lower or so. And but interestingly, there was no effect of persona in this task. Yeah, so of course we find, like, in general it did work. They asked for the difficult questions. You see this here on the left side, in the left figure. They asked more for help than for the easy questions. Well, this makes sense. And they were also more confident in their answers once they had asked the agent. Yeah, so if they had additional feedback of the model, then they felt more secure that this is the correct option. But in none of these parameters there was any effective persona. Yeah, so it seems like this using the help of the agent and confiding in how correct it is not really influenced here, at least with this persona manipulation. So this is interesting because it's a very common task, and I guess it will be used more in the future. So it's important to understand these effects. So let me conclude. Overall, yes, it's possible to use generative AI, and I think, like, coming from like basic research interested in social interactions, this is a very powerful tool if we want to present naturalistic interactions, which are also complex, where we look into the back and forth between participants and an interactive partner. And it will also allow us to investigate characteristic effects. Yeah, so we do find clear effects of the persona, not only on how participants felt, but also on how they acted. And this will also might have an impact on how we use these AI models in all kinds of applications. Think about psychotherapy or so, and or more like, for example, in a car. This might be very useful. And we should also start to look more into these task effects, because from this picture here, I mean, it was only a very small task variation. We do find effects, and we do find that if you're more like on a task-oriented state, so you would just want to get through the questions, answers, these persona effects seem to have less of an impact. But there might be other tasks where they are more important, and we should describe these options. So I don't know how I'm doing on time, but just to give a very short outlook. So now I started with a nonverbal behavior going to verbal, but I think that it's important that you have the full picture. So the next step will be now to go back into these nonverbal facial expressions, for instance, and to have like another AI sentiment model characterize the agent's the model's responses, and then to like deliver synchronous emotional expression with that. And with that, I'd like to thank you for your attention, and I'm happy to answer questions in the next coffee break. So, thank you.
It's me again, just introducing. So this is Neil MacDonald, Professor of Philosophy at the University of Glasgow. And Neil's going to be talking about XR and education and lessons from practical experience. I always love practical. Theoretical is amazing because I'm an academic, but I like practical too. So here's Neil.
Thank you. My clicker. Thanks, folks. It's very nice to be here. I worked briefly in Hamburg University here in Germany, and being back in German academia has a quite distinctive feel about it. It's much better provisioned than some we have back in the UK, so it's nice to be here. I was asked to talk about XR and education, and I think there's a good reason for that, and I'll take you through some of the things that we've done, but really the purpose of my talk is to get to the takeaways at the end, where I want to tell you the things I think are important for people to bear in mind when they try and think about combining XR technologies and education. So it really is those lessons from the practical experience of deployment that we've been doing at the University of Glasgow. So by way of introduction, I was the lead on a project called Project Mobius at the University of Glasgow. That then gave rise to a product that you can now go and use called Edify. It's a VR learning platform. And as a result of that project, we built some labs, and I chair those labs, both on the research side, but in this case on the teaching side too. So their kind of functional operation, their budgeting, who gets to use them, under what conditions, and strategizing about what equipment or software we might need next. That kind of sits on my desk. I was also the principal investigator on a project we called Scoping Extended Educational Realities, or SEER for short. And we published an XR Ed policy project last year, a paper and report, so a sort of long report and then a short, sharp white paper, and we were supported by Meta in this. I think it's important to say, as I always do, that we were, as we said, editorially independent. They gave us a donation, and then we could say anything that we wanted, and we did. And some of that is critical, but very much the reason we were embraced to do this is we've seen the potential for XR in education, and we've seen what's wrong about how the equipment and software platforms are at the moment, and we had recommendations to make, and so we made them. I'm very pleased to say I think they're listening, and not just Meta too. So it starts with this project I alluded to before, Project Mobius. So that ran between 2018 and 2021, and it was funded by the UK government. So it's quite unlike a normal academic or university project, because it was an innovation project. The idea was to create an economic tool, right? Something that would make money, frankly, for the United Kingdom or companies in it. And this is a distinct sort of thing that the UK is embracing more and more, about how universities can be an engine for innovation and for producing financially viable, financially sustainable products, and Mobius was an attempt at that. But of course, government only back things when it's at a certain risk profile, right? So if venture capital would give you the money for it, you don't need the government's help. But if you're more risky than that, then that's the sweet spot where government intervention is supposed to help you build the next big thing. And that's what they backed us for. Not a huge sum of money in the context, about £1 million, but from an academic side, that was very welcome indeed, particularly for those of us like me who are in the arts and humanities and philosophy. That's a lot of money. But with that, we built, on the university side, 10 apps for teachers, for teachers and by teachers. So what we did was we ran this competition internally, and we said, if you were to get your wishes to come real, what would you use VR for in your teaching? So there what we're trying to do is get teachers to think about the puzzles as they, the experts in that domain, understand them, and then come to us. Now, some of them weren't apt for XR technology, right? They weren't good at using the things XR is particularly good at. Some of the ideas could be a YouTube video or a 2D app, right? So they weren't apt for what we wanted, but they were relatively small as a percentage of the ideas that came forward. And the ideas that came forward were really, really powerful. And we selected 10 of the best, worked them up into something even better, and then we were able to build them over the course of this project. But not just build them, we had to deploy them. And this is where we used some of the funds that we had to build 2 VR teaching labs, and I'll talk you through them in a minute. But look at the spread of topics that we were covering. There was data visualization, there was physiology, there's a geology field trip, which are expensive, and accessibility problems. We have this excellent physics app, which we hope to publish standalone soon. And you could go and print your own page on the Gutenberg press, right, as part of a history lesson. So this breadth of ambition was really about trying to find out, where does it work, where does it not, and why? And that's what that project was all about. This was the first lab that we built just immediately prior to COVID kicking in. And that was a real challenge, as you might well imagine. We couldn't get people in to put their heads in headsets. But this is what we built. It's a grade 1 listed building. Now, what that means in the UK is you're not allowed to do anything to it. You're not allowed to screw a hook in a wall, right? Nothing. So we had to build this stage rigging out of aluminium stage rigging to host everything on that, which isn't great for, like, at the time, Vive sensors or beacons that bounced around. We had to suspend the screens from the ceiling. We had to use a coat hanger turned upside down to hang the headsets on, and so on. Because we're trying to maximize the floor space and allow a teacher to be able to scan the room and see what was going on and communicate simultaneously with everyone who was there. That sort of classroom management side of things was really difficult to manage and really important. Moreover, what you don't see in the picture is that this is about a 10-minute walk off campus. And that's not ideal. That actually makes a significant fall off in the number of students who show for their sessions. So we're learning a lot, and it's not ideal, but it's an amazing thing to have been able to do. We can take classes of up to 30 people if they swap, in pairs halfway through, and to be able to get a fully 6 degrees of freedom XR experience as part of their learning. And we've deployed our mobile apps across here. There are now thousands of students each year taught in this facility, which is really good. And the university has backed it beyond the project, so we've been allowed to renew all of the equipment in there and hire a permanent lab manager who makes it work for everyone and sort of makes the process straightforward for teachers. It's really amazing that we get to do this. The second lab was a standalone lab, which I can't show you a picture of because it basically didn't work. This was when Quests were initially launched, and there was Quest for Business, which was what you could go, or Oculus for Business as it was at the time. And you could buy these headsets that were for corporate use. They could be centrally managed and so on. What they promised on paper and how they worked in practice were wildly different from each other. And one of the just many crucial roadblocks for us was if we wanted to support a student. In the last lab, we can just look on the screen behind them because they're using PC VR. But if you want to support somebody in a standalone headset, you need them to initiate a cast. And on Quest for Business or Oculus for Business, to initiate a cast, you had to type in the administrator password for the whole university. Right? You can't deploy that. And the reason we had to go for the business models rather than the consumer ones was this is the time where Meta decided you had to have a Facebook login for using their headsets. But then you can't deploy that across the student body and make people do that as part of their education. So this is why we get a 404, right? This just didn't work. The pop-up deployment was really cool. We could use it in a student bar in the hours it was not being used. When I was younger, that was no hours in the day at all. But these days, it's not really used until about 5 p.m. or 6 p.m. So you can use it as a pop-up lab. You can use clean boxes to store them and clean them and charge them. You can take them out 1 minute and back in the next. There's a really rapid deployment available here. But the hardware and the software and the platform just didn't fit. And the licensing of the software that we might want to use didn't fit. So we mothballed it. We've put that one away. And we're hoping that with new changes coming online now, that we'll be able to resurrect this because it's such a good deployment. But it's important that I can't show you a picture, and it's important that we're honest about the why, because we can learn from that practical experience and take it forward. Mobius became Edify, as I mentioned before. It considers itself a virtual learning platform, and on it you can build your own lesson. Now what we mean there is anyone who can use PowerPoint can drag and drop objects around, annotate them, bring other tools together to make a virtual lesson, and deploy that. What we don't get are complicated interactions, right? So this is very much closer to what PowerPoint can do than Call of Duty or Fortnite, right? It simplifies the tools to make it available to anybody. At the moment, if you go and start to use this, this will be free. right? And it's only when it gets to scale in an institution that it starts to incur a charge at the moment. And it's across multiple different platforms, and it's tailored to teachers. It was very much about trying to be a tool for teachers and by teachers, and that's where we got to with Edify. So there's the kind of project history up to a point. What I want to now do is pivot to what we did when we were asked to announce our recommendations, right? We were given the opportunity to hire some people, to put in some work over about 9 months or so, and to write a white paper, a short, sharp document for policymakers to just absorb very quickly in a few pages, and then a longer report that had much more information and reasoning behind each of those recommendations. If you're particularly interested, go for the report. If you're not, the white paper. That's roughly the patience level we expect. So I'll just go through what we got to with this. I'm going to pick out 2 particular principles that I want to highlight. These are not the only ones we talked about, but these are 2 that I think are important. And then I'll talk you through a couple of steps that, in what we created as by way of an illustrative lesson. So that illustrative lesson is not what you can do today with today's technology, but let's imagine something 10 years hence. Imagine how the classroom might operate, what could be taught and how it could be taught. And by articulating what that would be like in an ideal scenario, we can then infer what the to-do list is and where the barriers are for the sector. That is the technologists, for government and policymakers, but also for the technology sector and for educators. Okay, but I'm going to start with what XR can do, which is no news to anybody here, I'm sure. But this is how we decided to break it out for the teaching audience that we imagined would be taking this in. So we start with the very obvious one, that you can visit places that you cannot visit in the real world using XR technology in teaching. Now, this is where we'll find this, the very well used and very on point work from Jeremy Bailenson, identifying that this really works well when the places you're trying to go are dangerous, impossible, either counterproductive or damaging to go to, or expensive. So this DICE acronym. I think it's extremely useful. But what the teachers were telling us on the project was that felt like a talk about where you were and what was happening out there. It didn't seem to be talking about the learner. So what do we say about the learner and what they get through this? Well, they're able to do things that they couldn't really do. They're able to experience situations that they couldn't experience. They're able to see objects or environments from a perspective that they couldn't in the real world. And they get to process 3-dimensional information in a 3-dimensional medium. Now, that last one I just want to stick on for a second, because I think that is that disguises an important accessibility benefit that XR can bring. So when reading the sat-nav for how to get from A to B while driving, I am notoriously bad at interpreting what it's telling me versus the 3-dimensional world around me. My wife is much better at it, hence the fights, right? So I'm trying to drive from A to B, and I'm not good at taking the 2-dimensional information, live translating it into a 3D world. But if that information was laid onto the world in front of me in 3 dimensions, I wouldn't have to make that translation anymore. Now, I think in general, I'm probably quite good in the general population at making that translation. I navigate the world quite well. But not everybody does. And I think the moment you realize that there is a cognitive cost to translating 2-dimensional information into a 3D picture in your head, it's a task, right? It takes some resource. That resource will not be equally distributed across all of our learners. It won't be equally distributed. And yet we expect them to do it in architecture, in engineering, in any of the topics around chemistry where you've got 2-dimensional representations of molecules that are fundamentally 3-dimensional things, and it changes how they act. And our teachers told us this. These are 3D problems. We want to show people it in 3 dimensions. So I think there's a massive accessibility benefit just from that last dimension there that I don't see talked about too much, but I think is an important one to highlight. Okay, so there's 2 principles that I want to highlight here that, as I say, are just a subset of the ones that we talked about in that paper. One of them is alignment, and the other one is ambition. So by alignment, I'm using that in a slightly technical term in the way that I was taught about how pedagogy works, about how learning and teaching works. So the first step is you've got to think, what am I teaching and why? What is the purpose for which this lesson is being created? And in our context, we call these intended learning outcomes, ILOs. Some other people call them learning intentions or learning outcomes. They come with different names. But the point is, a teacher at the start of a lesson ought to be able to tell you what the point of the lesson is. Like, what's the outcome? What do I want you to be able to do at the end? And here, fun and engagement along that path are very welcome, but they aren't the why for which you're doing this lesson. The lesson's got another purpose about it. And I think all too often, XR technology is used for the fun and the engagement, but not having been aligned to the intended learning outcomes, the why that you're teaching it. And this is exceptionally important when you come to the last step. How do you get these facilities that cost money? How do you get the platforms that cost money? How do you get the software that costs money if you can't make the case that it's going to make the impact that the people with the money care about, the intended learning outcomes? You're going to need to evidence that it works. Not works to make people smile a bit or remember an exciting time they put a headset on. They need to work in terms of those learning outcomes. And so, one of the points of advice that we come up with in this work is to say, ensure that your experience is aligned to the intended learning outcomes for which you're teaching. But then that relates to a second one about ambition. When you've got these superpowers, right, when you can go anywhere, you can do anything, you can break things without consequence, you can violate the laws of physics, you can do anything. And when you can do anything, then you should teach different things, and you should teach them differently. You should stop trying to take the way you were taught something and the things you were taught before and simply work out a VR way of doing the same thing. But rather, you should expand your horizons. You should embrace a more ambitious thing. So XR Ed, as we shorthanded it, XR Education, does not just provide a new means of teaching what we already do, but it enables us to broaden the horizons of what it's taught and indeed how it's taught. But to see that really requires people with a certain amount of vision or imagination or ambition. And I think that's really important to embrace. You've got alignment on the one hand to make sure you do what you need to be doing, keep your eyes on the prize. And the second one is, well, change what the prize is, because it could be so much more than it has been before with these new amazing tools. Okay, so now I'm going to just lastly go through some of the pieces of some excerpts of our illustrative lesson. And I want to just tease out bits of it. Now, I've copy-pasted big chunks of text. Don't worry about that. I'm going to just pick out a few portions of this to try and illustrate something that I'm going to make as a takeaway at the end. For anyone wanting to bring XR and education together, I think this lesson's a really interesting one to look at. So, this is a lesson for 2035, right? We just wanted people to stop worrying about what technology can do today, how heavy it is, how hot it is, how expensive it is, whether or not it's Apple or Meta. Just let it go for a minute. Imagine the technology can do all the things that something like an Apple Vision Pro, if we could all afford one and it was lightweight, could do. Something like that, okay? And we want to see what that would look like in a particular type of lesson. And we just picked, because we are parochial, an Iron Age Scotland lesson that might take place in a school. So this is how we set it up. We said, look, we're going to be exploring the Iron Age. That's kind of the purpose of the topic that we're dealing with here. And we're going to use it, XR teaching in there, but we're going to integrate it, right? It's not all XR. You don't disappear off into a headset for 3 days and come back out again. Like, this is supposed to be integrated. You're supposed to come in and out of using the technology, a notion we call transition. So what we wanted to do was get people to focus on, or the students here in this lesson would focus on artifacts found on an Iron Age site called Brock of Gurness up on the island of Orkney. A really quite amazing set of things. Nobody really knew that the Romans had got that far, and maybe they didn't, but we found Roman pottery there, and this makes it a really interesting sort of case study to talk about. So that's why we picked it, but what we did is we made it so that the setup was that during a trip to Orkney, the students used their XR glasses that were supplied to every student as standard. That's quite hard to imagine when you think Apple Vision Pro, right? But iPads have been rolled out across entire educational districts. If we're thinking about something that costs what an iPad does, then this power should be available to teachers roughly as iPads are today. But that's an important thing to think about the equality, about every child having access to the technologies. I think Maxine said earlier about there being no cost barrier. I think that's a really vital thing to consider. We also have it that somebody, a shielding pupil, somebody who maybe can't be out because of the next virus, right? Or somebody who simply can't travel for any number of different reasons. They could be there virtually through the medium of these headsets. So you see what we're doing. We're trying to say some things about what the setup is and tell a story that's not real. And then on this side, we're trying to draw out some really important aspects of what this can do. And indeed, some barriers along the path of here to there that we've got to address to make it work. So we produced this little GIF that was supposed to try and do some of the illustration around this. Can I just, on the off chance, did anybody see this before? Has anybody seen this anywhere? Familiar? No? Interesting. Meta gave us credits to push this out, and roughly 7 million people across Europe saw this. None in the room, apparently. Or you don't remember, which is the other thing as you swipe rapidly past it. But it was a quite incredible reach from a few thousand credits from Meta. Anyway, this was our way of just trying to give a shorthand of what this illustrative lesson might look like on site. And this is what Midjourney thought when we fed it into that. That by the time you've been on site in Orkney, you then come back to the classroom and you can bring it with you, right? And we can now sit around and have a shared virtual experience. Okay, so a second extract here, I want to highlight the bit in the middle here that says, Jessie is visually impaired and uses haptic input and AI-driven audio description of the virtual scene to join in a task that's about recognizing parts of a pot. So the important thing here is that these devices can see and hear for you, and with AI interpreting the world around them, they can feed that information back in another modality, something useful to the person using it. Now that could be, for somebody visually impaired, it could be audio. For somebody audio impaired, you could get visual representations of sound, as you can maybe see in the demo at the side. So the idea here is that we can use these technologies, use the power of these technologies in order to create an expansion in accessibility. But we've got to be honest that that is because this is a profoundly visual medium today. And a visual medium today excludes a huge number of people from that educational portion than standard teaching approaches might. So we've got to be cognizant of that, right? It's not all good, and nothing you could hear from our paper and the like would have you believe it, right? But there are real good benefits to be had, and we should identify them and get to them as quickly as we can. Second thing is that Fran is not visually impaired, but finds the haptics useful as well for accessibility. Okay, so this is a notion of universal design, the idea that if you design it such that it is helpful for one group of people, you don't know who else is going to benefit from it. And that's a really important concept in education in general, but in design. And we think that the VR world is ready to adopt this a bit more broadly than it has to date. So the last thing I want to say about this is that what we've learned from trying to deploy XR teaching at scale in a university is that classroom management and communication with students while they're in headsets is a distinctive new challenge. But we think that, again, there's barriers there, but there's opportunities too. So imagine that the class need to focus on something that's no longer an XR portion of their lesson. They now want to focus on something that's in front of them, something in the real world. And the teacher can simply say hollow off, and the whole class's hollow effects will disappear, except for those accessibility gains that we talked about before. They can stay. This is roughly equivalent to how iPads work in teaching classes at the moment. You can say iPads off, and everybody's screen goes off, and they can stop watching YouTube or whatever it was that they were doing. But I think that's really important to consider. How should a teacher communicate with the class in these devices? What tools can we give them? And there, towards the end of the class, we imagine that they're losing patience. The students aren't paying as much attention. You can tell the noise level starts to rise in the class, and you can't talk over them. And instead of shouting, as I was shouted at as a kid in class, or these days they do some clapping techniques or something else to draw attention that slowly brings the class back to attention. Why wouldn't we use the tools that we have? Right? Maybe we can have some noise cancelling effects, maybe some visual draw that makes them look towards the teacher in order to draw that attention in as part of classroom management. Okay, some people don't like that last one. They find it invasive in some sense. I don't, as it happens. But the point is that we've got powerful tools to aid classroom management, which is a significant problem in how teaching is deployed as we have it at the moment. So we can use the tools to do that too. Okay. So I'm going to wrap with these takeaways that I promised at the start. The purpose here was to give you some reason to think that my experience had something to say about it in that first portion, and then to talk about a few of the excerpts from our work next. But here's the ones I would like people to take away for this event, which is consider the full user journey. And I mean that starting long before a headset goes on. I mean, think about how far they've got to walk off campus. What clothes are they going to wear? Where are they going to hang up their jacket? When did you tell them not to tie their hair up that way? Did you tell them to bring along their smaller glasses or their contact lenses? It keeps going on. But think right back at the start of the user journey and think it all the way through. And classroom management is a particularly important aspect of that user journey. How are they going to get their instructions? How do they get help if they get stuck? Who's going to keep them right? What did they hear just a moment before the headset goes on? And what do they do afterwards to reinforce the learning on the other side? How do you call back to this? And how do you check that it worked? So that I want to consider a full arc. Certainly, you should embrace what XR can do. It takes time and money and effort to have an XR deployment in education. Make it worthwhile. Don't just do what you could have done on a YouTube video. Don't just do what you could have done on a two-dimensional app. You've really got to expand the horizon, so embrace those superpowers. But at the same time, make sure they are aligned to the intended learning outcomes. Make sure you're not just using it for the sake of using it so that you can say it was a VR thing that you did. That is ephemera, that burns off. It's not useful 2 weeks, 3 weeks later. It's not useful when you're standing in front of a board trying to get more money to refresh the equipment. So it's really important to make sure that you get those powers and make sure they are fit for the purpose for which you are engaging the students. And the last thing is to show that ambition that I spoke of. You need to be ambitious about what can be taught and how it can be taught to go well beyond the limits of what teaching has been to date. That's actually what should excite us about this. Not about saving money, which some of the apps might for lab deployments and the like, but really about expanding what we can teach and how we can teach. That should excite us, it should excite teachers, and I think that would lead to much greater deployment. I'll leave you with this and a thanks. This is a link to our white paper and report piece that I was speaking about. Please do take a look at that, and thank you very much for your time. I'll be happy to talk in the coffee break. Cheers.
So, good afternoon, everyone. Can you all hear me? Okay, good. So, I'm Joanne Halpern. I'm the director of the Hasso-Plattner Institute in New York. Our headquarters is actually in Potsdam in Germany, and I'm also an adjunct professor of international education at New York University. Very quickly, what is the Hasso-Plattner Institute? We're the digital engineering faculty of the University of Potsdam, and we're funded by the Hasso-Plattner Foundation. These are just some of our research areas. We are looking for postdocs and PhD students, so if anybody's interested with the funding, you have a lot of opportunities at HPI. So today I'm going to talk about the intersection of design thinking and virtual reality. Design thinking is a really human-centered and planet-centered process to foster innovation. And virtual reality, as you know, I don't need to tell you what this is, but basically creating immersive, interactive digital environments. But the integration is what's critical. And the integration combines real-world problem solving with creative solutions and drives the development of practical and engaging user experiences. And I don't know if everybody here understands or knows about design thinking, so I'm going to give you a brief introduction. It's a human-centered and team-based method to find innovative solutions to complex problems. But it's also a mindset. It's a way of thinking and a way of approaching your world. And it's at the intersection of desirability, feasibility, and viability. So a lot of times we think this is a great solution, but we don't go out to the people that we're designing for. And maybe what we think is needed is not needed by others. And also, do we have the technology? Do we have the resources to actually pull this through? And is this something that's going to be viable as a business? And there are three core elements of design thinking. One is multidisciplinary teams. And I'm going to bring you in here because I know you've been sitting a long time. So why do we need multidisciplinary teams to provide innovative solutions to problems? Just, can anybody, go out a little outside your comfort zone? Would anybody like to share why do we need multidisciplinary teams? How does that help in innovation? Anybody? Yeah. Exactly, right? Because we have different perspectives, and different perspectives lead to more innovative solutions. Also, we carry around with us assumptions, and if we're always with people that are just like us, these assumptions we often think are truths. You know, those Germans, annahmen is assumptions. I'm sure your English is excellent, so you don't need my translation. But if we are with people with different backgrounds, some of those things that we think are truths, we will realize that no, that's not actually, you know, when we think of design and we're only with designers, it's going to be different if we bring in an engineer, if we bring in a biologist, we bring in an artist. So this is why multidisciplinary teams are important. We also have variable space. It's a critical, and the VR, you all know about variable space, but variable space is really important in innovation. And I have another question for you. This is not a trick question, this is not a hard question, so I think that you can all answer it. What are you doing when your most innovative ideas come to you? Or when you have, but for me, it's when I'm jogging. So what about you guys? I mean, this is not a hard question. So anybody want to share? When do your best ideas come to you? What are you doing? Yeah. In the shower. Who else? Anybody else want to share? Cooking. Sorry? Okay, anywhere where you don't have a pen. Okay, so all these different things. And in HPI, I'm going to say HPI is the Hasso-Plattner Institute. At HPI, we actually design our own design thinking furniture. And it really funny, I was at the UN recently, and we were in the Secretary General's innovation space, and there we see HPI materials. And I said, Kirsten, he says, Joanne, because you introduced us, not him, but another person to HPI, and we have a person that does design thinking and space, because space is a really important part of this. And so they bought actually our materials. And as you notice, everything is light, easy to move, because in variable space, as nobody said, their best ideas come when they're at their desks. And we also don't want to be sitting in the same kind of space, so we move things around a lot in design thinking, and this is why you see everything's very easy to move and light. This is in our Potsdam. In New York, I'm in the SAP offices. By the way, I didn't mention, Hasso-Plattner was one of the founders of the software company SAP. So we have a very close relationship to SAP. A lot of the innovations that come out of HPI go into SAP. For those of you who are in IT, SAP HANA, which is the basis of a lot of what SAP does, came from HPI. By the way, if I'm speaking too quickly, let me know. In my family, if you don't speak quickly, you don't get to say anything. So sometimes, I end up doing that. The third important part of design thinking is it's an iterative process. That means it's not linear, right? And this can be very frustrating for many of us because we often want to finish and we just want to go from beginning to end. But in design thinking, you're often going back. As many of you mentioned and talked about prototyping, you prototype, test, and you might realize after you test that you even didn't really understand the problem. You might have to go back to the earlier stage. So it's an iterative process. And I'm going to teach you about design thinking. I know some of you might know, but Art told me when we talked that a lot of people don't know about design thinking. So I am going to, but bear with me. It's actually an interesting story, so I think it'll be fun for you. So in design thinking, there's usually a problem that you're starting with. And we're going to talk about a real situation. There's a man named Doug Dietz. Doug Dietz worked at GE Healthcare. He retired recently. I did actually design thinking with him virtually during COVID with some other people. And Doug Dietz worked, and he created medical devices from MRIs, for mammograms, different medical devices. And one of the things he created was an MRI for children. This is not for children. This is a regular MRI, but he also created one for children. And he wanted to see it in action. And this is before he knew about design thinking. He went to the hospital to see his MRI in action. And he gets in the hospital, talks to the nurse, and he's telling the nurse about how he's so proud of his MRI and his team's MRI that he submitted it to a design competition. And while he's talking to the nurse, the nurse is saying, Doug, you're going to have to walk out because a child is coming in for her MRI, a young child with her parents, and you can't be in here when we have the MRI. So Doug comes in, and Doug goes out, and he sees the child and her parents coming down the hall in the hospital. The child is petrified. She's so scared, and the parents are trying to calm her. And then they walk into Doug's MRI room, where Doug's MRI is, and remember, he was telling the nurse about his design competition and how proud he was. They walk in, I mean, this wasn't as clean as this. There was like a little warning sign and all. And they walk in, and the child sees the MRI and bursts into tears. So she's crying, and the parents are trying to comfort her. And then they close the door because they have her MRI. And Doug, was shocked, was very upset because he was so proud of his MRI, and he realized, oh, this isn't what I thought. Then they leave the room, the parents, the child. Doug comes back in and says to the nurse, does this happen a lot, that kids come in and they see the MRI and they cry? And Doug says, not Doug, the nurse says 80 for the Germans, 80% of children who have their MRI have to be sedated. Because as we heard in an earlier, I think it was Oliver at the beginning, was talking about how, an MRI, you have to sit still. And so 80% sedation rate is not good. One, lots of insurance forms. Also, you can't get as many children through in a day, so it's not as efficient. And in general, it's not a healthy thing, right? Getting sedated is not healthy. There are risks associated with it. So all of these are problems that you want to avoid. So Doug started off with a problem. Like I told you, in design thinking, you start off with a problem. His problem is redesign the MRI for children. But I would use design thinking with the UN. We were looking at the Sustainable Development Goals, the SDGs. Apple uses this, Microsoft uses this. Many companies use this. The Auswärtiges Amt, or the Federal Foreign Office here in Germany, uses this. We actually, the Hasso-Plattner Institute works with them. So it's used in schools all over the place. So Doug's problem is this. So just picture you have a problem you start with. And as we said, we have multidisciplinary teams. So if you have multidisciplinary teams, you're going to have different understandings of the problem. So what that means is that you want to ask yourself on your team, you want to make sure that the team has some kind of common understanding of the problem. So what we often do at HPI is, as you saw here, you have understand, observe. Now, in a lot of people who've done design thinking, many of you maybe, you saw empathy, right? Where we have understand, observe, you often see empathy. But the Hasso-Plattner Institute, we actually separated that because we found that with multidisciplinary teams, that going in and interviewing people with the teams that have a different understanding of the problem was problematic. So we separated, and Stanford actually uses, many people at Stanford have taken up our model. And by the way, design thinking really started at Stanford, but guess who funded it? Hasso-Plattner in Stanford. And a few years later, he said, we need this in Europe, and we have the hub of design thinking in Europe at HPI in Potsdam. We have courses, coaches, trainings, etc. So you're all welcome to do that. Okay, so the first thing we do in the understand phase is, I like to call it a semantic analysis, but you don't have to worry about the wording. But we ask which words might be understood differently by different members of the team. And so I'm going to ask you that. This is the problem, right? And I'm just getting rid of this. Okay, so if you're part of a team here, a multidisciplinary team, and I ask you which words, I don't want a description of the words, I just want to say which words would you underline or highlight. That might be, if you have a team of an engineer, you might have a team of a photographer, you might have an artist, you might have a biologist. Which words might be understood differently? Just call out. Children. Yeah, children. My niece still calls me a child. So what's a child, right? What's a children? What else? All of them. Okay. You could say all of them, especially with, okay, but most people say redesign, MRI, children. When we have philosophers in the audience, we have the of, the for, and the, and those are important actually. Those of you who have to start companies, we created in the US, we created the German Center for Research and Innovation, or in German it was the Deutsches Wissenschafts- und Innovationshaus, and we created this, and we really had to pay attention. Are we a center for research and innovation or of research? So those little words can be important. So this is what most people would say. Okay, redesign, MRI, and children. So now you've come to some kind of common understanding among your team about what this problem is. It's not going to all be the same. It's not perfectly the same. You might want to start preparing some questions because the next stage is the observe stage. And this is also, when you think those, since you're all VR people, this is really a place where VR can help this because you're really trying to empathize with the user. So the observe phase, we tend to go out and interview people, but there are other ways of observing. And we want to really walk in the people's shoes that we're trying to design for, to understand them at a very deep level, so very deep empathy. So in the observe stage, you're going to go out and you're going to interview people. If you were Doug or a member of his team, whom would you interview? Remember, it's human-centered, so that you're designing for, whom would you interview? You can just call out. Children, who else? Parents, who else? Nurses. Anybody else? Engineers. And you know who else Doug interviewed and his team? They interviewed child psychologists, they interviewed kindergarten teachers, and they interviewed children's museum directors. And when you're going in and interviewing, I'm going to tell you about little things that you have to pay attention to, but when they were interviewing, when they went to the children's museum directors, remember the children were scared of the MRI. The children's museum director, you're going out and you're taking notes, and the children's museum director said, children really need a story. And then, they won't be as scared. And so when you're taking notes, you want to really capture quotes. So that's one of the things, capture quotes. I'm not going to ask you another question, but I usually ask, but I want to get this done. I know you want to have lunch. But instead of just taking notes, capturing quotes is important because when we take notes, we often interpret. Right? We start to interpret what's important to us. Whereas it's more authentic when you're taking quotes. Also, you're not interviewing all, let's say the teams are usually in design thinking 5 to 7, you can do it with 4, you can do it with 8. But if you're not going to take 5 to 7 people and interview one person, so you're going to be separating from others. So that's why we want to be as authentic as possible. So when we share with the team, they get the real experience. So one, we want to capture quotes. We also, when we're interviewing, we want to go deep. Well, we want to elicit stories from children. So you might want, if you're interviewing, or whomever you're interviewing, and this sounds familiar to qualitative researchers in the room, right? You don't want to just get yes/no answers. You want to get stories. And so you might ask a child, tell me about the last time you had an MRI. A 5-year-old might not give you a story. They might say it was scary, right? They're not going to necessarily answer with the whole story. But you have to keep going and go deeper, and you can do that by asking why questions and other ways to go deeper. You also want to pay attention to gestures and facial expressions, gestures, contradictions, because sometimes people's body language will show one thing and they're saying another. Especially with adults, we often don't want to show vulnerability. We might, show one thing and not the other. Children as well. The other thing is speaking versus listening. If you're interviewing a child, the child is still the expert. They should be doing more of the talking than you. And also, if there are pauses in the conversation, that's okay, because it might be uncomfortable, but let there be a pause, because during those pauses, the people that you're interviewing might dig deeper. They might feel uncomfortable about the pause, but let them dig deeper. And then finally, extreme users. Why would you want to interview maybe an extreme user for, it could be an MRI, or I'll give you a hint, like my mom is 86, she can't open like a bottle, like whatever those, like a San Pellegrino bottle or whatever bottle, she can't open that. Why would it be helpful to interview an extreme user or extreme users? Anybody want to share or think what you think? What? Oh, maybe, or the other way around even, right? Maybe even the other way around. So, like for my mother, she can articulate, people that are extreme users, they often can articulate things that we don't even notice. Like opening a bottle, you know what, if we designed a bottle that's easier to open, we might benefit as well, even though but we don't even notice it in the day-to-day. By the way, sometimes we also, thinking about not noticing, you guys know what workarounds are? Workarounds, like, so for me, like my printer I work in the SAP offices, because of the security there, I can't use the SAP printers. I have my own printer. I have to, put my USB stick in my computer, save it to the USB stick, put it in the printer, print. That's a workaround. It's not the direct way, right? In your environments, things that are workarounds, so first of all, they often become just normal and you don't realize they're workarounds. But second, this is a place where innovation can occur. But you need to pay attention to it. You need to be curious about your environment. And that's another thing that happened to me when I started doing design thinking. I started noticing things that I just accepted every day that I realized, oh, this is really badly designed. Like plastic wrap or ceramic, like Germans, you'd say Frischhaltefolie, right? American, we say plastic wrap, Glad wrap. And the thing it's on like a cardboard roll, and then it sticks to the roll and you can't take it apart. And then you have to cut it off, and sometimes you cut yourself, and then you have to put it on top of fruit and it sticks to itself. Like all these things are really, I accepted that for 50 years of my life. And then I started doing design thinking, and I was like, this is designed really badly. So that's happened to me by learning design thinking. So moving forward. Okay, so Doug and his team go out and interview. And then they come back. And when you go out and interview, you're taking notes and you're doing all these things I just told you about. And then you learn things that you end up redefining the problem. So the problem you thought you had when you first went out and interviewed, and you started with this problem, but then you learn that from your interviews that usually the problem that you thought you had isn't the real problem. We work with Mercedes, with Bosch, with universities, with lots of companies, and they come to us and they say, this is our problem, help us solve it with design thinking. And 90% of the time, the problem they think they have isn't the actual problem. And what design thinking does is it brings to the surface the actual problem. So Doug and his team come back, they've interviewed, and they found, so they're redefining the problem. Sometimes they create a persona. Some of you mentioned persona this morning and yesterday. They often create a persona. So they might say, okay, we interviewed Amy, and Amy is 5 years old, divorced parents, et cetera, et cetera. And so they might do that rather than just saying children, because it motivates the team, to actually be designing for a real person rather than children in general. So they define a point of view. So Doug and his team, remember when the Children's Museum director said, children need a story, well, they translated that into how might we redesign the MRI experience for children. So they're now designing to create an experience rather than just redesigning an MRI. So this is changing their approach to the design. And this is just like the meta level, so you have an idea. Sometimes people like more of a little overview. What we've been talking about here, and this is important in VR as well, so I think this is, and we're going to get to VR in a little bit, but we often go to the solution space too early, right? We tend, human nature is, we want to solve the problem quickly, but if you don't spend enough time in this space understanding the real problem, like in the interview stage, sometimes people will say, that, you're interviewing someone, they say, oh, create a spaceship, do this. This is not the time to get the solutions. You want to understand the problem from the user's perspective. You want to walk in their shoes, empathize with them. You don't want them to be giving you solutions at this point. So understand the problem, and this create choices, make choices, diverge, converge. Sometimes you'll see this as a double diamond, but the idea is when we started, we had a problem, so we were all on the same, we were on the same page. Then we go at an interview and we get lots of data. That's what the diverge is. You're creating choices now to redefine the problem. Then you go back together, come together to redefine the point of view, and then you go back out again. So now we go into ideation where now you have how might we redesign the MRI experience for children. Now this is the post-it part where you put lots and lots, you put all your ideas, like one idea per post-it. We usually do this individually first and then share it with the team so that those introverts and the quiet people are, thinking on their own, and the loud people too, because it's distracting for some of us when everybody's shouting out it. So they come up with lots of ideas, then they share their ideas with the team, then they put them in order so that they try to kind of cluster the similar ideas. I always tell my people to, put your ideas next to the similar ones, but that also gets them to listen to the people before them. And then they vote on 2 or 3 to prototype, okay, so to create models. So Doug's early prototypes were out of cardboard. He even made like a cardboard box with a hole, and so early prototypes are out of cardboard. Why? Because you want to be able to make quick changes. You want to try things out quickly. You don't want to start using expensive materials this early, because you're going to learn when you're going to go out with your prototype and test it. And you're going to be doing a lot of going back and forth. You might even have to go, as I said earlier, to another phase to really understand. You might have to go observe more. So early prototypes, because then when they get closer to the final, then you can make them more expensive, and closer to the final product. Okay, we talked about ideation. When you get to ideation, you want to have lots and lots of ideas, okay? Because and many of us often, we want to, we get wedded to, we like our first ideas and we don't want to get rid of them, but we really try in design thinking to have lots of ideas. By the way, when you're going through ideation, you want to go for quantity, you want to build on the ideas of others when you're coming up with ideas. So everybody in this room who speaks German has heard in a meeting, ja, aber, right? Every American or British or everyone who's not a German speaker that's here, and you've heard yes, but, right? Well, we want yes, and. Even if you think the idea is crazy, see what you can do to build on it. Rather than judging, really add to it. And you can also in design thinking use images. You don't have to write words all the time. And we also think about fail early, fail often, because failing is really learning. But it's not about failing, it's about learning from your failures. Okay, and I talked about, so I skipped a little ahead, but yeah, so then Doug and his team created prototypes, they tested them, and what happened? Okay, this is the best part, and then I'm going to quickly talk about VR, because I know you're hungry. So what happened? Now, a week before children go get their MRI, they get a postcard in the mail. And the postcard says, you're going on a treasure hunt. So now, instead of these children totally scared and really upset, before their thing, they actually now are excited, and they see the postcard, and they're counting 7 days, 6 days, 5 days, and then they get to the hospital. And when they get to the hospital, so the postcard says you're going on a treasure hunt. And when they get to the hospital, many of you have probably been in hospitals where you go in and you have these long hallways that are gray or brown or white walls. Well, now when they get to the hospital, the walls are with decals and painted with pirate ships, with treasure maps, with gold, with fish. And then they get into the waiting room, and in the waiting room, they have coloring books with the whole pirate theme, and the water and the gold and everything. And then they get into the MRI room, and look what Doug and his team did. They this is an MRI, and they really looked at the child's perspective. They really tried to they noticed, they followed in the children's footsteps when they were allowed. And this is where VR can really help to empathize better with the children. So it looks a little, but they saw when they watched the children, they were so little often in comparison to the machine. So now it makes it look closer to the ground. This hole that's really scary, because it's usually very small, makes it larger. They keep the story going. They get a pirate tap when they get in. They talk about walking the plank. So they really keep the story. And then another thing they did was Doug and his team created a tiki hut. Tiki hut is like if you're in the Caribbean, if you're in Mallorca. I know where Maxime is in Mallorca. Tiki huts are these, the bars that they have the straw roofs and everything. And they created a tiki hut with the smell of pina colada. Okay, this is a child's MRI. Anybody want to guess why they created the smell of pina colada in a child's MRI? Anybody have a guess? Yeah, it's more immersive. Yeah, well, talking about hearing, those of you who had an MRI, you've heard about the clanking, right? It's really loud. So they have a story about that too. The people will tell the children, yeah, when you hear the clanking, the pirates are going to try to get in. But if you sit still, then they're not going to get in. I think Oliver mentioned earlier today about the MRI. So they have a story about that. So immersive. What else? What does pina colada smell in a children's MRI? Okay, it's not meant for the children? Mm-hmm. And anything else? No, that's good. But anything else? Okay, you got it. Parents, okay? So when parents think of pina colada, what do they think of? Vacation. And when parents are thinking of vacation, how are they feeling? How are they acting? Relaxed. And children take cues from their parents. So this is why this was. So Doug was thinking of the parents. He was also thinking of all the different senses. And so this is what happened. And there's this only one version. There's a spaceship version. And then they use the story, oh, I have to go to mission control now. You know, they keep with the whole story. So there are lots of, you just look under Doug Dietz, MRI, you can find different versions. But this is the key. From an 80% sedation rate, there's Pedro. Pedro graduated from HPI, by the way. But he's a VR person. He did his PhD at HPI. So it went from 80% sedation rate to a less than 2% sedation rate. So you could get more kids through every day. It's healthier for children. The costs were reduced, fewer insurance forms. But my favorite part is one day Doug Dietz went back to see his MRI in action, and a child just finished, and she pulls on her mom's coat as she's leaving. She says, Mom, can we come back tomorrow? And so Doug had tears in his eyes because he thought, oh my God, this is such a success. But not only that, he had tears in his eyes. He was interviewed about this, and he said, I was really happy and I had tears in my eyes for that reason, but I was also sad because I thought of all these parents and kids who had such a terrible experience, and he had learned from one of the nurses that a lot of parents couldn't even find the parking lot after the MRI experience because it was so stressful. So those are the results. If people who are interested in design thinking, these are some books. There are lots of books out there. Change by Design is very old, but that's like the one everybody talks about as the foundation, one of the foundational books. Design Thinking in Education, there's also a German version, Design Thinking in der Bildung. That's an HPI book, so I'm just, pushing our own horn. That just came out 2022, 2023. Under 2022, 21, the English and German versions. And this is a fun book about design thinking, creative confidence. And Jean Liedtke, I know she's at the Darden School, Business School and University of Virginia. Everything, she has YouTube videos, she's got books, she's just fantastic. I'm part of her fan club, she's just fantastic. Okay, so now to get to, what you're here, I don't need to tell you about VR, okay? I'm not a VR expert. But, empathy, there's a lot more than this. I just picked 3. So empathy is one. Deep understanding of user needs for VR experiences is critical. And you mentioned that, many of you, but design thinking can go even deeper. And it's an iterative process. So you're testing prototypes to optimize VR interfaces. And I think, Abraham, you mentioned, nausea and things like that. So it's also important you really test this out on users and different kinds of users to see. And then you optimize it and you iterate. And then creativity, to really push, not just focusing on the technical, not that you are, but just to go beyond technical solutions into meaningful experiences. And these are for you guys nothing new, except for the last one. But the last one, because at SAP in New York, I was talking to people that were really looking at, this is the third one, they were designing VR simulations to train communities on how to respond effectively during natural disasters. And I thought that one it was interesting that, that SAP was doing that with others. And I connected them to HPI too. Okay, and then this, I don't know if any of you know this, but this is a concrete example of using VR to create simulations for medical training. So VR is a company. They empathize with medical students and patients, and they're engaged with they're speaking with, remember we talked about observation interviewing, they're speaking with students, with residents, with surgeons to really understand their training needs and challenges. But also surgery, advances and evolves, so they're constantly going back and talking to them. Not just, okay, we talked to them, done, but they're always going back and iterating, and really taking feedback into account. And this is also so that the simulations are educational, but also reflective of real-world conditions. And as I mentioned, they're always testing and refining and working closely with healthcare professionals. And they're using the design thinking methodology that I just talked about. And this is an image of their environment. So I don't want to keep you, I know this is between you and lunch, but I do want to do I did a plug for HPI at the beginning, but this is really kind of fun too. I don't know fun, but it might scare you. But if you want to find out if anybody's, so HPI, a lot of our technologies, we have really top, engineers, digital engineers at HPI, but we also have design thinking, and that combination has led to a lot of startups. So this one, I don't want to scare you, but it was in Spiegel magazine. If you want to find out if somebody's gotten into your email, go to HPI ID leak checker, put in your email, and it will tell you when somebody got into your email. It'll tell you if it got in through an app or whatever. It'll tell you what information. Did they get your birth date, your credit card number, et cetera. And if you got somebody got in, change your password, please. And then this one, SchulCloud, we created this before COVID. And this is really an example of designing with, not just designing for, but designing with others. And we work with the BMBF, or the Federal Ministry of Education and Research in Germany. We worked with schools, with teachers, with students to design online schooling. It was used by over 1 million people during COVID. I'm not going to go through all the others, but we have a MOOC platform. So if you want to take free online courses from coding to ChatGPT, some great courses on there. Even some of the students' courses get even more people watching than the professors' courses, which I love that. And then this is just an example. I think this is a funny thing. Gesundheitscloud was created by we have digital health, also in New York and in Potsdam. And our digital health, one of the group's people, they created something called Gesundheitscloud. And then they came to the US, and people thought it meant sneeze cloud, because a lot of Americans did not understand that Gesundheit means health. So they realized that they had to change their name. But this is an example of why you have to go out to the user, and really find out things like that. So it's now called Data for Life, I think, unless they've changed the name again. But they thought, well, it's Health Cloud, but it was really, people didn't know what Health Cloud is. And just finally, this was in 2013. HPI in 2013, I don't know exactly how many students we had, but it wasn't that many. I mean, it was maybe 200-300. And then in 2014, a little more, but I don't know, but by 2015 we had about 350, 400 students. Look at this, these are startups and spin-offs coming out of HPI. And this was in 2018. So these are the most recent. I'm asking our entrepreneurship team to create more. And these are some of the companies that they're working with. So as you can see, design thinking really can create innovative solutions to different kinds of problems. And finally, that's me. If you want to connect with me on LinkedIn, or if you want to connect with me by email, that's how to reach me. Thank you for your attention. I know we're a little over in terms of time, but thank you all for your attention.
Thanks, John. That was amazing. Also makes you think how many scientific experiments are just badly designed. Anyway, guys, so this is our lunch break. You're welcome to take a look at the demos, like VR demos that you haven't seen yesterday. But we start at 2 p.m. sharp, okay, with the talk from Anna Siaunika. Okay, we cannot run behind the schedule today because of the hackathon that needs to begin at the time it was scheduled for. Thanks so much. The food truck is outside. It's ready to serve you burgers. There's some snacks back there, so, well, first to come, first to serve. They may run out in 5 minutes. Thank you.
Okay. Hello, everyone. We start with the next session in about 2-3 minutes. So if you want to finish your conversations and find a seat, we'll start at 2 p.m. sharp. Okay, then we start going and, oh, yes. So our next speaker is Anna Ciaunica from Philosophy of Science Department at the University in Lisbon. And Anna is also affiliated with the, I think, the Social Neuroscience group in UCL. And I'm pretty much looking forward to your talk, also connecting to some of the talks I think we heard early this morning about agency experiences and what that means.
Yeah, so I think I'm going to wait a bit to everyone to go back to their seats. Yeah. Yeah, so thank you to the organizer for having me. I want to apologize also, I'm a bit dizzy, but like Keizuki, but unlike Keizuki, I'm not coming from Japan. I'm coming just from Munich, but I did a mistake to take a German train. I should have taken a horse or a camel or something. But it took me roughly the same time to come from Munich to Bochum than he came from Japan. Yeah, so I have exactly the same state of mind as, bear with me. Okay, so I'm going to talk about experiences as my primary training is in philosophy, so I was trained as an armchair philosopher, and I was obsessed with the problem of like subjective experiences. So for instance, like what it is likeness to see a red tomato, right? So, so there is this idea that, you know, a philosopher invented a thought experiment. So imagine you have a brilliant scientist called Mary, and she's born in a black and white environment, and she lives in a black and white environment where she's 20, for instance, like, and she's super smart, and she's a brilliant neuroscientist, and basically she learns everything one can learn about the physical, the neural correlates of the visual perception of colors, yeah, so the red. So, and then the story goes, imagine that when she's 20 or something, you know, she gets out from the room and she finally sees tomato in real world, and then the question is, does she learn something new? Or she will be something like, oh, this is boring because I already know what it is like to see red, because I already know what are the neural correlates, yeah? So that's the problem of like perception of qualia in philosophy, but I did my PhD in Burgundy, I'm French, so I was like, who cares about seeing a red tomato? The most important thing for a human being is to eat it, yeah? So it's like, how about drinking red wine? So vision is very much like the sense that people tend to privilege when it comes to conscious perception and visual experiences in general, but actually we can't really survive just by staring at things, yeah? So we need to just also put things inside our body, like wine, water, food, like right now, yeah? And actually, it's super important to have those type of experiences in place very early on, yeah? So again, the problem arises how you get from this, brain, material matter, you get like the qualitative aspect of our experiences, yeah? And I don't know if you have PhD students in the room, but when I was a PhD student, I was advised to have like a pitch elevator kind of like phrase to explain people why I spent 5 years of my life doing what I'm doing. And I'm a painter, so I said, can I draw something, instead of like saying. So I'm going to share with you the drawing that I did when I was a PhD student about the problem that has obsessed me for 4 years. Okay, so here is, you see that the dots have a utility, right? So there is this idea that you have the human, and then there's a split between the mind and the body, and somehow the body is impure because it's kind of like develops, decays, and eventually die. We suffer through the body, but there is something which is like pure and stays there like a pure form, and that's the mind, the psyche, or something else in the soul, yeah? And the puzzle philosophy in between, and then you ask yourself how the two things are kind of like connected. And that's connected with something back in philosophy is called the soma-sema theory, which is basically, soma means body, like somatic, and sema means tomb, and there's this idea that body is a tomb for the soul, yeah? So, so this means that, the body is something bad that basically traps the soul inside, and we need to get rid of the thing, yeah? And why is this important? You will see why I'm talking about this. Things that we take for granted is because I think we see this like tacit understanding in discussion that we have right now about artificial agents. So, for instance, like this distinction between the mind and body is so deeply rooted in our society that when you have a liver problem, I go to a building like a physical hospital, but when I have a mental health problem, there is literally another institution, right? Different building. So these two are treated separately as if they are two separate entities. And also we do the same with artificial version of ourselves. If we want to create, for instance, like we create artificial minds on one hand and then artificial body on the other hand, and try to glue them together. I'm going to try to convince you that actually that's one way to approach the thing, but not the correct way, yeah. So now I'm an armchair that jumped from I'm a philosopher that jumped from the theoretical armchair into the empirical sea, and in my lab, I conduct psychophysiological studies, behavioral, qualitative, phenomenological, and neurals, both in humans and artificial agents. I'm going to present a bit of the studies that we are doing. But before that, I want to start with a couple of, so that's the philosopher me. I wanted to shake a bit of some of the assumptions that we have and question them, yeah? So I'm interested in, as I said, in experiences because that's our starting point. This is how we get into the world, through the perceptual experiences and perceive ourselves in the world. One very important starting point that I work with is the fact that we don't pop out like Athena from Zeus' head, fully fledged. We develop into who we are, right? So this means that there is a process of getting there from square one. Now, when people talk about pregnancy, they typically associate pregnancy, the pregnant state, with a certain category of individuals that have the ability to carry babies in their bodies. But if you look at the pregnant state through the perspective of the developing human, all of us here bear shared our body, your body, with the body of another person. So human body grow inside another body. So this means that the co-embodied state is a fundamental state. It's something that we should take into consideration from all humans, not just some humans, yeah? Especially if you want to understand how we develop a self, yeah? And that's something I develop with this fantastic people. And this is why I decided to name my lab the Co-Embodied Self Lab, because if we take this idea that the brain and the mind doesn't occur in a vacuum, but occur in a body, which is in a wider environment, also the human body also develop within another body, And the pregnant person body is not an environment in objective way. It's not a basket where you drop an egg. It's a self-organizing system that needs to negotiate with another self-organizing system. So basically have a cooperation between the two. So we need to start with the body within a body case, hence the Common Body Self Lab or the Cell Lab, because I'm interested how we get from cells to self. As before I was a philosopher, I was trained as a chemist. Maybe this is why I'm still obsessed with cells and biochemistry. Yeah, so we talk about agents a lot, like artificial agents, natural agents, but it's not very clear what we mean by that. So some people say, well, you have agents like that do stuff, like take action to the world, yeah? A robot is an agent in that sense. Other people would say, well, it's the capacity to feel in control in your action, yeah? So you have a sense of agency over your control. And some philosophers basically distinguish between sense of body ownership and sense of agency. For instance, right now, if somebody takes my hand, move it from point A to point B, I still have the feeling that it's my hand is moving, but it's not me, the agent, the control of that movement, so we can disentangle agency from our body ownership. And also, very importantly, basically, we can also discuss about what type of systems count as an agent, right? So, for instance, you have unicellular organisms, or you have neurons, and then you have mammals and humans in this case, and then you ask yourself, it's like the things that come from the human brain, such as like artificial neural system or computers, or something we decide, also can count as agents. And obviously, we can create more and more sophisticated agents, and then we ask ourselves again, what type of agents we are talking about here. But this is not what I want to talk about today, so I want to draw attention that we have, so I endorse a biogenic approach to cognition developed by Pamela Lyon, and the biogenic approach is to be contrasted with the anthropogenic approach, where basically it assumes that human cognition as a paradigm and work down to more general concept, whereas I think we should start the other way around. Instead of focusing, obsessing too much about what makes our cognition special, we need to understand what exactly connects us with other living systems, because this is what we do for survivors. So instead of starting with the human mind as being something pure that doesn't disappear because nobody wants to die, everybody don't like the body because the body kind of like disappears, nobody wants to die. So instead of considering like the body just a system designed to fuel and transport the mind, we should think of the mind as a system which has evolved to subserve the needs of a biological body who it needs to survive, right? So that's ours, So hence, it's like the idea that in order to understand embodiment and how we can connect it with artificial systems, we need to understand the biological roots of self-organization and a self-organizing system in contrast with the physical system, yeah. And when you do so if you take out this idea that somehow we need to start with the head, the mind, and the neurons, and you go back to the roots, so the fact that we are all coming from cells, not just neurons. You can't really have neurons if you don't have cells first, right? And how those cells self-organize to give rise to biological self-organizing system we are all right now, that, thermoregulate and self-regulate, homeostatically regulate because we had food, we had water, we need to go to the toilets. So this means that we need to start with the cells rather than the neurons, especially from a development perspective. So why is this important? Because, and you'll see later, it's like people working in the embodied cognition paradigm, right, like Varela. So we wrote this paper with Mike Levin and Evgenia, where basically we try to challenge this idea that the mental is somehow connected just to the brain. Basically, we think that the brain-body distinction is a side effect of the mind-body distinction, the dualism. There is no principal reason why we shouldn't consider the brain as being part of the body. There is no some sort of like distinct entity different from the body, yeah? And if you take the cells as a starting point, it's even better. So you start with the living organisms, which are open system, thus vulnerable and need for self-preserving mechanism, yeah? And they have the self-sustaining property that distinguish them from inert physical system, and they are typically composed of cells, maintain a stable internal state by converting food into usable energy, grow, and reproduce. Now, I don't want to say that neurons are not cool. I think neurons are super cool, but if you take development as perspective and you ask yourself how neurons develop, we need to understand how neurons develop in relation to other type of cells, because in the end, neurons are just one type of cells. Yeah? We can't just have them from the start. So this means that cognition, so that's the received view, so that the cognition requires a nervous system without which no mental states can arise. Neural activity in brain circuits generates sensory perception, cognition, and ultimately behavior. So this means that at the lowest level, the mind are anchored in the homeostatic neural processing, and hence the deep proof of sophisticated mental and cognitive processing may be traced back to the humble origins of information processing and metabolic homeostatic mechanisms of the ancient cells. So I think Damasio is right in getting that step, but we want to go even further in our work. So if you take the self-organizing system, biological system in relation to other type of self-organizing system, physical system like the snowflakes, and you ask yourself what is the difference between the two, you realize that in sophisticated like self-organizing biological system, multicellular ones like the human body, which one of the systems tell your system which one is the self, which one is not the self? So that's the immune system. So the immune system needs to be in place and fully functional before you even have a neural system, because otherwise you can get inside the virus and you just like die. Yeah, and as I said, it's like people like Varela were biologists, and actually they wrote a lot on the immune system before they wrote like the famous book Embodied Mind. They even coined the term immunology, because I think that's super important. And this is something we developed more recently. And again, this time we look at like nested cells, so one biological self within another biological self, and one immune system nested within another immune system, because again, the pregnant state is a case where you need to communicate to have two type of like immune system that communicate successfully. Yeah. And again, I'm stressing this because it's not concerned just some individuals, concerns all of us. And we'll see later very quickly why we discuss both this, because we want to say that cognitive processing are not necessarily just happening in the brain, but are multi-scale implemented multi-level bodily system and intricate neural networks, cellular networks that compose the biological organism as a whole. And why is this important? So we're going to start a project called Hybrid Agency. Sorry about the picture, I lost something here. With Mike Levin, who is based at Tufts University in Boston, Allen Discovery Center, and Ruud Hortensius in the Netherlands, basically going to look at self-organizing system, half organic, half synthetic, so it's like truly hybrid system, yeah. And combine this with the type of tools that we have in computational modeling, but also basically taking the type of exchange energy that you have at the biological level at the starting point, and that's something that they coined the term biobots, yeah, biobots. So that's in the pipeline is going to happen next year. But I promise you that I'm going to give you some experimental work as well. And before we go there, I promised my cat that I'm always going to have a picture of her in my talks. So I want to ask you, what do you think is the main difference between a robot and a cat? A fundamental difference. A fundamental difference between a robot and a cat. Feeling, yeah. Come on, guys. I just came from a summer school, and it's like we had 20 years olds had way more reply that you experts. So shoot me. Sorry. Language capable. Chemical composition. Homeostasis, yeah. Okay, yeah. Reproduction, yeah. Very nice, but there is one very obvious. That too. We do robots, we don't do cats. Yeah? There's a human intervention there, right? So there is somebody in the chain that kind of like tend to overlook. We don't do cats. Actually, we don't do humans. We don't create humans. None of us here choose to be here. None of us ask us to be part of the way we are, so we are part of something bigger, which is created by nature through zillions years of evolution. So whether we like it or not, just like have to play by the rail of the games that it's already going, so to speak. Whereas like robots is something that we introduced, right? So we kind of like control. So based on that, we have a project called Social Self-Consciousness, Social Interaction, Human and Artificial Agents. So we have a highly, because we talk about interdisciplinarity, so we have a highly interdisciplinary team. And here, basically, the idea is to look at different type of artificial minds and different type of artificial bodies and interacting with the stuff, different type of artificial mind and different type of artificial body to see what is the effect on the human body. Why? Because we know that we tend to attribute human-like mental states to artificial others, so that's well documented. But what is the impact of interact with different type of artificial minds and body on the human body and human mind? That's something I'm interested in, yeah? So why am I interested in this? So suppose I'm holding a tennis ball and I'm measuring your physiological and neural signals right now. While you're watching me holding the tennis ball, I'm smashing the tennis ball, right? So I see what is happening in your physiological measures in the brain. And then I just like draw, 2 dots and a smiley, and you see me doing it, and you know it's a tennis ball. And if I smash again the tennis ball, your vital will skyrocket. Why? Because you interpret this as being like a phase. Even if you know that's just an object, your body will react as if it's something living. So that's something you can't really control. So I'm interested in what the body knows without us being aware that the body knows when we interact with different type of artificial agents in different scenarios, yeah? So to do that, in our participants, I'm happy that Kizuki mentioned depersonalization. So in our studies, all our participants are divided into 2 groups. One is connected to the body, the other one is disconnected to the body, yeah? And then has that depersonalization experiences. So this idea that you're, I think the best way to describe it is just take a first-person perspective. So this is Jane. She smoked cannabis twice. She was not a regular user, but this is what happened second time she smoked. She said, my perception felt as though I'd been dragged back inside my head, so it's a bit like here, yeah? And almost as though I was looking at the world from the back of my head and could see the back of my eye sockets. I perceived that there was a delay between something happening externally and my brain understanding that something. Essentially felt like a divorce or fraction between the world and me. So though although my body was still in the world, my mind was only an observer, yeah? So it's basically like, split, yeah? And I feel like a robot. I'm listening to somebody else talking. I'm looking at myself from the outside. It's not another voice of body. It is me, it is mine, but it just doesn't feel like it, yeah? It's a very spread condition. Actually, it's the 3rd most common psychological symptom in the general population after anxiety and low mood. It can occur severe stress, traumatic life event, drug use, or symptom of another mental disorder, and sometimes just traveling to new places. So it is described as this idea of like being stuck in the head and outside the body. So there's this connection basically between the 2. So in our study, because these people feel like automaton, like machines, this is how they describe themselves, right? We said, okay, so let's do the study where we look at joint agency, where we have different type of participants. And we decided to use a very simple task with not many confounds. This is the individual Simon task is super boring, so you have the congruence effect. So people are faster when the dot is appearing on the same color side as the button that you need to push, yeah? The interesting part is when you do the task with somebody else. So in that case, each person has just one button. So you shouldn't see the Simon, the contingency effect, because you don't care about that button. You should care just about your button. But people do exactly the same mistake. Why? Because they integrate the action representation of the other in their own action representation. So basically do exactly the same mistake as if for a sense of we rather than just me, I plus I, yeah? And that's a very nice setup. So people already did this with human pepper, and so human servomotor, and they show the sense of joint agency is high in the human diet versus like human pepper diet, but they show that actually the sense of joint agency is higher in the pepper human than in pepper servomotor, and they concluded that basically the embodiment of the artificial other counts for the sense of agency. So we're doing exactly the same, and at this time we've also taken physiological measures from the two studies and the two participants, type of participants, and we also running as we speak 2 studies because we look at the cross-cultural differences, also looking at the neural correlates of this in collaboration with these fantastic people in Poland and also in Switzerland and in the UK. And the next step is to do exactly the same task, but this time with the virtual other. Or maybe with you, if you're interested. So we designed the joint assignment task in VR. So basically we created the avatar of Pepper. So this means that if you enter in VR, you can see yourself as having Pepper body, and you can do the task either as being a human avatar or a Pepper avatar. You can do the task either with co-agent as being Pepper or human. And then, as I said, our participants are either connected or disconnected from their bodies. In a further step, we basically want to, because I'm still obsessed with this idea that it's really important to keep the homeostatic self-regulation in place. If you bite too much into the idea that everything is visual and not going to survive very much, you need to put these things inside your body, you need to drink, you need to eat. So this means that we need to find a way to basically combine the virtual with the real world in a more effective, efficient way. So in collaboration with some people in Paris, we're doing some work where, for instance, here I'm in a VR and I can start seeing the world through the physical robot Pepper, and I can move around and Pepper moves exactly with me, and we're planning about a couple of studies around this. And I'm going to end with some advertising. So we're going to do a conference exactly on this, on consciousness and body self and biological and artificial agents in Lisbon in October, so you're very much welcome to join. And also, I recently pre-printed this with one of my students I co-supervise in Australia, because I'm starting to get more and more. I still have my obsession from my PhD about the subjectivity of experiences. We did a formal model of experiences, subjective experiences, and we just pre-printed like literally on Monday. And Michael presented the mathematical models of consciousness conference in Bamberg later. And feel free to download it and let us know what you think. We already attracted quite some feedback. So we already got contacted by the Scientific American in the conversation. They want to see us on this because, we said, I'm done. I want to solve the mind-body problem, but not in a hippie way. I want to put some number on it. So we worked on mathematical model on that, with that, I would like to thank my lab for making the work happen, my funders for giving me the means to implement these ideas, to the organizer for inviting me, and of course you for your attention. Thank you.
Okay, thank you very much. And since we don't do any questions or comments after the talks, we just go on with the next 2 talks. So we have 2 talks now of 15 minutes. First one is by Brenda Ryan, who is a PhD student with Mel Slater in the Event Lab in Barcelona in neuroscience.
Hello, thanks to all of you for being here, and thanks for the organizer. So today I'm going to talk about self-collaboration for improving mental health. So whenever you think in collaboration in VR, normally the first thing that comes into mind are these shared environments where you can meet with people who are not physically there in order to do a task together or to discuss different ideas and improve basically whatever task you have to do with these heterogeneous teams. Some examples of these come from my colleagues and my PIs in Event Lab and in IDIBAPS from Barcelona. One of it is this study published last year in 2023 regarding an interview that has been conducted in a virtual sushi restaurant with two people who were in completely different parts of the globe. Another one in more clinical settings is this study published actually this year, where clinicians, researchers, and patients can all meet in the same environment to discuss treatment, diagnosis, and future directions within all of them. So this is not the whole story. There is something more when you talk about collaboration. And I put this phrase here, we all have all the talents. I'm not fully agree with it, but I think it will illustrate the idea that people have several talents that cannot come into light unless you have the correct trigger to kind of call them to reality. This has to do with embodiment, presence, and plausibility illusions in VR. I won't explain this again because several of the speakers already did yesterday and today perfectly. But I want to say that these three things work together. So there is a link between the three that brings to VR something that is really interesting and you cannot actually achieve without VR. And this is, you can achieve a detachment from habitual ways of thinking, and this detachment brings changes in perception and in behavior. Some interesting examples of this is this study from 2013, where depending on the avatar that you embody, you can become a better drummer. So you play better the drums if you embody, in this case, is a generic black avatar. And most interesting for me is this study that they have conducted with Einstein. So the people who embody this avatar have better cognitive performance. So as you can see, you have the behavioral aspect regarding the motor activity, but you can also achieve improvements in cognitive and in mental capabilities in people. This doesn't mean that the avatar brings or have something, give to the people anything new. It's not that the avatar itself is going to make a person better in math. The capability is already there, and somehow the appearance of the avatar helped to bring this into reality. Regarding mental health and psychotherapy, we base in two big pillars. One of the pillars is the one that I just mentioned before, that depending on the avatar, you kind of adopt these characteristics, but also in the Solomon paradox, that even if you don't know what it is, I'm sure that you have experienced it in your own life. Basically, what it means is that you are able to solve the problems of others much easier than if you have to solve your own problems. So when a friend comes to you and explains something that is going on with their life, it appears crystal clear the solution to the problem. But when it's your own, it's not that easy, right? So exploring this, it has been created a software that is based on a body swapping technique for self-counseling. In this case, home-based, because we send the application to the participants so they can do it at their own houses. And the aim is to achieve drug-free therapies. I have this a video with the software because it's easier to show you than to explain. Let me see how I can open it. No. Sorry, can you play the video? Okay, meanwhile, I will explain the procedures. So basically, what you have to do is a self-conversation where you embody the role of the patient and also the role of the counselor or the therapist. In this case, the counselor is Sigmund Freud. This came from a survey that the participants respond, and they choose him as counselor in 2015. That was the first time that the study was published. Well, so for doing this, they create a lookalike avatar. That is to say, an avatar that looks like the participant. And for doing the creation of the avatar, they have to scan the participant. So they do a body scan of the participant. After that, they define a problem that the participant has to discuss in virtual reality. And after the problem definition, they come into the application and they discuss this with themselves or with the counselor. Okay, let's see it. So here's the scanning.
Okay, so what is the problem you'd like to talk about today?
My problem is that I'd like to take better care of my health. That usually I'm sitting for 8 hours in my job at work, and I don't get any exercise, and I feel like I should maybe do something about that.
Okay.
And then they do the experience.
Please look down towards your body. Raise your right hand. Now look in the mirror to your left. When the light next to you turns green, explain the problem to the person in front of you.
So when I notice that I'm delaying going to the gym after I come back from work, I think that I should go because I want to take care of my health.
And they become the therapist.
Now listen to the person in front of you, and when the light next to you turns green, reply and try to help them find a solution.
So when I notice that I am delaying going to the gym after I come back from work. Okay, so why do you think that you delay? Why do you think that you're not going? What seems to be the problem?
Why do you think that you delay? Why do you think that you're not going? What seems to be the problem? What seems to be stopping you?
Okay, I think that's it. We can come back to the slides. So then this second part is about the control condition. Yep. And here it is. So basically, the asynchronous is the control condition, and it has to be with embodiment, but this is out of the scope of the presentation, so I can explain further later. But what is important are the results with the questionnaires between pre and post in the synchronous condition. So there are two different questionnaires that they measure. POMS, the lower the score, the better, and SAM is the opposite. The higher the scores, the better. Okay, so as I was saying, this original application was designed almost 10 years ago, so now we have a lot of improvements and updates. One of the updates is regarding the environment. So now you can see that it's much brighter and is wider, so it's much more comfortable, the environment. And also the other important update is regarding the creation of the avatars. So we don't need to do the scan anymore. We can create the avatar from the picture. And this brings a lot of usability. So for example, you don't need to be with the person, but the person can send you the picture and you can prepare the software for them. I tested specifically in depression and anxiety complex. So I will skip this part, but basically there are a lot of people who has mental health problems who need an assistance and who cannot access it because rather they have to wait for 3 months in the waiting list, or because the economical costs are super high, and also because not all people who has depression and anxiety respond to a typical treatments, and they need something else, something different. So for this study, we did 4 sessions in total, plus 2, the screening and the follow-up. So the participants had the headset, a Quest, an Oculus Quest, Meta Quest, in their houses for about a month. So they could do several sessions. The general methodology was first do a screening call with them to explain the procedures. If they pass the screening, I ask the picture, create the avatar, put it in the software, send the quest, and then the participants will do several experiences at home. When they finish, a shipping company picked up the quest, and everything starts again with different people. Okay, so regarding the results, we found this. We asked the participants to rate the pre-problem discomfort and the post, so pre and post each intervention. And here you can see how the post problems decreases over the 4 sessions. In the experimental condition as well as the control, but more in the experimental. For the problem definition, we use cognitive behavioral therapy that basically is about the thoughts that you have about a situation, how you feel, or the emotions you have, the behavior, and finally, what is an ideal outcome that you want to obtain from the sessions. So in general, we see that the symptoms of depression and also the symptoms of anxiety decreases over the sessions. Particularly, you can see this in the last session, the follow-up. So over time, we got significant results. In comparison with the control, there is not a significant differences, but because we also use a body swapping technique for the control, I will explain all the details if you want during the coffee break. So the discussion. There is a generalization of positive attributes to an outgroup. There is a perspective taking that is going on in the place, and this is why the discomfort related to the problem decrease. It promotes self-compassion versus over-identification. This over-identification happens particularly when the people is overthinking, and this kind of breaks this circle. And the physical distance from the self, virtually in this case, promotes emotional distance. Overall, subjects can use VR to find satisfactory answers to their problems, leading to improvements in the general well-being. Okay, I want to thank all my colleagues, ADS, Event Lab, and well, there is my email and the webpage of the lab if you want to contact any of us. Thank you.
Okay, seems like we have a little bit of a break, a couple of minutes to just switch out the microphone. Okay, looks good. Okay, now we're gonna hear from Christina Kinne, about a social VR agent, one of the first ones to be running on GPT-3, so one of the very early social VR agents. And yeah, I think we're ready to go.
Hurrah! Oh, thank you so much for being here, and thank you so much VR Summit for this amazing conference and for having me with my talk. Up. Whoops, where's the... Yeah, with my wonderful talk, Quantum Bar, creating a GPT-3-driven chatbot for social virtual reality. And a few notes about me. What got me here is, first of my real life name is Christina Kinne, and in VR I'm KS Princess, and I'm the project lead and creative director of the Quantum Bar. And in the first half of my creative life, I've been a filmmaker with a art school diploma from Munich Film School. But then in 2016, when I got my pre-ordered HTC Vive, my life did the most positive 180, and I entered social virtual reality on Philip Rosedale's platform High Fidelity, which was basically the successor, successor. It was basically Second Life in VR. Unfortunately, High Fidelity pivoted to spatial audio only in 2022, so I jumped on board as CMO and events manager with the open source successor platform Tivoli Cloud VR. And at the same time, in 2020, I also picked up studies again and did a Master of Arts in Digital Narratives at the International Film School Cologne, for which the Quantum Bar was the main project of my research creation thesis. And now we go on with the best of my master's thesis and my journey, or our journey to develop the Quantum Bar. So a quick overview of what's happening in the Quantum Bar. The user journey is, once the user has followed the onboarding instruction and enters the Quantum Bar, they are greeted by our chatbot with a nice uplifting conversation, and the user can talk to our chatbot for a maximum of 10 minutes on anything which is on their minds. We also use sentiment detection to steer the lights in the bar, so more serious topics will lead to a more blue light, and happy topics give us pink. And after 10 minutes, or if the user says bye-bye, the bartender bids his farewell and gifts the user with a summary card. And here we have a showcase video of the bartender introducing himself. Or doesn't run. Okay, then I invite you to test that yourself. So basically, my main goal was to show that our bartender is really friendly and nice and sympathetic, but also to show that we have a little lag in our conversation, which is due to the technical setup, which I'm gonna show on the next slide. First off, I need to tell you that we're using GPT-3, the generative pre-trained transformer number 3, the third generation of OpenAI's language prediction models. And this uses machine learning to analyze and compose text. And back then, GPT-3 was trained on 175 billion learning parameters. That was back then the super state of the art. Still now, GPT-4 is estimated to run on, I think, 2 trillion learning parameters, but we still on purpose use GPT 3.5 Turbo because it is not yet over-aligned, so you can get away with prompting it, and it doesn't mention in every sentence that it's just an AI language model. So this brings me also to the, for me, super advantage of the GPT and LMN technology, which is that it can be prompted in human language. And for artists and creators who aren't necessarily coders, this is like a quantum leap for their own creation process. And now I show you why we have a lag. This is due to our signal flow, which is actually sent 3 times across the ocean. So in Germany, usually, right now back here, sits our backend, which has been coded in Python by the wonderful Marius Creoles Anger. And sitting there in Germany, we pick up the audio signal of the user, who is, for example purposes, in New York City at that picture. Then we take the audio file and send it to San Francisco, where OpenAI does whisper to do the speech to text. Then OpenAI sends us back a text file. We do our tweaking and prompting. Then we send the text file back to OpenAI, this time to GPT-3. And then GPT-3 sends us its answer, which is then read out by Windows Voice of David and transmitted back to the user. And yeah, we have like a 2 seconds lag, and that's regarding that travel time and the fact that we also allow for like 1 second longer for the recording to run in order to allow for afterthoughts of the users. That lag is, I think, pretty bearable. So the technical side was only half of the job, but my main job for the master's thesis was, of course, the academic research. So I start off with the psychological and ethical considerations. So first off, because we had just gotten beta access, and I was like, wow, it would be cool to do a chatbot with that technology, but I didn't know if this was even feasible, if it could even establish like an emotional connection to the user. So I looked into what has been done before, and I was super happy to find Eliza, the first chatbot ever, which has been developed by Joseph Weizenbaum, an American-German computer scientist at the MIT in the 1960s. And the functionality of the chatbot was that it would reflect a user statement back with a question, which actually follows the Hegelian psychoanalysis. And everybody fell in love with that chatbot, and common people, but also academics, anthropomorphized it, and even like psychology researchers proposed that as like the future of psychoanalysis. But Joseph Weizenbaum, who actually just wanted some cool use case to showcase the capability of his great computer, was aghast to see that and stopped the development. But I was super happy because I thought like, okay, if you did that in the 60s, I can do that with GPT-3 in the 2020s too. And the anthropomorphism is also quite a bit of a challenging thing, and looking into that from an ethical standpoint, I found the principle of honest anthropomorphism, which was proposed by Margot Kaminsky, and she found that robots, which at times were used to look out for senior people, could make humans feel so trustful that they feel that then a relationship with that robot exists. And that's why they might disclose more super private things without realizing that they're actually talking to some corporation in the background. And therefore, Margot Kaminsky proposes that robot designers should not use anthropomorphism to deliberately mislead users as to privacy practices. If anything, roboticists should explore using anthropomorphic features to provide better notice to users of what a robot is actually doing. And that's why we chose a like humanoid looking but a robot avatar as the personification of our chatbot. But that was not the only reason to go for a robot. The other reason was the uncanny valley effect, which was discovered by Japanese roboticist Masahiro Mori in the 1970s, and which accounts to robots and avatars as well. That means that our affinity to a virtual character increases the more it looks like a human, but shortly before it is like 100% human, which with the current render capabilities we cannot reach, so you'll always have maybe glitches in the animation or low poly optimization edges, and since 100% cannot be reached, it evokes like a feeling of eeriness and disgust in us. This is due to evolutionary reasons, since like if somebody's, for example, staring at you without blinking, that might be a threat, like my cat jumps at me after he does that, or if somebody has glossy eyes, that might be like a signal of a transmittable disease. So our race survived because we were like getting away from too human but not human enough looking entities. And my last chapter now is about the immersive design and the world building, and for that I was so lucky that I could ask two of my favorite researchers personally the question, hey, I'm designing a GPT-3 driven chatbot for social VR. What do you think I should focus on most? And the conference's also favorite, Mel Slater, gave me the first answer, which was like, take care of plausibility, which is the illusion that the events that are perceived to be happening in VR are really happening. And that was the reason for us to take great care to program plausible animations which would run forward and backwards, like I enacted them myself. And in the talking times, we have me going with my hands, running forward and backward. And in the idle times, we have like the listening state of me enacting that. And that was done by Guillermo Valle Perez, who is also a great AI researcher and a specialist on the platform Resonite, which we use. And we also, that was also a recommendation from Mel Slater, took care of the eye contact. So Guillermo wrote a script which made the robot avatar always look at the nearest user, so you feel really attended to. And one of my favorite researchers is Janet Murray, who immediately said, take care of the onboarding and the debriefing. As an entrance and an exit mark the beginning and the end of a story. And the entrance was basically a no-brainer. So I needed like one place where to put our controller explanations, because the buttons are on all kinds of controllers at different places. I definitely wanted and needed a place to put my credits. That's like, in movies it's easy. You have like the rolling credits in the end, but I think it's really important to credit all contributors to a project, so that jumped there, and I wanted to have, for the users to have like a long shot view of the beautiful quantum computer, and then I had like this literal Joseph Campbell hero's journey inspired crossing of the first threshold and forwarding over the bridge to the core of the story. And I had like more challenges coming up with a good exit, with a good end, because I didn't want to do it like in a bad psychotherapy session, like our time's up, go. And so I thought a bit, but then I took again inspiration from Joseph Campbell's hero's journey, who issues a summary, or who calls for issuing a reward after you've completed that self-development journey. And therefore, we also used GPT's summary functionality. And so we are issuing a summary card, which looks like that. And if you want to have your own summary of the conversation, I would be overjoyed if I could invite you either to our booth to test it, or if you would come to our monthly mingles, which are usually on the last Friday of every month at 10 p.m. Central European time, or as an exception, because yesterday was the last Friday and we were here, the next one is going to be on October 4th at 10 p.m. Central European time. And yeah, thank you so much for your attention, and I would love to welcome you to the Quantum Bar.
Okay, so as the final highlight of this session now, I'm very happy and honored to introduce Pedro Lopez. Pedro is now a associate professor at the University of Chicago, where he leads a group of very, very talented students at the Human Integration Lab. And yeah, we have heard before from Joanne's keynote that Pedro completed his PhD in Potsdam at the Hasso-Plattner Institute, supervised or advised by Patrick Baudisch. And yeah, until now, I think you've published around 50 papers at Chi and WIS, which is insane. And yeah, I can only for myself say, because I've had the fortunate experience to work with you before, that I always enjoy your talks, and I'm really looking forward to this one.
Thank you. It's really a pleasure that he's introducing me, because we've worked together, and if I knew that he was going to be the session chair, I would have chosen specifically the work that we did together, just to embarrass him and to put it right here. But if you have a chance to talk to Lucas later, please do. He's a genius when it comes to neuroscience and EEG, and a lot of the stuff I learned on that territory was with him and his advisor, Klaus. We can put the slides back up if you don't mind. I'm going to talk about how VR's ultimate display, which has been a really long quest from the 60s, is actually, in my opinion, a continued evolution of the paradigms of computing, which are now so small computers that are no longer just in our pockets, but are coming into our bodies. So that's what we're going to talk about today. All right, so before this gets too abstract, I want to actually show you an example. This is work done at HPI. What we see here is a user in VR, and pardon, they're using like a really old school headset, but it has all the modern functionalities. There's hand tracking involved, and they can walk in the scene, they can walk in the building, and they can see things such as a virtual wall. Now, we all kind of know what happens when you face a virtual wall. You can go and try out VR demos around us here at the beautiful festival, and you know that usually VR is just a bunch of ghost-like sensations. I can walk just right through a virtual wall and nothing really happens. In fact, VR right now hinges on the fact that you believe the visual realism of things so that your behavior is more or less common sense, not crossing through the wall. But if you don't, or if you just test it out, you'll see that it's, ghost-like thing. So VR right now is only really hinging the visuals. And as we heard today, we know it's kind of really, really hard to fully immerse one's just eyes. So we need to involve the whole body. What I want to show you is that this VR, though very normal seeming, right? normal VR headset, nothing special, nothing big on the user's body, will lead to different behaviors. So let's watch what actually happens when this user tries to go through that virtual wall. You can see he's trying to touch the wall, but his arm recoils immediately. And in fact, he kind of like walks around and he realizes, I can't cross that place. I'm gonna go, this is like a button that he will press. And I'll show the rest of the video later. He'll press and unlock the next phase and open that door. What's interesting here, and this is what the talk is all about, is how does this work? I mean, there's nothing really special on his body, on his VR headset. How can it generate like the sensation and the force of a wall? And why is it so small? Like, why can't we see the trick immediately? And the answer is going to be that it's about integrating devices with the human body. Now, if we step back into the early days of VR, this is 1960s, there was this very beautiful paper, sort of a vision-like paper that Ivan Sutherland put out, and he also put out a series of displays that came to be sort of the first VR displays, or some of the first pioneering VR displays. And in this sort of vision, he lays out a very compelling argument of all the benefits we could reap from VR. We could get things that are so immersive, they're useful for training. I could learn how to do something in VR, like the type of things Joan was talking about, and then go back to the real world, and maybe I'm a better medical student or a medical profession, right? I could actually learn skills from one to the other, but only if that VR is a decent emulation of the physical world, meaning if I'm manipulating tools, that VR must have things like forces and etc. And though his displays were very rudimentary at the beginning, in his vision he lays out things such as, you know, the ultimate display, he calls it, that vision, should serve as many senses as possible. That would involve things like smell or taste, and even kinesthetic, which is, you know, fancy lingo for forces, right? So it makes sense if I'm training how to do palpation and being a better surgeon in VR, because it's great for training, it's very safe as well, and I can replicate, I can do it 100 times. Well, if it doesn't have forces, it's not gonna lead to a transfer of knowledge into the real world. So we need that kind of VR, and early pioneers of VR knew that very, very well. So where did we go from here, from the 1960s to today, which is 60 years of VR? I'm just surprised to say that. You've probably seen these graphics, you know, mapping out the evolution of VR. Super fun, you know, seeing Ivan Sutherland here in a corner and all kinds of headsets. And this is a commercial type of map. If you would see a more, you know, research map, you know, Anthony would be here all over the place in the 90s inventing all kinds of things. But this is a commercial type of thing. You might remember some moments here, like the first Oculus coming out, and many of us trying and being very impressed. I was, for sure, by that device. And I took the liberty to extend this map, and over here I just put a blob of everybody's making VR headsets. This was a nice moment, you know, 5 years ago or so. Every company was very excitedly making their own version of a VR headset, and I was happy to see that as a researcher myself. And it seemed more or less, and I'm sure many of you won't agree with the ones I've put here, more or less we're settling on some big players that came out with headsets just in the last days, but also in the last month, in the last year, that are fantastic and do lots of cool things. So maybe that's it, the end of the talk. Thanks, Lucas. And that's it. We've reached the ultimate display. But all of you know that's really not even close to what Ivan set out with smell and taste and forces. I've never seen smell, taste, and forces in the Apple Vision Pro or Microsoft HoloLens or Orion, which obviously I haven't tested because it came out 3 days ago, and the Apple Vision. None of them have that. None of them will lead to situations when I'm training VR physically and learn something that I can then transfer to the real world. They're visually really impressive. I've tried at least 3 of the 4, and I can say they're impressive visually, but not bodily impressive. And so the question really underlying all this is, like, what's so hard about this? How come we've conquered displays, we've conquered all the engineering needed to make very small tracking systems to track the hands, to track the room, but we just can't seem to make the same amount of progress at the same speed for touch and forces and temperature and smell and taste and so forth, right? So let's start with forces, just because that's what the VR wall is. A wall is just a moment of a lot of force that I can't penetrate through. So why can't the headset provide that amount of force to the user's body, to the user's legs, to make the VR feel less ghostly and more immersive? So let's pinpoint that moment, and let's rewind a little bit the history of robotics, the history of interactive computing, and you'll find out that, you know, This was solved once and like really beautifully using a type of device that you could also call a robot arm, but more typically we call this an exoskeleton, that is just a bunch of motors that can resist the force of your body. So if I play this video, you'll see this user, he's happily in VR, not wearing a headset, but this is the simulation. He's rolling a ball up and down the incline, and as he pushes the ball up the incline, the motors, they force against his body. It's harder to move. That simulates gravity acting on the ball. The ball feels harder to move. This is a really, really like realistic kind of device. He's smiling because, it just feels real. If this was the training, you would then go up to roll balls up the hill and you would like feel, wow, this is, I trained over there. I'm better at this task. So why can't we have this? Why does the Vision Pro, or what's the newest one, the Orion, why does the Orion not ship with this in the box? And the answer is kind of obvious, but it's because the priorities have shifted tremendously. The priorities here in modern VR are small devices, untethered, mobile, powered by battery, no cables. The tracking system is included in this thing, which I never thought I would even see it. When I started, the trackings were very complicated. But this is the opposite. This is tethered to the wall, tethered to a power source. It actually is tethered to the wall for two reasons. One, is very heavy, and two, Newton's third law, it must push against the wall to provide a counterforce, right? That's Newton's third law. For every force, counterforce. So it's very hard to combine these two when these two sort of have gone in different trajectories with different optimization goals, mobility, extreme realism. So my question is there a way to bring some of these benefits of this amazing device, don't get me wrong, really, really exciting. I've tried things like this and they're just mind-blowing, but have everything else we've grown to like in today's modern VR, right? Like untetheredness, lightweight, unencumbered, right? And don't forget, this person is fully attached with these exoskeletons. They can't even shake your hands anymore. They can't even put the very VR headset on if you're having to grab the exoskeleton. So how to make these things convenient, less cumbersome, yet have the same output force? If there's any mechanical students in the room, you might be like, oh, I could just make the motor smaller. And then you run through your head and go like, that's true. But if I make the motor smaller, although there's less weight and less battery requirements, I also reduce the output force, and I can't do a wall anymore. I can't do training anymore. I don't have the same capabilities in the haptic device. So the key issue here is really that we're doing a lot of things hoping that the laws of physics and the laws of mechanics behave in the same nice way that Moore's law, which is the reason why computers get smaller, smaller, and smaller. We can just pack more transistors in a small space. But these two things don't work in the same way. Moore's law, so far, is giving really, really tiny devices. Motors don't obey Moore's law. They just, if you make them smaller, they're like, well, very little force. Okay, so here's one approach that I've started to explore actually during my PhD. What if we, instead of using motors to push the body, integrate the hardware in the user's body? In this case, let's use electrical muscle stimulation as a way to actually get the user's body to move. And this is not a technique that I've invented or people in VR have invented. This is a long history of medical rehabilitation since the 60s. And maybe some of you might even have experienced muscle stimulation where you go to the doctor, maybe you have your leg in a cast and your leg is potentially atrophying by being in the cast after breaking your leg or something. They'll put these electrodes, they'll dial some knobs, and rebuild a little bit of muscle tissue. Here, we're not giving the knobs to a doctor, we're giving the knobs to the VR application that says, I need a force right now, let's stimulate the body. And what happens is if you stimulate with a tiny, safe amount of electricity on the two electrodes on the top side of my arm over there, what happens is this. The wrist sort of moves involuntarily and automatically up. So now the VR is able to displace parts of your body. The VR is able to control parts of your body. Not just input, this is now the VR outputting. And playing that game, we can now turn the body into a force actuator. And so we can return back and explain what the force feedback device was. And again, like Lucas said, this is work that I've done at HPI with my former PhD advisor, Patrick Bowdish. And you can understand what's happening. He's wearing all these electrodes, and the VR is sending the force commands to the system and saying, generate a wall here, propel his hand backwards. Actually, he pushes the button now. It's actually really hard to push this button. You have to make force, and it clicks at the end. It gives you even like a little click. There's some projectiles being fired at him. He deflects them, but as he deflects them, there's an impulse. His arm flies backwards. And in this final room, which is kind of a crowd favorite when I gave these demos at SIGGRAPH and other conferences, I actually return back to that idea of gravity. So he picks up these cubes eventually. When he picks up the cubes, what is going to happen is that his arms involuntarily go down, and he has to voluntarily kind of go up. And these two forces are in opposite directions, and they sort of feel like gravity. So we're able to generate force feedback, and yet the device is so small that if I would like roll down my sleeves, there would be no device. You wouldn't even see it, right? So that's much, much smaller when you juxtapose it with this mechanical approach of the exoskeletons, of any robotic approaches. So in fact, if you can only remember one thing from this talk, from this keynote, I would say it's this slide. The idea, the core idea that I'm trying to pursue here to push VR into a more mobile and yet more immersive form factor is, what if instead of adding more electronics to every single VR headset to produce forces externally, like if you want to produce the force of a wall, you go and ask yourself, okay, what thing do I add? A motor, and you add a motor, and it turns out it has to be a big one. What if we just go out to the world and see what's the minimum set of components we could find? Minimum set, and we stop there. That are sufficient to trick the user's biology into internally generating that sensation. The desired sensation, like the thing the VR programmer is thinking about. And that case is force. Okay, what's the minimum set? 2 electrodes, tiny safe medical stimulator, done. And now put that with the VR simulation, send the force and let's get the wall feeling like a force. Okay, so that's the thing that you should remember, is this sort of approach of actually putting less electronics than putting more electronics, because our body turns out to have, and the body has been a really nice theme in this session today, our body has a lot of methods to generate the sensations that we need to feel. I wanted to just show what's inside one of these devices, because it's not going to be a super technical talk, but I reckon people would enjoy seeing what's inside. And so you can see there's nothing really special inside of one of these devices. This is one that I made a long time ago, more than 10 years now, during my PhD or before maybe even, and has a microprocessor inside, like a little computer inside, has some wireless capabilities so we can receive information from the VR that says, please generate me a wall here, generate me some force here, there's a punch over here, etc. And at the core sits this medical stimulator, the same that you would see in the clinics by the doctors, except instead of being a doctor controlling it, it's the VR that uses these digital circuitry to control it. There's batteries, and in the end, most importantly, there are electrodes that connect to the user's body to deliver the stimulation. Now, if there's engineers in the room, you're probably as excited about the slide as I am, because there's a secret in this slide, which is from here to here, the entire left side is what we call solid-state electronics, which means stuff that we can make really small for nothing. That's what the things that abide to Moore's law are solid-state electronics. So this is big because I was a really bad engineer back in my PhD years. But my PhD students, like Lucas was saying, they're so much better. You want to see the equivalent device made by my PhD student, Jazz? It's this. I'm not joking. This is equivalent circuit for all this thing, electrodes, wireless, Bluetooth, everything, stimulator, and puts in the nose. I'm not going to explain why I would want to stimulate the nose in this talk, because it's not about VR, but if you want, you can ask me later and I'll show you some fun videos. But it's the exact same device, right? So the electrodes are the only thing that is not solid state. We need the electrodes to cover whatever area, the nerve system of the user we need to stimulate. It's a muscle, it's fairly big. It's the nose, is very small. If it's the brain, it's very small, so forth, so forth. But it can be made really, really small, which is very exciting, and you'll see much more smaller miniaturized devices through the rest of the talk. All right, now what's fun about this is now we have a new type of device. It is very small. It produces forces different from the mechanical exoskeletons. Let's see if there are new applications that we can come up with, because it's just so small. We can apply it in situations where we probably would not be wearing an exoskeleton. So I'm showing you something in VR. Let me show you something in augmented reality, right? So augmented reality, very similar, though I'm superimposing content in the real world. So this is sort of like IKEA simulator for choosing your couch and buying a new couch. This is a virtual couch, although it is a physical space where she's putting the couch. This user is dragging the couch, this virtual couch, but as she's doing that, she's actually feeling the forces and the boundaries where the couch is at. She actually feels the friction by the muscle stimulation as she draws the couch through the floor. More importantly, when the couch hits the real wall, and remember this is a virtual couch, she feels she can no longer push the couch forward because the muscle stimulation is preventing her from doing that. So she can actually figure out how this couch is going to fit. She figures out how the space is going to look. For us, it doesn't look very exciting, but from her view, it's like really cool red couch. HPI has cool red couches. All right. I'm going to fold all this stuff about, force feedback into this little chapter. We can talk more about that later if you're interested, and go on to Ivan's next challenge, which was, what about temperature, right? If I'm in VR, be a social VR around a fireplace is not going to feel realistic if it doesn't feel warm like a fireplace would feel. And in fact, we've done studies where we put people through these types of VR simulations. A training in a desert or a hike in a snowy mountain, and if you don't turn on the AC, like the real room AC up or down, they look at you and go like, really? Like, this is not very realistic if you're telling me this is a desert and I'm not sweating. So people have done beautiful things like this, by the way. This, again, I'm juxtaposing it for the sake of argument, but this is very, very effective. People put a heat lamp on top of you as you are in a VR desert. You really start to sweat because the air around you is so hot. And it's just one of the most immersive things I personally have tried, right? My body's super involved to the point that thermoregulation kicks in and I'm producing sweat. Now, obviously, I could ask the question again, why does the Meta Quest X does not ship with this? Well, because the battery of the Meta Quest would drain if you turn a heat lamp on it with a kilowatt power per second. You could do the same with an AC unit. So obviously, we want to explore something smaller, less energy, more convenient. And let's see how the answer is, again, to integrate with the user's body. This is work by my PG student, Jazz Brooks. So you see here a user in VR. She's actually in front of a fireplace, and she feels like the environment is kind of hot. But if you look at what she's wearing, this is a weird device. This is not a temperature device. She's in a controlled temperature room. Nothing in the room is changing temperature, and yet she feels slightly warm. What's actually happening, and oops, I jumped over something here, is that, I don't know if you can actually see it. Let me play the video again, because I hope you guys could see this part. It's nice. Is that we're projecting a little amount of a chemical as she inhales. And I'll superimpose a little graphic so you can actually see, because the chemical is so small, and we atomize it in little pulverized puffs. They're so small you can barely see it in the video right there, and you can't still not see it. And she inhales that. And you're probably thinking, what does inhaling something and smelling, olfactory and all that has to do with the sense of temperature? Nothing. My skin feels the temperature of the room. End of story. What does the nose have to do? If you zoom into the human nose, you'll find, just like in the lining of our cells of the skin, what you have is cells that detect temperature. So they react if the temperature is like above 45 or below 10, and they fire and tell your brain, it's really hot, it's really cold. However, and you know this, you've tried this, all these cells have another gateway, another entry point. They're chemically stimulated. If you eat capsaicin, which is that main ingredient in chili peppers, right? If you go to like the Indian restaurant and eat some really spicy food, you feel really hot. Now, contextually, you know what's happening. You look around, there's food, and your brain goes like, okay, hot because of food. I've experienced this before. But if you go inquire to that particular cell, it just was triggered. It doesn't know if it's chemically triggered or, temperature triggered. It just reacts and fires and tells your brain. In the absence of that cue, because you are in VR and we're not showing you spicy food, this thing is actually, once we purify it, it doesn't smell like capsaicin anymore. You just feel hot. So the trick here on how she feels hot is that she's inhaling a little bit, a minute amount, microliter dissolved of capsaicin, and she feels like the heat of that furnace. Now the room is going to be blown open by like a gust of wind, gets really cold, and we do the opposite trick. We switch into a chemical that triggers another receptor, and you've all experienced this, eucalyptal or menthol. You take a breath mint, a chewing gum, so refreshing. Like, it's refreshing because it physically triggers the cells in your oral cavity that get triggered. Those are called the trigeminal receptors, trigeminal cells. And so she's walking around outside and gets colder and colder because she's outside, and you emit eucalyptal more frequently. It's really fun. If you ever come to the lab, I would highly recommend asking Jazz to try this one because it's kind of crazy realistic. And then she finds the backup generator and goes back into the room. I won't play the rest, but you can watch any of these videos entirely. These are longest sequences on YouTube if you're interested. Now again, by juxtaposing the two, you realize that all we're doing is an illusion. There is no temperature changing. It's just telling your cells what internal sensation to generate. All we really need to do this is a microwatt of power, a little quarter of a watt, sorry, to really just pulverize. And then you can smell those chemicals. There's certainly other, even more power-efficient ways to deliver that chemical into the nose. What I want to say, though, is that it's the same story as you've seen before, right? What's the minimum set of components we need to internally generate the sensation of hot or cold? Well, it's just talking to the receptors, to the cells that already do that in your brain to generate hot and cold. Again, we can keep moving from challenge to challenge, and you'll see that the answer kind of keeps being integrating with the body. This is a simulation of like sort of training how to, deal in a situation. If you spill a chemical in the lab, something that my students have to do every year, as they're training how to operate in such emergency situations, and this is a VR training of that. You accidentally spill a chemical, what should you do? You actually should wash your hands first, then your eyes, and only then the wound. If this doesn't feel real, if it doesn't feel like touch and an emergency of touch, almost painful touch, people are like, yeah, VR training sounds cool, let the wound be there. I'll wash my hands later. So again, turns out the answer can be the same one, can be to directly speak to a receptor of your body that generates the touch sensations. This is actually work by Jasmine, one of my PhD students as well, in collaboration with Jazz, who you've seen before. And I think this will start playing in just a second. There we go. This is called chemical haptics. And what we actually do is the same approach you've seen before for the nose, but we apply it to the entire cell. So the device that Jasmine is wearing here on the arm, but she's also wearing one in her cheeks, actually. You cannot see it because of the VR headset, is a device that allows her to feel super strange, very, very immersive, rich sensations in the virtual reality. Well illustrated by this example here. So she's in a simulator.
Nuclear reactor overheating. Please report to control room immediately.
She needs to find where the nuclear reactor room is, and she's using this arm device in VR to see the map, open doors, etc. And of course, nuclear reactors overheating is never a good thing. There's a big explosion, and her arm device goes crazy with electrical interference and sparks and so forth. And here, instead of using the canonical type of simulations people do in VR, which is maybe vibration or electricity to make you feel like something is tingling, what Jasmine does is she, again, passes a chemical. There's a chemical, I don't know if you can see a little snaky chemical going through these tubes. These tubes are open to the skin, so the skin is slowly absorbing the chemical, and this has a chemical called sanchul, which is also a food spice, and creates a feelable vibration. What's really cool is that she can just change the chemical and she gets a new sensation. So in just a second, she goes outside, it's very cold, she changes the chemical from sanchul to menthol, and in her cheeks is gonna pass menthol, and it's like Chicago cold level of like blasting cold. Menthol is really strong, it's actually stronger than eucalyptus in terms of the cooling that it kind of activates those cells to do. We can do lots of other sensations. You've seen the warming before as well. We can do things like numbing even. And of course, the one that I was showing you about for the training, we can do cinnamaldehyde, which creates a kind of strange stinging type of sensation, almost like painfully stinging. Again, the trick is the same, right? You could go and find individual devices. People have engineered beautiful haptic devices that create skin sensations, but you would come up with a constellation, the whole body would be full of very crazy haptic devices, or you can try to just ask the user's body to generate those sensations by talking to those cells specifically and saying, please make me a vibration here, please make me a heating here. Now, I do want to flag something that I think this audience will enjoy, which is something we do here, and I feel like we all do in VR because we can get away with it, which is in VR, when we want to create haptic sensations like touch sensations, skin sensations, etc., everything is fine. We can cover up the body part where we want those sensations to arise. Like over there, we cover up her arm, all was fine. However, she can no longer use her arm to feel something because her arm is now covered by that device. This is how we came to the idea of VR gloves, which we're sort of like all very okay with, and especially mainstream, the companies are all very okay with. In fact, if you Google for VR glove, there's like tons of them you can already buy. And Meta, of course, is working on one. It's a very, very cool device. And this is all fine. Like if you really apply this to VR, everything works out. And just for the fun of it, I took the VR Summit poster. I hope that's okay, Art. I took the poster, and let's see what happens if she's wearing a VR glove to touch that little flying dust. all good. We put a glove on her with vibromotor actuators per finger. Her fingers are now covered, but that's all she's feeling. Everything in VR is generated. It's all fine. You could argue that's going to be a little bit hard to remove the headset if you have a big glove with so many actuators. They're kind of clunky. But besides that, if somebody else puts the headset on her, it's going to work out. Let's try the same thing in augmented reality. You all know augmented reality, same thing except we can see through. Great. So this is a device by Microsoft, very cool, especially for kind of like Microsoft HoloLens, for type of work situations. So this person is having a Zoom meeting while she's also repairing this engine. Maybe they're collaborating on how to repair this engine. If she wears gloves and touches the, hang up the Zoom call, she will feel a zzz. Great, more usability. She feels the device as she's touching it, fantastic. However, if you're wearing gloves, I can guarantee you cannot fix this engine and manipulate tools because you lose all the dexterity needed to do that. Turns out we even tried, and people can't even put the VR headset on, if they're wearing gloves. They can't even shake someone's hand. The dexterity goes down by a factor tremendously. You can't even type on your keyboard. So what I'm saying here is that, funny enough, and my talk is not going to stop the companies from working on gloves. They should do it. This is going to come out. This is going to be great, but it's going to make us all realize the difference between being sort of contained in VR and being free in AR to do things in the real world. And unfortunately, this is not going to translate well into AR. So one of the things we've been doing in the lab is to ask if these ideas of using the body as an actuator, leveraging the body rather than putting more electronics on it, can solve this problem. Could I make someone feel a touch on their finger pad without covering up the finger pad so they can still type on a computer keyboard? And at the beginning, when we posed this question, we laughed at ourselves and said, no, it's a paradox. The receptor is there, so we need to put something there for the person to feel like they're touching in that location. There's no magic thing going on here, except we realize that every single cell is wired from the brain to the receptors, and so maybe there is a way. So hold on a second, and let's see this demo here. This is one of my former interns, Arata, kind of posing here as a participant in a study that we did where people could actually climb in this mixed reality, and I call this mixed reality just because it has physical objects. I'll show you something in AR just in a second, but this is also AR in the sense that this rope is real. He's in a training gym in mixed reality, training with real ropes, but physical kind of walls, virtual walls. So his hands are unencumbered in the sense that he can grab the rope, no problem, feel the edges, climb all the way to the top, so he can now finally start bouldering and climbing. And the virtual holds on the walls are all virtualized, but he feels them. He actually feels even the shape of them, like, oh, this one is like rounded, this one is spiky, I should adjust my grip, and so forth, so forth. But if you look at it, there's nothing in his palm. All the hardwares are on the back side of the hand. And what we're actually doing is a little bit of a neuroscience kind of hack, which we strategically place these electrodes in locations where we know that the nerve from the brain is going through and kind of passing over close to the upside of the body before it like shoots down and connects to this side. And we intercept and generate the sensation on the backside, but when you ask people where do they feel it, 98% or 7, you have to look at the paper for the number, I think it's 97% of the times, they say it's in the front, right? So we like trigger that sensation from the back. And you can do really, really fun things in mixed reality. This is one of my favorite applications. Again, if you come to the lab, please try this one. You're kind of molding, sculpting with clay in mixed reality while also kind of going with instructions and just imagining trying to do this while wearing gloves. We've tried, and it was really, really, really hard to even get the clay out of the bucket, much less like make the cute teddy bear according to what the virtual model is telling you. You're supposed to feel it, and you can actually feel the haptics of the virtual model to see if the two are aligned and if you need to put more clay here or remove clay there. It's a really fun demo. All right, so I'm going to also fold this idea of the body becoming a tactile actuator and go to our last challenge, which was, can we figure out taste? And taste is a really, really difficult one. This is almost where, me and my students kind of threw the hat down and be like, oh, you can't do taste. This is just, what a nightmare. Like the sensations, the biochemistry is all really complicated. So much that what people actually do in VR, I don't know if everybody tried a VR with taste, is to just use food, real food as props. So you actually eat a virtual food like you eat a lemon, and they give you a physical slice of a lemon. And that's cool, but I'm like, well, that defeats the purpose of VR. The purpose of VR is to generate things cheaply. If I need N props for N foods, that's not going to be very scalable. That's not going to be very exciting. I wonder if I could have one prop just to have a real sensation, real like chewiness, real explosion of taste in the mouth, but then somehow cheat my way into making one food feel like many foods. And that's what we do with this project, more recent one called taste retargeting. Maybe some of you have heard of haptic retargeting or redirected walking and like things like that. This is taste retargeting. So what's happening here, this is again work by Jazz Brooks, one of my PhD students, is a user eating props. She's eating blackberries. And in VR, she saw blackberry. This is a survival game we made where you have to eat to survive. And later she finds a lemon. So this time she picks a lemon, but notice this is just blackberries. She's eating a slice of lemon, and yet somehow the whole experience feels just like she's actually eating a lemon, although she's eating the blackberry in real life. It's only virtually that it appears to be a lemon. We've tried just the visual illusion, didn't work. Check the paper for details. It's very, very unimpressive, the visual illusion. But somehow this worked really well. And actually Jazz got an award from the jury when they tried the demo at the conference. What actually happened is before she ate the lemon, the device she's wearing on her mouth, on her lips, you might see little lip cuffs over there. This device, just before she ate the lemon, so about the time she finished eating the first blackberry, activated and started delivering a chemical that we call a taste modulator. These taste modulators, and you'll be able to see just for a second the liquid passing through the tubing. This is just for you to be able to see the liquids are actually colorless. Can selectively change taste perception. It can, for example, take out sweet, take out salty, boost the umami. They can kind of go there and hack your taste perception. It's not the food that changes, it's your taste buds responding. And so in this case, we use a thing called lactazole, remove the sweetness. What does a blackberry taste if it's not sweet? Well, it's acidic. It's kind of like a lemon. And on this one, people rate it like almost as a real lemon. It kind of goes down as you try to push off a little bit to the extreme. But this one, they really buy that it's a lemon. They like almost 100% of realistic on the lemon. But you can do all kinds of things. I think in just a second, after she eats the lemon and gets convinced that it is a lemon, you'll see her kind of going through transforming the, if I remember correctly, the blackberry into a strawberry. That's probably my favorite transformation. It comes like a party trick. It uses a chemical called miraculin, which is actually sold as a party trick, but we diluted very small. Oops, you don't see it anymore. You can see it here. And then at the very end, we reduce everything, and it feels kind of just plump. And you should go on YouTube because people react like, whoa, and they're eating a spider. It's just like the plumpness of the blackberry exploding and the gushing things inside. And people actually kind of believe it. So to sum it up, the idea here is how can we walk these modern devices, VR devices, super convenient. And if you look at the things, these are all modern VR headsets, small things that we're not adding anything big like an exoskeleton. How can we make those devices go closer to that vision of ultimate display by really involving the body, right? Integrating more of the user's body in the experience. And yes, things like smell and taste will have to be there. Things like temperature are absolutely crucial. And of course, forces, because everything we do in real life is about fighting forces. So if VR doesn't have forces, it's never going to work, especially as a training simulation. All right, so I'm just going to conclude now and give you some takeaways, things to think about. The first one, and this was one for myself too, it's kind of fun to think about this. We're used to seeing the VR timeline like this, right? Oh, cool, all the inventions that happen in VR looks really disconnected. Just like, how did we jump from Nintendo Virtual to the Oculus? What happened there? There must have been something. Like, how could Palmer Luckey develop something that Nintendo couldn't develop? Nintendo's a massive, giant company full of really brilliant engineers. And the reason is because we're just looking at the timeline of VR. We're not looking at timeline of computing and the evolution of technology and computing. So if you actually put here how historically people interacted with computers, things start to have a little bit more context and explanation. So over here, kind of like first VR arcades and first cool VR consoles, they were really, really cool. It's just ahead of their time for sure. Is the time of desktop computing, the time when computers and users were stationary, computers were still kind of big, so no wonder VR was going to be an arcade that you go to and play there and then go out of. It made perfect sense. And still, these computers were not portable, but like this changed the world entirely, like desktop publishing, It's completely reformed after desktop computers came out, right? People writing newspapers in computers and the internet and everything. Like, it changed the world despite of the fact that it was still not portable. So now we see this next generation in a new light. And by the way, the Oculus Rift coincides beautifully with mobile computers coming out. In fact, those who know that if you take the Oculus Rift apart, you kind of just end up with an Android device inside that is kind of all taken apart. Is the screen, is the accelerometers, which were used for this rudimentary head tracking at the beginning, and turns out that was mass-produced because phones had accelerometers. And so the whole thing is starting to gain much more traction as we see it like that. And again, these devices sort of unleashed untethered VR because they had to be untethered themselves for other reasons, right? So I can put them in my pocket and access information on the go. And so VR sort of becomes untethered. These are very different looking from the previous stuff that all had cables and consoles to connect to. And of course, we keep going, and now it all, again, I think makes a lot of sense. Sort of the first time the little bubbles collide. This is the user bubble and the wearable bubble sort of touching, and wearables have this really weird kind of device that kind of straps onto us, and so you start to see like the Vive trackers, which a lot of you I saw in your slides, or the controllers that also strap to our arms, or literally this week, this Orion device came out from Meta, which has an armband that uses electromyography, so your muscle movements are being used, and all of these things are just strapped to your body. And that's only possible because the things we do with wearable devices are very different from the things we do with mobile devices and desktop. They are connected to our body 24/7, so they afford new capabilities. So the story here is that every time there's a revolution in computing, the VR folks are smart enough to find a new capability to put into VR. And so what I think we should all be thinking about is what happens next, right? What happens with this evolution from, this can start earlier, infrastructure like computers, like really like back in the days in the 60s, computers, only one room was a computer. This is called mainframe computing. Desktop, mobile, wearable, what happens next? And you don't have to buy my story, but you should definitely think of what happens next. I think these bubbles are getting eerily close together, and we should start to look at that overlap between the two and see what happens when the technology integrates with the body. And the devices that I'm showing you today are just intentionally created to show you that, intentionally created to borrow parts of the body for input and output rather than adding more technology. And maybe, who knows, like that little meta thing that came out this week with muscles as input is a little part of this integrated story, because now your muscles are part of the thing that controls the actual device, and so forth. They're part of the hardware. It's not even just output movement. It's literally part of the hardware that controls the device. All right, part two of these takeaways is that, we've talked about touch and forces and some other fun senses that are often overlooked, but there's so much more, right? Here's another example of what you can do once you have extremely miniature actuators like the muscle stimulation. This is, again, work by Udai. And what you see here is a person doing a fire training simulation in augmented reality. This is my lab. They're learning what to do if there's a fire that breaks out in the lab. And they miss the next step. The next step is to go and grab the fire extinguisher, which is under the table. And in this case, the muscle stimulation kind of takes over and forces their head to rotate and see the fire extinguisher and go and grab it, right? So we're changing the point of view. We're changing where you're looking at in real time so that people have like a physical memory, like a muscle memory. It's over there. And they memorize that feeling where it actually is. We're actually studying whether muscle memory works like this, or we're just confused. But I also invite you to watch the rest of this video, because the simulation is going to guide him on how to leave the room, how to do the fire escape, and all these things, which is something that is very hard to do when there's an actual real fire, which has happened in my lab too. Obviously, we're not the first to say, hey, let's move someone's head and move their viewpoint. Our colleagues in neurology and medical rehabilitation have been doing this, again, with beautiful exoskeleton devices. What I'm asking is, again, this is probably not going to work with the VR optimizations for portability, convenience, and everything. Perhaps something like that could. So we're just seeing the use cases, how they change when we have a much smaller actuator like that one. And turns out this difference between a neck motor and a neck muscle stimulation are not the only differences we've seen in size and also in power consumption. You saw the same story with the arm motor and arm muscle stimulation with the chemical and the heat lamp. Turns out usually when we do this trick of integrating with the body, we end up with smaller things and more power efficient things. The other part that I'm kind of excited about is asking the question, how far can we push this, right? Could we have, for example, one haptic device that replaces a bunch of people have done things where you're like full VR suit full of motors and vibrations, and you can feel sensations in the whole body. Turns out they're really heavy and hard to wear, but the sensations are just amazing. Could we have one device that kind of does it all, and we don't need to wear such a heavy kind of instrumentation? And so maybe another way to ask this question is, how far can integration go? Can it go to the brain? And so here you see a project from this year called Haptic Source Effector, also by my student Yudai Tanaka. And what you see here is a user in VR, and he just got hit by a projectile, and he felt a tactile sensation from the projectile. And now he's actually going to fire back to the enemy, like kind of posing this gesture. A projectile comes out of his hand, but actually what's happening is that the VR headset is instrumented with a neuroscience device called a transcranial magnetic stimulator. This is a coil that generates an impulse that can stimulate your brain without having to implant anything inside your brain. So once we generate that impulse, the impulse will kind of tell his body that that area that we're stimulating is the area responsible for hand sensations. So he'll feel like the projectile is coming out of his hand. He'll feel like a tactile sensation in his hand, though he's wearing nothing in his hand. The only thing he's wearing is a VR headset, which happens to have a coil on top. Now what we're going to do is move that coil to another location, to the location in this brain responsible for feet sensations, or for foot sensations in the case of one foot. And when he gets hit by that projectile, again, little magnetic pulse in his brain in that area of the motor cortex that is kind of responsible for that foot, and he feels, whoa, something hit my foot, although there was nothing in there, right? He's only wearing one device, although he feels sensations in about 17 individual parts of the body. Now, last kind of moments of the talk, a lot of the things I'm talking about are VR training and VR augmentations of things you might already be able to do. I'm not showing you details of this work, but we do a lot of work on how can people train better with muscle stimulation. We've done things like people doing two drawings at the same time. One drawing is muscle controlled, the other drawing is voluntarily controlled. As you can see, the muscle stimulation is not great at drawing. Piano playing, that's great, people like it a lot, or guitar playing. But these are things that people know how to do. You just don't know what the next key in the piano melody is, and the muscle stimulation goes like, I know which one it is. Bing, and you go like, great, thank you. It's just extending abilities that you already have. But over the past couple of years, we started asking the, I think, harder question, which is, what about new abilities? Like things that your biology isn't even ready to do, wasn't evolved to do, right? So we've done a number of projects here, including speeding up someone's reaction time. This one you can find in the Guinness World Book of Records, which is kind of cool, that old school book we had when we were kids, with muscle stimulation, giving people a sense of stereo smell. But I want to show you this one, which is a work in progress. There's no paper, there's no anything. But from the last couple of weeks, and I promised Lucas I would show this one to him as well, which is how to speed up your reaction time by not forcing you to do something, but just helping your brain to be a little bit faster. So this is a person, this is work by Yudai Tanaka again. This is a person using the transcranial magnetic stimulator, that little thing on the brain that stimulates your brain with magnetic pulses, non-invasive. Here the system is off, and she's going to try to do like a really fast hitting of a ping pong ball in an esports game. And she's going to miss it because it's really, really fast. It's like the type of thing where like 8 milliseconds make all the difference. And here we're going to turn the system on, but the system is working at a very, very low intensity. If she would just be standing still in the system, she wouldn't move. All the system is doing, the transcranial magnetic stimulator, is to heighten a little bit the electrical activity in that area of the brain, so it's like easier to excite. It's already pre-excited a little bit. It's like repeating the same movement over and over. You're kind of exciting that area, so you're kind of faster at reacting. So we just do one small pulse before she does it. This pulse does nothing but pre-excite that area, and she's able to actually be about 10, 8 milliseconds faster. Depends a lot on the person. Some people are really, really fast, and she gets that ball. But it's her that does everything. She decides to move. She decides when to do anything. We're not forcing her to anything. We're just helping her become permanently kind of faster. All right, and last but not least, and this will just be a really, really quick slide, I've shown you a lot of sort of body integration that has everything to do with neurons and chemical cells and more the neuroscience of human-computer interaction and more the human of VR. But I think you can take this idea of human-computer integration to different levels of VR as well. So for example, just to show you very small teasers, we've done work, this is work by my student Chen Yuan Tang, my PG student, where he uses a VR haptic device that has no battery. It is the user movement, moving around in the room that is charging the VR device all the time. And he actually conducted a study, and people did not notice after hours of using this that they were the ones charging the thing, because in VR you can craft a story in a way that you kind of hide that you're charging the device. Really, really beautiful work. Alex, also a PhD student working at Meta right now, he's done some work on integrating physical terrains and temperature sensations in VR. She's holding part virtual object, part real object. How do you do this sort of integration with physical props? And Yujie, who was my master's student, now a PhD student at Stanford, worked on integrating distractions in VR. If I was in VR and somebody opened that door right now, a gust of wind would come in and I would be like, oh, this doesn't match the VR experience. Whoa, immersion broke. Yujie's device detects the gust of wind and changes the VR world in real time to also have a gust of wind, and you go like, whoa, that's super immersive. I felt wind when there was wind in VR. Wow, what kind of haptic device is this? It's nothing. It's just that she leverages every distraction in real time to integrate in VR, and people sometimes don't even spot that she's doing that. So really, really cool work. All right, final slide. This is my team. They are the people who really did the work. I am really just sort of channeling it here for all of them, including some of our alumni who aren't with us, but you saw their work and their faces today in the talk. And I'd be happy to answer questions after this, as we're just chilling around the festival and trying demos. And I want to give a big shout out for the organization team, especially Art, for bringing us all here together in physical space. Thank you.
Okay. So I'd like to ask everybody to return to their seats, please. So our next speaker is Sebastian Merkel, and Sebastian is Professor of Digital Health at the Ruhr University of Bochum, and he is going to talk about VR and AR in healthcare. Sebastian, the floor is yours.
All right. All right. So first of all, thank you all for giving me the opportunity to talk to you. Before I start with my presentation, I have to get two things straight, I guess. So the first thing is that I'm not a VR, AR, or XR specialist, or you ever want to call it. And the second one, which is probably even more important, is that I'm a social scientist by training. And hence all my research does not focus on technology per se, but more on human-computer, human-technology interaction, design processes, what ideas and what imaginaries of designers actually feed into the final technical products, and how these products are implemented in the real world. And specifically on the last topic my presentation will focus on, because I will not show you like potentials of VR and AR in healthcare that exist. We don't need to discuss that, but more why it has not achieved the potential that many people actually wanted to achieve. So why there's a so-called adoption issue or an implementation issue. And my presentation will be based on research, well, not necessarily our own research that we conducted at my professorship, but more on what is outside in the field on research and what we can make of it to better implement or design VR and AR solutions in the field of healthcare. Now, we had already a couple of presentations that gave you some ideas of how these VR technology in the field of medicine or in healthcare might look like. The colleague from Switzerland, for instance, this morning or later on, the final keynote of today, they will also touch this topic. But just to give you a brief overview, an idea of the very versatile field, I brought along this, visualization here. So this shows basically the results of a bibliometric analysis. And in bibliometric analysis, what you do is that you look into all the research that has been published on a certain topic, well, in this case, VR in healthcare. You map it, and then you analyze it, and ultimately you end up with some sort of map that shows different clusters of here that are visualized on the left-hand side and on the right-hand side a bit more in detail. Now, if you look into the results of bibliometric analysis, you need to consider two things. The first one is that it only is based on research that has been published, right? So it doesn't say anything about the wild or what has been achieved so far, what has been implemented in practice. And the second thing is that it doesn't say anything about if it's successful or not, right? So it just gives you an idea of what people think might be interesting in the field of healthcare, or where AR, VR in this case solutions might fit in. And all these clusters shown here, I put them on the right-hand side. I left a few out, to be honest, and I added one, but I will come to this later on. Now, as I said, this is only to give you a very brief idea about how it actually might look like. And the clusters that have been identified here are, for instance, using VR to support the physician-patient communication, right? I mean, every one of us knows that it's sometimes a bit tricky, and obviously VR might play a role here. And what the authors of the paper found is that specifically in the field of pediatric care, VR might come in handy, probably just to, exchange in a playful way between the doctor and, in this case, the children. Another area which is probably not as surprising is having on-site or telemedicine healthcare supported with VR technology, or the next clusters, physical health training or physical rehabilitation. I think we all know some applications where you use VR technology to actually help patients recover after surgery or something like that. A bit more interesting probably is the field of geriatric care, where VR is used to, I don't know, tackle memory issues of older adults most likely, or use it to fight dementia or memory loss in general. I won't go into detail on the other clusters, and since we have a keynote on mental health, or the field of mental health later on, this is also quite important field where VR technology is used. Now, I added medical training as additional cluster, so to say, and in the talk this morning we heard a couple of examples where you use VR technology to teach medical students, for instance, but also doctors, physicians, I don't know, probably before they will do a surgery. This is also quite a typical field that I assume most of us will have encountered so far. Now, I said in the beginning that this is just what researchers came up with, right? So this is what came out of the labs. But how does it look in reality? So what is happening really in the field? And well, the answer might be quite disappointing, not so much, right? If you look into research in this area, then a theme that you will encounter is that the uptake of VR, AR in clinical practice is still quite scarce. So this AI-generated picture on the right-hand side probably is not showing the reality. There are, of course, some clinics, some hospitals and so on that use this kind of technology, but not in a very broad field. And, well, this might be surprising, but if you have been working in the field of, well, health service research for a couple of years, which I have done, then you are probably, it seems to you like a story that repeats itself. Because there are many technologies, specifically digital technologies, that have been developed, and it took them ages, years, or they have never been implemented in clinical practice at all. So this is not a new story for us. We know a lot about technologies that fail in the implementation, that fail in the diffusion phase, right? And the interesting question here is, why is this happening? Now, as I said, as I'm a social scientist by training, and I would argue it's just not about the technology itself, right? But it's about plenty other factors that actually affect if something like a VR device will be used in clinical practice. And I also said that, well, we as health service researchers, we have studied so many technologies that actually have failed to be implemented in the wild that we even have our own models and frameworks to just study why technology has failed and why technology has not been implemented on a large scale. And this is actually, it's taken out of a paper that specifically looked into why VR devices have not been able to scale up, why they have not been able to achieve the potential that so many people would like them to have. And what the authors did here is they used this model. It's called the NASSS model, and this model has been developed specifically to study the failure of technology in healthcare, right? So what the authors did here is they distinguish 7 dimensions, and I won't again go into detail due to, well, the short time frame. For instance, the technology, and each of these dimension has several subdimensions. And here you can see why actually something has not been able to scale up. Now you might argue that some of the parts, they are not specific to the healthcare sector, right? So if a device does not function, or if there are usability issues, it really doesn't matter if it's in healthcare or if it's in another field, for instance, in the financial sector, then it won't be used at all. But a bit more interesting is probably the adopter system. And here's something that I would like to point out specifically. It's the lack of research on evidence and added value. It's integrating VR in routines. On the field of organization, it's the integration of VR into workflows. And I would specifically stress these 2 aspects that need to be considered when you design VR technology for the healthcare sector, and particularly for the core healthcare sector, which is in the diagnosis and in the treatment of diseases and disorders. And my main hypothesis, so to say, is that medical practices and evidence are things that need to be considered as early as possible in the design process. Because otherwise you will have, or most likely will face difficulties during the implementation phase and to unlock the potential of the technology. Now, healthcare doesn't equal healthcare. So, right, the healthcare sector is large, and what I'm talking about here is like the very core sector. It's what I said, it's diagnosis and it's treatment. These are the two fields that probably will be not only most regulated, but also most difficult to enter. So when you have something that you want to, for instance, implement into clinical practice, be it in the diagnosis, for the diagnosis, supporting the diagnosis or supporting treatment, then you need to keep in mind regulatory issues like a CE certificate, the MDR, for instance. Then you need to keep in mind the reimbursement parts, so where you have to negotiate or where you actually get money for your device, right? And finally, then you have to consider the clinical practices that you want to, change where you want to engage in. And this is, of course, only true, as I said, for the core part. Like for treatment, not for treatment, but for training, this is probably not as important, but many of the applications actually want to engage, want to get into this core sector. And what we've seen so far from many projects is that people, especially developers and designers, often do not take into account how difficult it is to get into the healthcare system, and and to also keep in mind, well, not technological issues, technological problems and barriers, but barriers of the system and also barriers of the practice, right? And this is another thing that I mentioned earlier. The healthcare sector is characterized by very diverse stakeholder groups, right? You have to keep in mind the patients, you have to keep in mind the physicians, the nurses, etc. These are embedded into organizational structures, right? So the actors that I just mentioned, the stakeholders, they typically work in hospitals or so. And these hospitals or these organizational aspects, they also influence the implementation processes. These organizations are then embedded in a larger system, right? For instance, in Germany would be the German healthcare system. And this also affects the implementation processes and the diffusion processes. And this might look a bit complicated, but in fact, it is. So I can't give you any short answer how to get something out of the lab into the clinic. It's just a very complex, very diverse field that needs a lot of experts, actually. But the good thing is, if you have these on board from the very beginning, then you can tackle some of the issues, and then the devices, the applications might, well, at least not fail, but you can tackle a lot of these barriers. Because another thing that frameworks like this do, they are not just for studying why technology implementation has failed. They can actually also be used in the development or in the implementation phase to see what kind of barriers might be encountered in this process, right? So it's not just to look retrospectively at issues, at problems. You can also use it prospectively to avoid these, or at least address them in the necessary way. The last aspect here is also a key thing in medicine, right? Evidence is key, especially if your main target group are physicians. So historically, the medical evidence specifically has gained more and more and is still gaining more and more relevance. And this needs also to be kept on their mind, that devices need to be efficient, they need to be there needs to be some sort of evidence base, not necessarily just in medical outcomes like increased quality of life, for instance, or reduced risk of mortality, but also evidence on that it actually works, that people will adopt it, and that people like the devices, right? So this is a key thing that needs to be remembered in the field of healthcare. Now, summing up, as I said, if you want to engage in the field of healthcare, it's probably quite risky, but it might as well be very rewarding. And we've seen a lot of applications specifically designed for this field. But keep in mind that healthcare is not just a key area for AR and VR applications, but it's very diverse and very, very complex. You can say that many digital technologies have not been implemented on a large scale, and which is also quite sure that implementation in most cases takes time and a lot of resources. And this is because the healthcare sector probably raises more barriers than other sectors, as that's what I was just trying to show you. One of these is, for instance, evidence that is very important, specifically if you have a solution or if you have an application designed for physicians. And the other one is that we have these existing medical practices, right? People do something they not necessarily are aware of in a certain way. And if a new technology disrupts this certain way, then there also are barriers in terms of adoption, in terms of technology acceptance, and these also need to be addressed and kept on your minds. So ultimately, very difficult sector, very rewarding sector, but be aware of all these issues from the very beginning or as soon as possible, and then you might be able to overcome them or tackle them. So here's the references, and that was my presentation. So thank you very much.
Thank you, Sebastian, for a very engaging and informative presentation. Our next speaker is going to be Michael Barngrover. Michael is the Managing Director of XR for Europe, and he's going to talk about European XR in a global context. Michael, the floor is yours.
Not sure if, yeah, now I'm on. All right. And my presentation should load in just a moment. So this is definitely going to be a change of pace a little bit, because this presentation is not going to have an academic focus or a research focus per se, though there's some industrial research in this. But the point of it is to tell you all, both here physically and watching online, a little bit about what I see, what XR for Europe sees as the state of this sector, this collection of technologies in Europe, what the importance of it is at the EU level, and then at the continental level, even going beyond just the European Union. What types of fundings are there, and then perhaps what actually is Europe's role distinctly in a global context. So just kind of getting into it, those of you who are kind of following what the European Commission communicates, and I'm sure that's everybody here and online, will remember that last year there was a communication, a strategic communication outlining the virtual world and actually Web 4.0 initiative. I don't normally talk about the Web 4.0 part because it's kind of diminished a little bit. They're together, but definitely there's been a lot of focus on virtual worlds specifically. So what the initiative outlines is that it outlines that this collection of technologies, which is immersive, which is in their definition understood as to be persistent, extended realities, immersive mixing of physical and digital elements, is of a strategic importance now and for the future. And particularly, the European Union does not want Europe to fall behind in what they foresee as a major new sector that's going to impact industry, education, healthcare and medicine, and society. And they're very concerned about falling behind. So the initiative was to tell everybody we're serious. It's not a very long text. I encourage you all to maybe look online. You'll find it very quickly in a Google search. But it outlines 4 pillars, highlighting the importance of building skills, recognizing that there's a deficiency of skills in Europe. I disagree with that definition or that presumption that there is a deficiency of skills relative to virtual worlds in Europe, but that is the perspective. And so many of the pillars are about building capacity, new training programs at the university level, and supporting with some direct investments, R&D at various levels. The initiative ultimately is leading towards something really exciting for those who understand or are familiar with partnerships. So there are a handful of partnerships. At the time, this was coming from a presentation made in February, At the time of this presentation, there were 49 partnerships, and partnerships are structures set up to be counterparts with the European Commission around specific technology, either technologies or technology verticals. And so, for example, there's one for AI data and robotics and photonics, for batteries and these things. And there's going to be one for virtual worlds and Web 4.0. Having some meetings, we've been part of the general community that's been engaged with discussing how this partnership can come about. And so it's coming, though it's not here yet. So what that means is the partnership's job is to, among other things, is to define the strategic research agenda for the Horizon Europe program going forward. So again, what this communicates is that there's a lot of importance and priority for these collection of technologies, these immersive technologies, XR and virtual worlds, and that's going to be reflected in Horizon programming. So there are right now about 80 Horizon projects that we're tracking that have XR either at the core of it or significantly featured within it. So that's a lot more than what people think. So again, I'm not sure how familiar everyone in the room is with Horizon Europe grants and what the program is, but it's a program supporting research and development. So it gives funding to consortia of universities and SMEs and large corporations, all types of programs, all types of sectors and technologies. And Horizon Europe is one program. There are programs like Digital Europe, programs like Creative Europe that are also investing a lot into XR fields. And universities and researchers and research institutions that are not universities but that work closely in the R&D space are very much a part of these types of projects. So I just give a couple examples. And the reason, again, is that 80 is a lot. That's a lot of projects across different sectors. And again, it's easy to think that sometimes, you know, in the private sector, metaverse was hot for a while, then it was NFTs, it got wrapped up with metaverse. Now it's AI. That's all true. But public funding has a longer kind of delay. Because of that, it can be easy to think that it's not still important because it's not necessarily what the private investment is chasing. But public funding is still very much directed towards virtual worlds. So if you're considering whether this is still a space for you going forward, yes, if you're aligned and if you're in a position to take advantage of some of these opportunities. And actually, I just want to highlight, Horizon projects can be very big, but these top ones, Cermos, Fox Reality, Cortex, Square, XR2, Learn in particular, are examples of cascade funding. So part of their project is to have open calls, and they give smaller grants, 100,000, 200,000, and it becomes a lot more bite-sized, a lot more accessible. To be honest, I encourage a lot more people to look at those types of grants than the full Horizon, because those are super competitive, very difficult to manage. But the sub-grants can be very targeted to giving you money to do what you say you want to do. And as long as you make a compelling case, it's really can be a perfect fit. All right. But the European Union, that's looking at the European Union, European Commission's perspective. But I want to take a quick run through a couple significant countries, because if you were paying attention last year, you might have also learned that there is a country in Europe that has a national strategy, a national metaverse strategy, and it's Finland. As of right now, to my knowledge, they are still the only country in Europe that has a national strategy outlined. Sometimes it's called initiative, sometimes it's called strategy. It's being actually spearheaded. I mean, it's a collection of different entities, but Business Finland is the main driver. So it's all about trade and industry. It's really unique. And a lot of other countries have been trying to figure out, how can we be number two? What do we need to do to bring together a strategy that brings the government along with industry and industry support mechanisms and universities and startup ecosystem? And the reality is it's not very easy. Finland is still the only one, because as you see in this landscape, they're a rare ecosystem that has almost the entire chain. They're doing hardware with like Vario and a lot of photonics and optics. They're also doing a lot of just core tools, and then end user platforms for industry and consumer. So Finland is not the easiest thing in the world to replicate if you're a country. But they're getting a lot of trade support and industry support, and they have the unique opportunity to have something like Match XR. Match XR is not the most well-known event, though it should be, if you're working with startups in the XR space, because it runs the day before Slush. And Slush is a major investor event in Europe. So when people say there's not a lot of investment in Europe, particularly for XR, it's usually because they don't know that this event exists. So you need to go to Helsinki if you're in that space. On the other side of the continent, we have Spain. And Spain's one of my favorites because as XR for Europe, we have members who are national associations themselves, and one of the most active and locally engaged at grassroots level is Immersive. So Immersive is working in Spain. Spain is a major export market. They're serving clients all over the world, in Europe, in the single market as well, but as you can see, taking advantage of their language. They're one of the few countries in Europe that's really exporting services into South America and Central America. Each one of these lines is from an industry research that we just closed data collection on that we're still working on to produce a final report to be produced or to be presented in Stereopsia this year. But each of those lines is one of their companies that has identified this other country as a major export source for them, for clients. So that's just, again, highlighting. Spain is not always recognized as a major XR ecosystem in Europe, but part of it's because so much of their work is not captured on the buy side in Europe because it's not buy side Europe. They are doing that, but a lot of it's going outside. And then on the other corner, very same story, but a much smaller country in Bulgaria. Bulgarian XR exists. It's pretty active, but they don't have a local market. Spain does actually have a local market as well as an international market, but Bulgaria does not. So they're totally exporting. And this was a research that we did, small scale, interview driven, less of a survey and more of a deeper dive interview. But they're really targeting things like the United Arab Emirates and Saudi Arabia and Asia, growth markets for them. They're looking outside of Europe more for their business, and they're coming from a gaming background. But, and there's a lot of countries like Croatia, Slovenia, a lot of the Balkans are very gaming oriented, and that's where their XR skill set is drawn from. And they're, again, really contributing a lot to their local economies through XR. And this is a snapshot. This is, every one of these lines is one country in Europe that is supplying, exporting services in XR, either products or services to some other country. So Europe is tightly woven in the whole global XR ecosystem. And that's not always very recognized, but that is the fact. We are exporting a lot, both internally and externally. And a lot of the importance placed on by the new commission coming in is to increase the connections within the single market. So just to briefly, XR for Europe, we are aware of this and we're following this and we're doing this research because our job is to support people in Europe who are working with XR, whether they are universities and researchers, whether they are creatives, whether they are SMEs, whether they are large industry. And we work with entities like the Commission on projects, Horizon projects like XR for Human and Openverse, and soon to be VR Health Champions on Tuesday that launches. So the previous, actually a couple different talks today are very interesting to me because VR Health Champions is about how to support healthcare XR startups to scale and to grow in Europe. So we'll be getting into that. So we do a lot of research, industry research. We organize a lot of panels and thought leadership for people to be able to come together and understand like what's going on in their country and their market, what types of other countries might be partners for them in some way. And then we support startups with programs like Impulse and working with Startup Wise Guys and the pre-revenue program for XR. Again, trying to connect people around the continent with opportunities. And we're not alone. We work with national entities. I already mentioned Immersive, but we also work with Immersive, the Irish association that's new. We actually have 3 members that are in Germany. We have XR Hub Bavaria, we have XRBB, which is Berlin-Brandenburg, we have EDF VR, and then we work with a number of others. So we try to be as representative as possible. Not every country in Europe has a representative body for XR, which is something we're looking to try to help overcome and help to support new ones in Poland, for example. And then we have peers who are also just very Europe-level focused, things like EuroXR, which many of you are probably familiar with, as well as OpenAR Cloud, Europe, Euroimmersive, and Foundation Metaverse Europe, for example. So we try to be everywhere. We try to work with partners who are more specialized in certain sectors and certain fields. But if any of you are interested to learn more about other parts of Europe and XR where you might find peers you haven't yet found, I'm happy to talk with you about that. So yeah, thank you very much. That's my talk, and I hope I didn't go over.
Thank you, Michael, for that overview of XR in Europe. Our next speaker, our final keynote, is Professor Skip Rizzo. He's a professor at University of Southern California, and he's going to talk about the evolution of virtual human agents and AI in clinical VR applications in mental health care. Skip, the floor is yours. Oh, he's going to get mic'd up, so he'll be here in a minute.
Alrighty. Is there a controller up here? Yeah. All right. First off, thanks to everyone and for being here and for inviting me here to speak. I just got in yesterday, so I'm a little jet lagged, but I think I can get through this, hopefully. So I'm going to talk about virtual human agents, but I'm going to start off by talking a little bit about VR and the context that we build to insert virtual agents and the evolution that's taken place over the last 30 years in the development of these virtual characters. Our work is at the University of Southern California Institute for Creative Technologies, and over the last couple of decades we've evolved the MedVR Lab, which is an interdisciplinary group of folks working in computer science, graphic arts, psychology, social work, medicine, all working together in an interdisciplinary way in order to come up with new ideas. And over the years, our work has focused on four major areas: psychological function, cognitive, motor, and of course, virtual humans. And just a little walk through history here. This is what some of this stuff looked like a few years back. An exposure therapy application for post-traumatic stress disorder, test for children that might have attention deficit disorder in a virtual classroom. Some early work that we did with motor rehab. We built our own little tracking system and made gamified rehabilitation for people post-stroke or traumatic brain injury. And our first virtual human agent, which you'll see a little bit later. The good news is all this stuff has evolved. And rather than being just one-off applications, they all evolved into research programs, so we could build on the research that we did in the early development and continue to evolve that work. So with that, the way I look at it is that the best metaphor in mental health and rehabilitation is aviation simulation. So just as an aircraft simulator serves to test and train piloting ability under a range of controllable conditions, we can test, train, teach, and treat human functioning similarly in VR environments where we have these exotic, controlled stimulus environments. And if you're a student of psychology, you'll get this, the ultimate Skinner box. B.F. Skinner had developed these little systems for testing rodents and pigeons on different learning challenges and so on. Well, we can go well beyond what the behavioral scientist B.F. Skinner did in VR. Now, in 1994, that was when clinical VR really got its initial traction with phobias, with exposure therapy, people with fear of heights. That was 1994, Barbara Rothbaum's work. Fast forward 30 years, and this is a short list of the areas, the clinical application areas where VR has been shown to add value either as an assessment tool, tool for intervention, or a tool for scientific research. Now, the one thing we learned right out of the gate with this stuff, with phobias, if you looked at that image, you would say, oh, it's very cartoonish. How would it, how could it ever be useful for any clinical purpose? It doesn't look real. Nobody will take it seriously. But we found early on that we could fool the brain, especially with people that had phobias. They were very primed to react to anything that had a whiff of what they were fearful of. But that a user could go into that environment, that plank bridge, and their frontal lobes are telling them, oh, it's just a simulation, it's not the real thing. But we hijack the brain, we fool the brain, going into the limbic system, memory, emotion, and so on. We activate that in spite of the fact the user knows they're not really walking across the bridge, and it doesn't really look that realistic. So that was one of the key things that we could find in the beginning, was that we could fool the brain and maybe leverage that for useful clinical purpose. Now, one of the takeaways with this talk is that, things have evolved. So this is actually, I think, 2016, Ritchie's plank, but it shows a fear of heights application where you have to walk out on a plank and rescue a little kitty cat that's on the plank, pits your fear of heights against your love of cats. Anyway, so you get an idea. Things have evolved, and that is one of the core messages, of course, with VR and with virtual humans. Technology has caught up with the vision. All the ideas people had in the 90s about this stuff, they made sense. They were theoretically informed, but we didn't have the technology to be able to really implement them at a high level. Now, commodity, consumer-grade hardware can do that job quite well. As well, the literature continues to grow. This is just a listing of VR from PubMed, so mostly clinical type applications. You can see the continued growth, but the science has evolved and it validates the vision. These are just meta-analyses from the last couple of years documenting where VR makes a difference for fear, for PTSD, for pain management, for rehabilitation, and some of the work with virtual humans. We have our own specialized journals as well that offer us other opportunities to speak to the closer-knit VR community. As well, clinicians weighing in on this. This is an every 10-year study that's done, a Delphi survey, and back in 2013, they asked clinicians, expert therapists, what were some of the areas where you expected next 10 years there was going to be a significant enhancement or growth in. And that, at that time, predicting to 2022, VR came in about 4th place out of a long list. They redid this analysis in 2021, and in this case, VR came in 2nd place. So there's growing appreciation that this has potential value from scientists, from theoreticians, but also from clinicians. So it's not like the old days where you'd have to twist a clinician's arm to buy the idea that this harebrained scheme of virtual reality was going to make a difference for their patients. So what about virtual humans? Well, similarly, compared to just general VR applications in the clinical domain, the literature has rapidly expanded. And there's just tremendous opportunities to publish on these things because, in a sense, we're creating experiences. That's what our job is, to create experiences, whether they're places or they're people to interact with. And that can be leveraged quite nicely for a wide range of clinical applications, as you'll see. And we'll start with the very basics, the very scripted or avatar-driven or even spherical video-driven stuff, where it's very scripted. There's no real AI involved in the mix. And so this was built in 1999, I believe, and when they finally ended up testing it, comparing people with panic disorder and agoraphobia with real-world simulations, with real people, very expensive and cumbersome to conduct, they found virtual humans did the job just as well. And you could do more trials of exposure, helping people to confront their fear by using simulation. Same thing with Stefan Bouchard's work a little bit later on, 2017, where for people with social phobias, and he used a cave-like experience to do this study. Again, they found that this was a more efficient and hence more effective way for treating people with exposure, with social phobia, because you could systematically ramp up the exposure to people under different contexts. And you wouldn't have to bring in actors or friends to, do real-world live role plays. Fear of public speaking, this is one of the easiest ones. All you have to do is, basically create a room like this and populate it with folks. These are some of the early days stuff. And it's one of the areas where it's pretty common. You can see applications all over the place, like XR Health's application here for fear of public speaking.
These results are promising. What impact do you think it may have in
You
the
can have a
future?
large room, a small room, more provocative questions like this.
Don't you think that your point of view has certain limitations? How did you choose your presentation's approach?
So you always get one of those. But this has moved along so fast that these are pretty much widely available to anyone. In fact, some clinicians are concerned that people might be self-treating themselves using these kinds of off-the-shelf applications. But I look at it, we give public speaking kind of a pass, even though it could be considered a clinical condition in extreme cases, because everybody's got it a little bit. You got to practice, you got to get over your fear. But these are all free and available, and there's some paid ones. But this has also opened up the door to movements where you can start to do self-help VR under the guidance of a clinician. So in this application from Dan Freeman in Oxford VR, basically it's a fear of heights application, but there's a virtual human that plays the role of a guide and guides you through all the exposure applications. So one first case of self-help where they send the headsets home with people and they monitor them, they keep track of them on, connect by phone, email, and they do the exposure at home. So a way to broaden the application. And I think, there's still a clinician in the loop that does a proper diagnosis and develops an optimal treatment plan. And you can get positive outcomes in this area. The next level up, though, is he did a study with an application called Game Change, which is basically a bunch of social contexts that can be populated with a varying number of people. And he tested it with people with schizophrenia, with psychosis, that have extreme agoraphobia. And again, so in some cases, these folks couldn't even leave their home to go to the clinic to do therapy. So setting it at home with the patient and having some connectivity with them, they're not just completely in the wild doing self-help, they found positive benefits with this particular population, although it's still kind of self-report research. I don't know if they really followed these people around to see how much they left their house after treatment. But again, a little bit of a movement in that direction. In our work with PTSD exposure therapy, a way to help patients confront and reprocess difficult emotional memories, particularly for Iraq and Afghanistan, but now Ukraine and other populations as well. We could systematically manipulate the number of characters of relevance in the scene. Sometimes people would be in a world where it was a vacant street. Other times for their specific trauma, it involved being around crowds. But these were basically props. You couldn't talk to them, you couldn't really interact with them. They were just there to add relevance and context to the scene and activate the emotion to help a person go through that process of confrontation and reprocessing of very difficult emotional memories. Now, another way virtual humans can be delivered, and they're not so much virtual, it's using spherical video. So an extension of the PTSD work was to create everyday environments that veterans are hesitant to go to, even though they pose no real threat. Because of their experience with PTSD, they're hesitant, again, like the agoraphobics, they're hesitant to go to places where there are people, where they can't sit in their preferred seat and feel safe and so on. So working with this company, Penumbra, we built out a whole variety of spherical videos that can be ramped up. You're basically in a barrel of video, essentially. But you can select different applications that have different levels of provocativeness. And this is now being tested at the VA hospitals in the United States. And to help patients that have difficulty leaving their home and being in provocative environments. have large crowd applications as well, sometimes with emotional disturbances going on in the space, very activating for some veterans. Okay, let's talk about a different application, autism. And with autism, you know, a lot of times these folks are actually quite talented and skillful, but they have a real problem with social interaction. So in the early days, 2002, Sue Cobb's lab started building out a bunch of social settings where people could interact with these, you know, again, relatively impoverished graphically characters. That might have been a good thing for folks on the spectrum because they have a hard time with complex social interactions. So this is a good stepping stone for scaffolding that kind of comfort and learning, a little bit of exposure therapy with social skills training. Now, we did an application that was more focused on high-functioning autism. And these are folks that actually are really talented. They can do a job, but they can't get through a job interview. They're terrified to have that social interaction. So we built out a set of simulations where you could have a person practice their role-playing with a virtual interviewer. And you could manipulate how provocative the interviewer was. He had a variety of characters. So in this case, you'll see this character in nice mode.
I'm glad you're here. In a minute, we'll get into some questions about the job. But before we do, why don't you just tell me about yourself?
So pretty easy. Then we could, you know, have somebody go through a bunch of interviews with characters in that kind of a mode, but then ramp it up over time. So you could eventually maybe get to this character, this job setting.
This is an entry-level position. I guarantee there will be things you won't like about this job. That said, what's the most important thing you think you're looking for in a job?
Now, keep in mind, these are all scripted. You know, we built it out so we could pick a variety of characters. We picked from a variety of characters, different age, ethnic background, gender, of course, and then put them in different job contexts. So you had a lot of ways to slice and dice this, to do this kind of training. And here's somebody who's gone through it, and then I'll show some data on the use of this application.
It's a good program, and it teaches you how to do an interview, and it teaches you how to be in an interview situation with another person.
And did you see your performance improve? Did you get better?
I get better every single time I do it. I get better.
So what that graph shows is the red bars are actual live interviews done before and after training with vocational experts, vocational counselors, and so forth. And they're rated on a scale in terms of effectiveness in their social and verbal interaction with the interviewer. And then the yellow bar shows systematic progression over 4 training sessions where they did multiple practice interviews and the average of each. And you see that progressive improvement on the app, but more importantly, you see that the skills transfer at the end to a real-world interview. And that's the key. That's the bottom line with all this, not just rating skills as to self-report and how comfortable you might feel if you're in that situation. In fact, we actually tested that out, and so it showed that what's learned in VR, in some cases, does transfer to the real world. Also, experimenting with AR. This is back about 3-4 years ago with the Magic Leap headset, and you can see the user is sitting there talking to an empty chair, but sees the virtual interviewer there.
My name is Grace.
We didn't really follow through on that. We made with the video AR that's possible in the Quest 3. We may do that. But right now, a lot of these applications can be done just as well on a laptop with a big screen. Sometimes you don't need to go full immersion. Certainly, we can deliver this in a VR headset, but the action is all up front. So if you can deliver something at a lower cost and hopefully evolve it with good science, so you know what are the things that challenge people or what are the things that give them helpful hints that they can more likely use in their everyday interviewing, then that's a real plus. A company that I think is doing very compelling work focused in the autism spectrum area is a company called Florio, and I want to show one of their applications I think is very
Florio is busy
important.
building more advanced training situations in virtual reality.
Can I talk to you a moment?
Yes.
This is Manoj beta testing the latest one, a police safety simulation. The police safety module is part of an NIH study in partnership with Children's Hospital of Philadelphia's Center for Autism Research. Florio started building the police safety module after an incident in 2016 where police approached an autistic man who wandered from his group home. The incident resulted in his caretaker being shot by the police.
We basically started building content to simulate what it would be like to have an unexpected encounter with law enforcement and start being exposed to some of the language that the officers would use in that interaction.
So, you know, kind of like the job interview, but on steroids, because there's a lot of issues around police encounters with special needs folks where sometimes police think they're drunk or they're having a problem or whatever, and it escalates like in that situation. So this kind of skill learning, and this goes back to early work in 2000, a woman by the name of Dorothy Strickland developed an application for kids on the spectrum, teaching them different ways to escape from a burning house or street crossing behavior and so on. So I think these are important areas to be focused on. But it's all very scripted again. So we're still in the beginning stages of the evolution. And, you know, this company is, I think is pretty good. They've got a lot of content, a lot of spaces built, and a lot of types of social interaction. Again, they don't have to be all that complex in terms of the visual fidelity in order to get the job done and foster the kind of learning engagements that can benefit these folks in everyday life. Another group that I have a lot of admiration for, they started off working with folks with autism, but they used an avatar-based approach using Second Life. So it was training social skills in Second Life environments, but very labor-intensive because they had to have, you know, providers, healthcare providers that were trained play the role of the characters in those environments. Well, in the early pilot work, they showed with just a small number of patients, and they did fMRIs, they showed that after this kind of training that there was higher levels of activation in areas of the brain that are thought to underlie social understanding. So with that, then they went on and did a larger study, and they got more money, and they built this out, which I think is, you know, pretty much state-of-the-art for these kinds of applications.
Here at the Brain Performance Institute at the Center for Brain Health, we're using virtual technology to help individuals learn social skills. Charisma is a name that we've given to our software program combined with the clinical application. It really is a platform that allows people to practice social skills in a safe environment and practice them in the virtual world, but the skills that they learn transfer into the real world.
We found that Charisma is a great tool for increasing social vibrancy, and part of why it's such a great tool is this virtual reality environment creates a safe place for people to explore different ways to interact socially, and they become more creative, more confident, and more enthusiastic about social engagement.
So the challenge there, of course, is it requires humans in the loop to play those roles. It's not scripted, it's, you know, avatar-based interaction. But they've gotten positive results and are continuing to do the work. And eventually, I think, like what Christina talked about with Spectrum Bar, if we start incorporating a little bit of AI into these things, we can have people practice by themselves, and we can expand the reach of these types of applications. Now, another avatar-based approach is work we're doing, and this is actually in Bucharest, but it's for Ukrainian refugees that have been dispersed across Europe. It's basically a spherical image of a popular square in Kyiv, and people can go into that world as an avatar and have social interaction in order to share their story. It's psychologists run. We're actually running a trial right now in Bucharest with this. But psychologists there, and it's a way to get social support and to share their experiences, share their hopes, their losses. And here's an example from one of the early pilot tests.
Нам о своем опыте переезда в Румынию.
Я приехала в Румынию со своими
These are all real people dispersed in different areas connected in this space.
Первое время было тяжело. Но я записалась на курсы и в ближайшее время...
So initially they talk a lot about mundane, everyday transition issues, but then as they get more comfortable, and it's easier to become comfortable when you're embodied as an avatar than if maybe you're in a face-to-face group. That's what we're testing in this trial in Bucharest right now. But I think that's one of the key things. Can we make it easier for people to have interactions by being represented as a virtual human or practicing their skills with a virtual human? This is another app, Mark Billingshurst's lab, and it's specifically same kind of concept, but designed around people with traumatic brain injury that may have speech problems or cognitive issues, and they can practice with characters like this. Again, very
I'm so
scripted.
Glad you could make it today. I need to go pay for parking. Go in and grab a table, and I'll meet you in there. So how was your morning?
Like an obstacle course, if you will.
Hey guys, sorry we're a little late. Roadworks is such a nightmare. Have you been waiting long?
Okay, and one more, and this is Gareth Walcomb's work out of Belgium for speech therapists for people with speech impairments like stuttering. And basically, what you see here is a control panel that a speech therapist would have, and a speech therapist is like the Wizard of Oz, picking picking the content, the places, the people, inputting. Well, here, let me just let it run.
Moments. We can also have ambient sounds like coffee machines or distractions like a phone going off. We can make them speak, so you choose the group that you had, and then press the name that you want, and then press the sentence that you want them to say.
Sorry, could you say that again?
And then they say it, so we can also type something in the top, and then the avatar will say that too.
Hi.
We can also translate the text to a different...
So basically, creating a control panel for a speech therapist to be involved in engaging the user in these types of interactions, not autonomous. So that brings us, well, before I go to there, a recent conference paper review documented the value of this technology in a large number. I didn't track all these down, but they're claiming 76 randomized controlled trials using virtual humans in some form for a clinical purpose and showing positive benefits in those areas. So, in any of the papers I have here, just send me an email and I can bounce them to you. All right, now moving on to the next generation of these things, and I'm going to focus a little bit more on our own work, is virtual human agents that have some level of autonomy that people can interact with, and now more and more fueled with different types of AI programming, if properly guardrailed, in order to make sure that you're giving people the proper kinds of information. So first one, very intuitive, just like the job interview, but instead a patient interview trainer, virtual patients. And this is a big area. There's a shortage of actors that can credibly play the role of a patient. This is a common practice in medical school in the United States. Clinical psychologists and social workers very rarely ever have the opportunity to role play with a real person. So when you look at this, think about psychology training, which I think would be very important. But our first virtual patient was 2007, and it was very primitive, but it addressed an important topic, sexual assault. So basically, this character had very limited gestures, hardly any differences in facial expression, and had a dialogue library of about 200 utterances that could be matched to common questions that a medical student in training might ask in the situation. Medical student was given an index card with a referral question. Patient doesn't want to leave her room, doesn't want to go back to school, won't tell the mother what happened, and that's it. And so here's an example. Even with this impoverished character, you'll see the transition over time of this medical student interacting and...
Hello, my name is Dr. Davis.
Hello.
What brings you into the office today?
Something bad happened that night.
I'm sorry to hear that. Can you tell me what happened?
I was in the car with Eddie and he stopped the car and wanted me to kiss him, but when I tried to stop him, he threatened me with a knife.
When did this happen to you, Justina?
So you can see in this application, he's starting to
I
get
was so
credible
scared. I thought I might
responses,
die.
and you'll see he starts to get engaged and pull out a little more clinical empathy.
It must have been very tough for you.
Yeah, it still is.
Do you find yourself still being bothered by what happened?
Whenever thoughts of the event pop into my head, I put my iPod on real loud.
You mentioned thoughts pop into your head. What kind of thoughts pop into your head?
I want to get away.
When you think about it, you feel like you need to get away?
That horrible time replays
So-
in my mind over and over.
He's illustrated a number of the strategies that a skilled clinician would implement in an interview like this to show some empathy, to do follow-up, to do reflection, things that oftentimes don't come natural, specifically in high-stress interviews like this. And so I think about my own clinical training as a psychologist. I spent the first year in graduate school taking courses in psychotherapy, maybe watching a video, maybe once in a while role-playing with a fellow graduate student. It was totally stupid and unnatural. If I had had in that first year a clinical caseload that I could access online and meet with every week, and with the proper level of sophistication, then I might have been a better clinician in the second year when I was actually being thrown into a clinic and actually seeing patients without any previous experience. And we also found that the types of questions that people asked in this setting were pretty much in line with the types of questions that they would ask a standardized actor patient. We went on from that and got a grant to do something with social work for the School of Social Work at USC in a program that focused on military social work. And in 2012, this was a big area because there were a lot of people coming back from Iraq and Afghanistan with psychological issues. And so this one revolved around suicide interviewing.
Good afternoon, Sergeant Castilla. What brings you in today?
Well, my wife told me she thought I should talk to someone. She's been pretty concerned about me since a soldier suicided on base last week.
Did you happen to know the soldier?
Yes. He wasn't a friend, but I met the Marine once or twice. He seemed normal at the time. I guess I'm afraid I might end up like him.
Do you have any plans to hurt yourself?
No. It certainly caught my mind, especially lately. I just need it all to stop. Sometimes I can't handle it.
So based on this work, we ended up getting more funding and were able to build out a virtual patient toolkit, which had a highly authorable front-end interface. We weren't just building one-off cases. We could give clinicians an opportunity to author cases that would then foster these kinds of training opportunities. And had a wide variety of different characters, could put them in different settings. We could adjust their weight class because that might influence elements of a clinical interview. And basically went from, in medicine, they always talk about see one, do one, teach one. Well, instead, you could do your practice in these types of simulations where there was no risk, no harm. People felt more comfortable doing it in this setting because they weren't being evaluated by their supervisor. The software was giving them feedback. So that reduced a little bit of the tension, and people could experiment. And sometimes there was coaches that would, automated coaches that would pop up and illustrate when somebody made an incorrect utterance and would need to change it. And that's what this had. This had a coach that would pop up, motivational interviewing.
Hey, how's it going?
Training system with a resistant client, didn't want to be in therapy.
I'm good. Look, this is my wife's idea.
And so motivational interviewing is designed to work with patients like this.
No offense to you, but heck no, I wouldn't be here.
So, convincing somebody that maybe they should get some help, that's part of the battle initially to get them engaged in therapy. So, we did a randomized controlled trial with this with 126 folks, and it was at a VA hospital, Veterans Hospital in the United States, where everybody did the 2-hour online training for motivational interviewing, and then the control group had an added 45 minutes of text-based training, and the experimental group interacted with the virtual patient for 45 minutes. Now, how do you measure success from that comparison? Well, what we did was, before they went into training, they did an interview with a live actor patient that was well trained in playing that kind of a role. And they did that before training, immediately after training, and at 3-month follow-up. Now, all of those interactions were recorded and then sent out to 5 experts in motivational interviewing that were blinded to what condition: experimental control, baseline, post-training, 3-month follow-up. They didn't know what was what. So you're getting pretty unbiased ratings, and there's a very structured rating scale for motivational interviewing. That's one of the reasons we picked that, because it's very quantifiable in terms of the types of responses you give, and essentially found that immediately after training, the trainees that were in the VR experiential practice group did much better than the traditional method, and it prevailed at 3-month follow-up. The interesting thing was when you asked people on a self-efficacy scale how good they thought they were at motivational interviewing, there was no difference. People in the control group thought they were great, as well as the people that actually were a little bit better. And so it's kind of like when you take continuing ed classes, you think you're certified in doing a certain type of therapy because you take a class, but until you get that experiential practice, to hone those skills, to really implement them, maybe you're not really getting up there, even though you may think you are. Okay. Now, shifting gears to virtual human support agents, we hear a lot about chatbots. Well, we built our first one in 2011, and this was for, again, with veterans. We had a lot of money during this era because of Iraq and Afghanistan. So this was designed to be an online character that veterans could go and talk to privately, anonymously, ask questions about PTSD, about substance use disorder, whole spectrum of things. And the character could also ask the user questions. And if the user, and these questions were thinly veiled screening questions for PTSD, anxiety, depression, and so on. And so if the user reached a certain level, character wasn't going to start therapy. What they'd say is, it looks like you're having some trouble. If you want, you can punch in your zip code here. I'll pop up a list of providers in your area. And if you want, I can answer questions about what actual in-person therapy might involve and what it would take. So it was a way to put a toe in the water, not as a doc in a box. And so this is what that looked like in 2011.
Well, I'm not a real person, if that's what you're asking. But I'm based on the personality and experiences of real soldiers and Marines. I'm still just a piece of software, but I'm getting better all the time. So hopefully I can be a helpful piece of software to talk to.
All right, so flash forward 12 years, meet Taylor. This actually was inspired a bit by Christine's Spectrum Bar robot character, where we said, we're going to start putting in a higher level of AI into these things. It's getting more possible. And in this case, this was designed for healthcare professionals that, because of COVID and other reasons, they may be on the edge of being burnt out or have compassion fatigue, secondary PTSD, and so on. So the character would interact with these folks, docs, nurses, regular healthcare workers, and do an interview with them and try to understand, what their issues were. And then the character could say, hey, why don't you, if you'd like, you can take the professional quality of life assessment. It takes about 3 minutes to fill out, and I can give you your scores and tell you a little bit about what this means, and maybe direct you towards self-help or where you could get help with another person. And it was particularly relevant in this population because, oddly enough, nurses and docs, in terms of occupations, have one of the highest suicide rates. And there's a stigma amongst people in the field to share their experience. So this was, again, similar to SimCoach, a toe in the water, and this is what that looked like.
Let's start by talking about your work life. On average, how many hours per week do you work?
This is all AI, voice, everything.
That's not easy. Generally, do you enjoy the work you do?
No, not anymore.
So she builds rapport.
I'm sorry to hear that. How well are you able to focus on your assigned tasks and duties?
And so she'll ask a few questions and then offer to pop up some assessments or see if the person just wants to do freewheeling discussion. Now, the question that always comes up with this stuff is, can people relate to virtual humans? You know, the uncanny valley that we heard about earlier today and other elements around engaging with an intelligent agent. So we wanted to test this with virtual humans, where we told one group, and it was sort of a quasi-clinical interviewer character, and we told one group that it was an avatar, that there was a person in the back room hitting buttons and interacting and driving the avatar interaction. The other group, we said, it's all AI. And in fact, it was all automated, not really a high level of AI. It was pretty scripted. But we told them there was no human loop. Both groups got the same thing, but we told one group there was a human in the loop. And what we found was when people thought they were just talking to software, they had less fear of evaluation, less worry about impression management. They displayed a higher level of sadness. And we tested a large number of veterans in this, about 700 people that went through this, majority veterans, so there was high levels of that. But most importantly was that people felt that they could self-disclose personal information in a safe way, and that's one of the privacy issues that were brought up in an earlier talk. You know, if you're going to do this, and there's going to be value, you have to have the user's buy-in as to where that information is going to go. If it's for direct feedback, that's one thing, but if it's going to go on some hospital record, that's an ethical violation, or to Google or whatever. So these are real important, but these were the kind of comments, and I want to just show one other little video here. And basically, we do a lot of virtual human work at our center, and these two folks had been in our study previously, and they were getting ready to participate in another study, and they were being filmed, and you can see the top-down view and the face-to-face view, a negotiation study with John Gratch. And this is a completely unsolicited statement about their experience in our work.
Have you been here before? The virtual human, is that the one you did? I think that's what she's doing. So they're probably seeing how two humans interact, and then how a virtual human. Yeah. I think it is awesome because it's a lot easier. I don't know why, but it's just a lot easier to talk to somebody like that than a real person, because I think you feel judged. You know what I mean? And all this other stuff. I can understand why they won't.
So, and in another case, we compared veterans that came back from Afghanistan. When they come back, they have to fill out what's called a post-deployment health assessment, which is a symptom checklist. And in the psych symptoms, most people just go through it and they check no to everything. You know, problems with sleep, problems with panic attacks. You know, no. So we compared the post-deployment health assessment, a number of psych symptoms endorsed, on the actual computerized version, that's on the left. And then we also compared, we had them do it anonymized, where they got a paper thing without their name, just a subject number. So they knew it wasn't going to be on their medical record. And then we compared that with a virtual human doing a conversational interview that slipped in some of these questions. Like, hey, so how's your sleep been since you've been back? And the person might pause and say, well, I'm okay, but I do have a nightmare every now and then. And it's about this event that I went through, and it keeps popping up in all of a sudden, they're revealing something that is pretty relevant for their mental health that they said no to on the checklist. Anyway, we found higher levels of symptom reporting, both for the computerized version and the anonymous version. So even though they thought it was anonymous, it was almost like habit. They go through and check these things off, no. But it came out in the interview. So the final one I want to talk about is Battle Buddy. And this is one where we're moving virtual humans to a mobile app. And Battle Buddy is a term used in the military for a person that's assigned to you back and forth as somebody to keep an eye on you. Somebody, if you're having troubles, they can be there for you and all that. That's Battle Buddy as a real person. So our thing, we got funded to build out a mobile app that served that same purpose, where it could do daily check-ins. I'm going to let him describe it, but can do all that stuff in your pocket all the time, has modules for self-help, and also invoked a suicide safety plan, which is a very structured and evidence-based approach for reducing suicide, helping people recognize the triggers, come up with options for how they can distract themselves or how they can deal with it, and instant calling to family or instant calling to a veteran support line. Anyway, let me let him describe. We integrate an Apple Watch or a Fitbit as well to track that stuff.
Hello there, and welcome to Battle Buddy. My name is Kevin, and I'll be guiding you through our vision for suicide prevention and wellness. In addition to daily check-ins that focus on mental and physical well-being that can leverage data from a companion Apple Watch or Fitbit, I can make coping strategies easy to access, queuing up music, a book, or a route for a calming walk. We could also play a game of Wordle together. If there are friends or loved ones who can help, I'll have access to their contact info, and I can help the veteran make that call or send that text. And of course, if the veteran needs professional help, I can connect to emergency services.
So that's a general overview of what and this is only a year in development at this point. Now, examples of different types of content that's available, and the fact it can track your sleep, your activity level, and leverage that in the interaction between the user and the agent. But now we're at the point we've built out a ton of content, but we don't have a deep level of AI. And it was always our vision that we were going to partner with industry to do the AI component. And so I'm going to show you our licensed partner now, Sidekick Wellness, and a nonprofit support group, Soldier Strong, that's supporting it. And in the year where we're developing all the different types of content and different ways of delivering it, they've been working on the AI component. So here's a version of their app where the user is in the middle, but you don't really see the user. The sidekick, their support agent, appears on the left, and then there's other sidekicks that can pop in for more specialized, like you got a team of people that can help you. So here's a little bit of an example of a natural interaction from the user who's fixed in this and the sidekick.
Now, can we take a look at my mental health benefits?
That's the
Definitely.
user.
You are eligible for mental health benefits through the VA Care Network. If you're in crisis, you can call the crisis line anytime. Otherwise, you can schedule an in-person meeting, have an online appointment with a counselor, talk with a care coordinator whenever you want, or do some whole health exercises like meditation. This short video gives a good overview of the VA's approach to
And then another question where the character can dig up information from the web as relevant and well vetted.
I've heard the VA is using virtual reality to help with mental health. Any chance you can find some information about it? Of course. Give me one moment to see what I can find. No rush, thanks. Here's a video about what the VA is doing with virtual reality.
VA wants to transform the way that we deliver care and the way that veterans experience care. One of the ways that we do that is through immersive technology like virtual reality and augmented reality. We know with these technologies, we're able to engage the whole patient, physical, mental, spiritual, and emotional.
So the key here is we know that mobile apps, oftentimes in mental health are really well done. They've got all the information well vetted, but they don't stick. There was a study I saw recently where the median number of times that people go back to a mental health app that they're not paying for after they've downloaded, installed it, and tried it once is one time. So our view is that if you develop a character that gets to know you, that can engage you, that you have a dialogue with, that maybe these things will stick, and maybe you'll come to trust these agents in ways that can fill in a gap when there isn't a real person involved. Now, we're partnering with this company. They're basically going to be the central nervous system of Battle Buddy and all the connective tissue, because it was, in the span of a year, there's just a lot of issues working with AI that in a clinical application you have to be careful with. So they've already got the start. They're partnering with us. And the next app for this isn't for veterans. It's for maternal health, particularly maternal health in populations that don't have access to a lot of health, where the application can run all during pregnancy, and it can track things like heart rate, temperature, whatever, give tips for what's going on. And then after birth, perhaps that woman runs into trouble. Or maybe there's a highly stigmatizing condition like postpartum depression, where most women don't even want to tell their husband what they're going through because of the stigma level around it. This is where I think an agent can pop in and be a positive force towards engaging people. And maybe that in that engagement, it makes it easier for them to engage with real people to get the help.
No one should ever have to face their toughest moments alone. Everyone deserves a non-judgmental friend that is there when they need them the most. That's what I'm here for. I won't let our vets down. Together, we're stronger. I'm a friend, a partner, a buddy. I've got your six. I am your battle buddy. Thank you for your time.
So this comes to the end here where, some of our work, and I wanted to put in Quantum Bar as the inspirational piece for the direction we're going to meet Taylor and a few other apps. But we're seeing all kinds of applications where ChatGPT and other AI systems, large language models, are brought to bear and are remarkable. It's scary how good they are. I routinely use it, not just for generating images, but maybe the start of writing up an article where I want to make sure I've covered a wide range, and it pops up things that I should cover. A lot of things. I don't want to reveal my soul here, my dependency now on ChatGPT, but it's happening. But anyway, that brings up the question, and I don't think this video is going to run. Can you turn this off and restart the PowerPoint, because I think the cache is loaded from too much video, and I'll describe what's going to happen here. I want to, as this pops up, you have to jump out of the PowerPoint and then hit it again and start it up and go back to the slide, and the video should pop up. And basically the idea is, how far are we away from virtual therapists? I mean, what we've talked about already is healthcare support agents, filling gaps, making stigmatizing conditions easier to talk about. But the World Health Organization estimates that about 1 billion people are walking the planet right now that have some form of mental health condition, of which fully 2/3 will never see the inside of a therapy office. And so there are gaps to accessing care. So traditional therapy, is that the way we're going to be restricted to? Or what about this? Oh, shit. Oops. Well, it's not going to run. But basically, it's a virtual human therapist that pops up, and it starts to engage someone in dialogue. And the point I want to make is there's a lot to be said about this. It's always available. Encyclopedic knowledge of every evidence-based treatment, as well as encyclopedic knowledge of diagnostic conditions. It remembers everything you said to it. It can sense your behavior, track your Apple Watch, your Garmin Watch, whatever. It never gets bored. Therapists do get bored sometimes. The big challenge is, well, there's a lot more in therapy, and we do know that therapy, a large percent of the variance of that predicts outcomes is based on the therapeutic relationship, the alliance in therapy, the empathy, the idea of talking to another human that may have a shared experience that's different from a piece of software. But at least on the empathy front, you know, ChatGPT in a recent study has shown in unbiased raters of responses to healthcare questions that it was more accurate and had a little bit more of an empathetic tone. So can we bring all that to bear and replicate a clinical relationship? I'm more cautious. I think we use AI for decision support for now and learn more about how we can leverage it. And hopefully, in that way, we can make healthcare more accessible, more available, and more effective for a wider range of folks. So with that, I don't want to skip that. That's a deep fake. Conclude, you know, we're not saying we're going to replace clinicians yet. These are all tools to extend their skills, to maybe increase efficacy. And we want to be very careful because societal impact is relevant. Do we want our kids to have a positive vision of the future? Or do we want to have a Ready Player One world where the reason people retreat the simulations is because it provides a better world than how messed up the world might be that we've created? So something to think about. And with that, I'm done. Thanks.
Thank you, Skip. It was amazing to have you here in real reality.
Yeah.
Well, yeah, I guess, ladies, gentlemen, I mean, the second VR Summit is over. Well, at least for us, the conference part. The hackathon is about to begin, and the participants will have like 24 hours of coding on a very exciting challenge. But before we get there, I would like to say thank you to a few groups of people. First of all, our amazing speakers, some of whom took like, well, a long time to get here, especially those coming from overseas. Second, I would like to thank our sponsors, especially GTEC, United, and Snap for funding the prize for hackathon winners. Then I would like to thank our amazing team, especially Sophia and Rusty, who were continuously busy responding to all requests from speakers. I would like you guys to come on stage. I want all these people who knew you from emails. I would like them to see your faces, to see that you exist. You're not AI generated. Then I would like to thank Sebastian. I would like to thank Sebastian for taking care of all the hardware-related things, and he still has a long night ahead of himself. I would like to thank Kirill, our IT specialist. I mean, you guys, come on stage. I mean, like... And last but not least, I would like to thank Michael, the head of the hackathon, who is responsible, like solely responsible for organizing this amazing event together with his team that, well, part of the audience will now be busy with. So, thank you all for coming. See you next year. Now, an important announcement. So, hackathon participants, you are kindly asked to pick up your badges back there and then slowly move over to makerspace so that we avoid delays. You can follow Michael and Sebastian because they will, well, guide you throughout the rest of the night. All the rest, you guys can stay here for like half an hour, 40 minutes, mingle, talk to your, well, long unseen friends. And also like, oh, by the way, exhibitors, guys, you just take your stuff. Whatever is left here is gone tomorrow. Thank you.